elective mathematics, additional mathematics, further mathematics. Whichever name you choose to call this particular subject, the students that are attempting this in their exam knows that this is a hard nut to crack, but the story is going to change, because with this video from DaveTuts Academy, we are going to demystify all of the topics that are featured in this particular exam, because we'll be walking you through 3 different examination papers, particularly the theory paper, for you to have a very good understanding of what to expect from the exam. And not only that, you can also go ahead, face the exam boldly, and make that excellence that you are gunning for. We want you to just sit down, get set, get ready. Let's walk along. It's as you do that you build proficiency in preparing for this particular exam. We really appreciate that you support what we are doing at DaveTuts Academy. So don't forget to like, don't forget to subscribe. You can leave your comment for us to have feedback, and for us to be encouraged to do more. We appreciate if you can just give us a super thanks from YouTube, or just support us by buying us a coffee. It will really go a long way to encourage us to do more. Our work is set out for us. We are going to demystify further mathematics. Let's go ahead.
Here in this question on indices, we'll have to simplify 625 raised to power 3x over 4 minus 1 plus 125 raised to power x minus 1 all divided by 5 raised to power 3x minus 2. So what we need to first take note of is that looking at these numbers that are actually the base for this question, we can see that there are multiples of 5. Like in the first case, 625 is 5 raised to power 4. So we can have that power in bracket as 3x over 4 minus 1. Okay, then this plus 125 itself is 5 raised to power 3. Okay, so we still have x minus 1, and then we have this denominator, so we can say it's divided by 5 raised to power 3x minus 2. I can take a step further to say, in the first entity, I want to open up the bracket, so I can have this as 5 raised to power 4 times 3x over 4 minus 4 times 1, okay, plus 5 multiplied by 3x minus 1, okay. If I say I will open this bracket here, I will say I have 3x, then 3 times minus 1 is minus 3. Okay, so all of this, still have the denominator standing intact. So this is 5 raised to power 3x minus 2. So if I are to open up this, you can see that 4 here can cut 4 here. And what we will have eventually is that we have 5 raised to power 3x, then minus 4, because minus 4 times 1 is minus 4, then plus 5 raised to power 3x minus 3. Okay, this is being divided by 5 raised to power 3x minus 2. So now this is where students will make mistake. Students will have the tendency to say, yes, in these 2 entities on the numerator, I can just factor out 1, 5, and then I can add all the power, and you are going to get it wrong if you do that, because look at this sign. This is not a multiplication sign, this is an addition sign. And in that case, what are we going to do? We can see that in those 2 entries at the numerator, we can factor out 5 raised to power 3x minus 3. So what we are going to have is something like this. Now this is 5 raised to power 3x minus 3. Now this is how we factorize. In the first case, we are taking out 5 raised to power 3x minus 3. What is remaining? We still remain 5 raised to power minus 1, because if we multiply 5 raised to power minus 1 with this, the minus 3 and minus 1 will constitute minus 4. So we are on track. Okay, then plus, looking at this particular case, you can see that the whole of that entity is what we have factored out. So it's only 1 remaining here. Students, I hope you get this. Once you miss this step, there is no way you can really get this question again. Okay, so divided by 5 raised to power 3x minus 2. Okay. So now in this particular case, even look at these two. They are quite similar too. So you can say, okay, instead of just saying I want to factor out, I can say this that I have here is nothing but 5 raised to power 3x minus 2, okay, multiplied by 5 raised to power minus 1, because if I take only one 5, I can solve this to say it is now a singular 5 raised to power 3x minus 3. That minus 3 is the addition of minus 2 and minus 1. So this expression and this are quite the same. I'm doing that because I'm going to divide with this denominator that I have. Then I have what I have here in bracket, and 5 raised to power minus 1, which is the same as 1 over 5 plus 1. Okay, then we have the denominator as over, what do we have here now? 5 raised to power 3x minus 2. You can see why I was factoring that out, because this entity and this entity, they are going to cut. So what I'm going to have is 5 raised to power minus 1 is 1 over 5, that is this entity, multiplied by 1 over 5 plus 1. Here I can find the LCM to say that is 5. So here 5 can go in 5 1. 1 times 1 is 1, plus here is as if we have 1 over 1. So 5 divided by 1 is 5. 5 times 1, this is 5. Okay, so this is going to be 1 plus 5 is 6, and 5 times 5 is 25. And you can see how our attention to details have been able to enable us to see that what we have here is a positive sign. Okay, and initially when we have opened up the bracket, we can see that we can factor out 5 raised to power 3x minus 3, and you could have chosen to factor out 5 raised to power 3x minus 2, so that from both numerator and denominator straight away you can cancel out and then solve to arrive at your answer as 6 over 25. All right. In this question, the equation of a line, we are asked to find the coordinate of the point which divides the line joining point 7, minus 5 and point minus 2, 7 externally in the ratio 3:2. So we need to know this. We have to divide the line externally. So we are looking for a point in which, if we bring it to the line joining this 7, minus 5 and minus 2, 7, that point would divide the line joining these 2 points in the ratio 3:2. So I want to present a graphical view of how this is going to look. So here you can see I've located the point 7, minus 5, and I can tag that as point A here. So this is point A, and then the point minus 2, 7, I will say this is point B. And now we are looking for another point which will divide the line joining the two of them. So first, let's get that line. You can just go to point A and draw a straight line. Okay, so that's the line joining the 2 points. But now we are looking for another point which is going to divide this in the ratio 3:2. So to divide this line externally in the ratio 3:2 means that we are going to have something like this. Between the point C and the starting point, which is A, that's going to be a 3-fold division. And then between the point C and the second point, this is going to be a 2-fold division. So this is like 3:2. Okay, so in that case, we will say from here, from C here down to A, so you can have this as M, which is 3. That's why we have ratio 3:2. And then from C to the second point B, if we just note that from B here to C here, that will be N, which is 2. So this is the way to externally divide a line. So once we understand this, we can now use the general formula that is used to divide a line in the ratio, as we're given here that the coordinate of point C will be M multiplied by x2 minus N multiplied by x1 over M minus N. That's going to be the x coordinate. Then for the y coordinate, we have it just symmetrical like that. M multiplied by y2 minus N multiplied by y1 over m minus n. Okay, so this is what we ideally will use to solve for this particular question. And from what we have been given, we are told that we can see that m ratio n is 3:2. So m is 3 and n is 2. Then the coordinate of our first point A, okay, which is x1, y1 is 7, -5. That is the starting point, okay. So this is 7, -5, this is -5. Okay, then the coordinate of the point B, which is the second point, that's x2, y2, that will give us -2, 7. Okay, so having this, we can just substitute in the equation to have C to be, what's the value for m? That is 3. x2 is -2, so 3 times -2, then minus n is 2, multiplied by x1 is 7, okay, over m minus n, that's 3 minus 2, for y we have m, which is 3, multiplied by y2 is 7, minus n, which is 2, multiplied by y1 is -5. So then don't forget to put in your sign. It's not 5, it is -5, then divided by m minus n, which is 3 minus 2. So if we have this, we can just evaluate. 3 times -2 is -6, -2 times 7 is -14, over 3 minus 2 is 1. So that's the coordinate for x. And here 3 times 7 is 21. Then -2 times -5, the negative signs will multiply each other to become plus. 2 times 5 will give us 10, over 3 minus 1, that is 1. So this is -6 minus 14 is -20, and we're having 1 as the denominator. 21 plus 10, that is 31, and we're having 1 as the denominator. So the coordinate of C, okay, that's going to divide this line externally in the ratio 3, 2 is equal to -21, 31. So that's the coordinate as we are asked, and you can see it is just, yes, the x coordinate is moving more in the negative direction. Here you can see in the negative direction, and the y is moving more in the positive direction. So we are quite on track, and this is how we divide the line externally as given in this type of question. All right. In this question unsolved, we are told that without using calculators or mathematical tables, we are to evaluate 2 over 1 minus root 2 minus 2 over 2 plus root 2, and we are to leave the answer in the form p plus q root n, where p, q, and n are integers. So we are going to be doing that, and the very first thing we can do looking at this expression is that we can find the LCM, which is going to be, in this case, the product of the two denominators that we have there. So if you have our line there, we can say we want to find the LCM as a product of 1 minus root 2 multiplied by 2 plus root 2. Okay, then for the first case, in the first entity, if we look at this denominator and we use it to divide this, it will remain this other entry from the second entity. So we'll have 2 multiplied by 2 plus root 2, then minus 2, just like we did in the first case. Here, if we divide this denominator by 2 plus root 2, it will remain 1 minus root 2 multiplying these 2. So we have 2 multiplied by 1 minus root 2. So this is what we just need to evaluate. First, for the numerator, we can open the bracket. 2 times 2 is 4. Then 2 times root 2 is 2 root 2. Then here, we should note that this negative sign is multiplying all of the entities in this particular expression. So we have minus 2 times 1 is minus 2. Minus 2 times minus root 2. The negative signs will multiply each other to give us plus. So 2 times root 2 will be 2 root 2. Okay, then we'll still have our denominator to express. And here we can open up the bracket by multiplying entity wise. 1 times 2 will be 2. Then 1 times root 2 will be root 2. Then minus 2 times 2 will be minus 2 root 2. And minus root 2 times root 2. When you have a square root, Okay, here we are using 2 and we are multiplying it by each other, meaning that we are squaring it. This is the same by the law of indices, is 2 raised to power 1 over 2, then this 2 times 2. So the 2's will cut out and this will be 2. Okay, we need to know this so that we can apply it here. So that's one of the rules of indices that normally help us to solve questions like this effectively. So in that case, this last entry will be minus 2. All right. So looking at the expressions there, we can see that 2 minus 2, that will be out of the equation, so that we are going to have here 4 minus 2 will give us 2, then 2 root 2 plus 2 root 2 will give us 4 root 2. Then we can divide this by what we have as the denominator. So here root 2 minus 2 root 2 is going to give us minus root 2. It's as if you're having x minus 2x. So x minus 2x is going to give us minus x. So x can be taken as root 2 in this case. So we have root 2 minus 2 root 2 is going to give us minus root 2. So once we have this, we can now say we want to further work on it. Say, since we are told to express it in the form p plus q root n, so we can find the conjugate of this by multiplying both numerator and denominator by minus root 2. So I'm going to have 2 plus 4 root 2 over minus root 2. But I want to multiply it by, okay, I can just say let me multiply by root 2 over root 2. I have expressed this initially before, that this is going to give me just 2. I'll just note the negative sign. So that is going to give me 2 times root 2 is 2 root 2 plus 4 times root 2 times root 2, okay, over minus root 2 times root 2. And I've expressed that when you are multiplying root 2 by itself, that's going to give us 2. So this is going to give us 2 root 2 plus 4 times root 2 times root 2 here will give me 2, okay, divided by here root 2 multiplied by root 2 is 2, so we still have the negative sign, that's minus 2. So if I can just break it out, that will give me something like 2 root 2 over minus 2 plus 4 times 2 is 8 over minus 2. So the final answer after having expressed all of this is going to give me minus 2 can cut 2, so I will have, okay, that will be minus root 2, then 8 over minus 2 is minus 4. But if I want to write it in this order, p plus q root n, that will be minus 4, okay, minus root 2. So this is going to be the final answer to this question that we are asked on SOD. In this question on arithmetic progression, we are told that how many terms of the series minus 3, minus 1, plus 1, and so on will add up to 165 degrees. Now, to look at this question holistically, we need to notice that we are being given the set of values of this particular series as minus 3, then minus 1, then plus 1. And if you look at this, we need to get the next set of entries, and if we add up everything, the sum will be 165. Now, there are some things we can observe from here, like the first term a, this is the very first term, is minus 3, so a is minus 3. And then the common difference is the difference between the subsequent terms and the initial term. Like in this case, it will be maybe minus 1 minus minus 3, or it can be 1 minus minus 1. Okay, in both cases you see that minus 1 minus minus 3, these two negative signs will multiply to become plus, so we have minus 1 plus 3, and that's going to be 2. Or in the second case, this same d, you can say it's 1 minus minus 1, minus multiply each other will give us plus, so 1 plus 1, that is 2. So the first term is minus 3, the common difference is 2, and then we are told that the sum up to a particular term Sn is 165. So what we have to find is to find the number of terms that will add up to this 165. Now the question is, what is the formula for evaluating the sum of some terms in an arithmetic progression? That sum Sn is given as n over 2 multiplied by 2a plus n minus 1 multiplied by the common difference d. So this equation is what we can use to actually solve for n, because like here we're giving Sn, n is what we don't know, the number of times, but the sum of that number of terms had been given as 165, so we have 165 is equal to n, which we are looking for, over 2 multiplied by 2a. A is minus 3, so we have 2 times minus 3 plus, again we don't know n, so we have n minus 1 multiplied by d. And what is our d? The common difference, that is 2. So we just need to open up this and solve appropriately. If 2 is multiplying 165, that will be 320, then 10, 330. So we have 330 is equal to n multiplied by 2 times minus 3 is minus 6, then plus 2 times n is 2n, minus 1 times 2 is minus 2. Okay, so here we can say we want to open that bracket, and we have 330 is equal to okay, we can still solve this. N multiplied by 2n, yeah, minus 6 and minus 2 we add up to be minus 8. So if we just move all of this to the only one side, I can have 2n times n will be 2n square, okay, then n times minus 8 will be minus 8n, okay, then 330, if it comes to this side, it will become minus 330, and the sum of all this will give us 0. Now, this is looking like a quadratic equation, but we can simplify further by dividing each of the entities by 2. So if I do that, I will have this to be this beautiful quadratic equation as n squared minus 4n minus 330 over 2. 2 in 3 is 1, 2 in 13 is 6, and 2 in 10 is 5. So this is a quadratic equation that we can solve with whatever method we find appealing to us. And here I want to look at 165n squared, and I want to look at, okay, minus 165n squared, and I want to look at minus 4n. So to solve this, I need to look for two terms that I can multiply to give minus 165n squared, and when I add them together, I will give us minus 4n. So if I'm looking at 165 as a number, and I want to just find all the factors of that, I can divide, okay, I think 3 can go. 3 in 16 is 5, remaining 1. 3 in 15 is 5. So 5 can go in 55, that is 11. 11 can go in 11, that is 1. So I'm having these entries. What I can do is I can try to look at the combination of this in whatever format that can be suitable. So if I take 3 and 5, the product of the two, that's 15. 15 and 11, I think this is giving us something worthwhile. Let me clear this board. So I can say I want to look at 15n and 11n. And no, now if I'm taking the negative of one of them, then the product will give us a negative number. But looking at this sum, which one should we take the negative? I think it should be 15 that should take the negative, because minus 15n plus 11n will give me minus 4n. And if I say minus 15n times 11n, that will also give me minus 165n squared. So I'm on track, and I can say for this particular expression, I can write it out as, now I can say n squared, but instead of writing minus 4n, I can just say minus 15n, okay, plus 11n minus 165 is equal to 0. You see, it's consistent because minus 15n plus 11n is actually minus 4n. So I can solve for that to say, in the first case, n is common to both. This will remain n minus 15, okay, then plus 11, and this will also remain n minus 15. This is equal to 0. So looking at that, I have two factors, n plus 11 multiplied by n minus 15 is equal to 0. So taking these two is either n plus 11 is 0 or n minus 15 is 0. And looking at this, in this case, n is equal to minus 11, and here n is equal to 15. But we are looking for the number of times, so definitely n is minus 11 cannot be the correct answer because it's negative. The number of times have to be an iterated value starting from 0. It cannot be negative, so our solution is that n is equal to 15. All right. In this question on trigonometry, we are told that if sine x is equal to p minus q over p plus q, where x is an acute angle, and that is why it is defined as being between 0 degrees and 90 degrees, we have to find 1 minus tan square x. So what we are going to do here is to ensure that we make use of the trigonometry identity SOHCAHTOA. So SOHCAHTOA is going to be quite useful for us, and here particularly we are making use of the sine and the tan. Now originally sine x, since we are talking about x, is opposite over the hypotenuse, as seen here. This is so opposite over hypotenuse, and from the question we are told that this is p minus q over p plus q. But that means that we know that we are to define the triangle, we can find the three sides of the triangle from here. If we say this is angle x, then the side facing it is the opposite, and that was given as p minus q. The side facing the right angle, which is also the longest side, is p plus q as given. But for us to evaluate tan is opposite over adjacent, so we need to find the adjacent. Okay, so if we call that adjacent m, then we can use the Pythagoras theorem to find the value of m. We want to use the Pythagoras theorem. That means that we can say that the square of the hypotenuse, which is let me just use red ink, which is p plus q raised to power 2, that's the square of the hypotenuse, is equal to the sum of the squares of the two other sides. So we have this will be p minus q raised to power 2 plus m raised to power 2. So if you make m the subject of the formula, we'll have m raised to power 2 is equal to p plus q raised to power 2 minus p minus q raised to power 2. Now we can say we want to start opening up this bracket and try to solve this particular expression for him, but there is the difference of two square equation that we know that if you have a square minus b square, this can be evaluated by saying this is the product of the sum of the two numbers and the difference between the two numbers. So this is what we are having as the difference of two squares. A square minus b square is equal to a plus b multiplied by a minus b. Okay, so if you want to use that here, p plus q will be synonymous to a, p minus q will be synonymous to b. So we can say in that case m square, m raised to power 2 is going to be first p plus q plus p minus q, that's the sum of the two numbers. Okay, then multiply by p plus q minus p minus q. So this is the difference between them. This is the sum of the two numbers. Okay, so if you want to find this, we will say this is equal to, now let's be quite observant, p and p will be 2p, but look at this, this is q and this is minus q, so those we have known that. So we have, in the first case we have 2p. Okay, then here in the second case we have p plus q minus p minus q. So this is going to be, here this p and this minus p will be out, but q minus q will turn to q plus q because the product of two negative signs is a positive sign. So it will be q plus q, and that will be 2q. So here we have 2q, such that our m square is 4pq. And if that's the case, then m will be the square root of 4pq, and the square root of 4pq we can say is, square root of 4 is 2, and pq we still have in the square root. So that's what we are going to find as the adjacent for this particular triangle. However, what we have to find is 1 minus tan square x. So we can say tan x with all that we have been saying, which is opposite. Tan is opposite over adjacent. So this is opposite divided by the adjacent is going to give us, where is the opposite that we have? It is p minus q we have been given originally. Okay, divided by what's the adjacent? 2 root pq. So for us to find 1 minus tan square x, 1 minus tan square x will be 1 minus p minus q over 2 root pq raised to power 2. So we can just say we want to express this. We can have this as 1 minus, we still have P minus Q as the numerator raised to power 2. But here, the square of 2 root PQ, if you look at, that is the m that we are coming from before. Okay, this is m, and m raised to power 2 is 4 PQ. So we have this as 4 PQ. And with this, we can say we want to find the LCM. And this will be 4 PQ minus P minus Q raised to power 2. Okay, so we can open up that bracket to say we have 4 PQ, and here this is also 4 PQ minus P minus Q multiplied by P minus Q. But now, let's just be careful with our sign, because this negative sign is going to affect the whole of this entry. So this will be 4 PQ that we have here minus, now P multiplied by P is P squared, P multiplied by minus Q is minus PQ, but we're also going to have another minus Q multiplied by P, so we have minus 2 PQ, then minus Q multiplied by minus Q, the negative sign will multiply to become a positive sign, and then we have Q squared over 4 PQ. So our work is almost done, because here we can just see that this is going to give us 4 PQ minus the whole of this. If you are to open the bracket, we can say this is going to give us 4 PQ minus P squared. This minus and this minus will multiply to give us plus 2 PQ, okay? Then this minus and this plus will be minus Q squared over 4 PQ. And now our final answer, after all has been said and done, we can see that 4 PQ and 2 PQ can add together to give us 6 PQ, okay? Then we have minus P squared, then again minus Q squared divided by 4 PQ. So this is going to be the value of 1 minus tan square x as requested in the question. Here in this question, the resolution of forces, we are told that 3 forces, 10 newtons, 14 newtons, and 16 newtons, acting on a particle, keep it in equilibrium. So we need to note what that is going to mean for us. But our question is that we have to find the angle between the forces 10 newtons and 16 newtons. So we are to start just like the way they ordered it. We are to, now here, this is the 10 Newton force, okay? And then incline at some angle to it is the 14 Newton force. Then we have the 16 Newton force going to be a counter force that nullifies the effect of those two forces. Then we are going to have their direction like this. In the first case, this will be the 10 Newton force. Here, this will be the 14 Newton force. But in the opposite direction, now you can see this going like this in the positive direction, here in the positive direction. If we add that 16 upward, then it will have to act like this, and that resultant force will not be what we are looking for. We want it to cancel the resultant effect of the 10 newtons and the 14 Newton force, so that will need to come like this. So this is actually going to be the 16 Newton force, okay? So this is what we have, and to solve this particular one, we can make use of the parallelogram law of vectors to say we want to complete that diagram. And let me just show that quite faintly. And just say we want to complete this diagram by drawing something like this, and then just completing it like that. You can see this is just already looking like a parallelogram. So we can say we want to find some angle, whatever angle we can find suitable. Maybe I think this is looking very good. We can find this as angle theta, and we can try to solve for the theta. So we want to look at the effect of the forces at a point. So if you say this is the particular point that we want to find the emanation of each of those forces, we can say the 10 Newton force is acting in this direction, which is quite consistent with what we have initially. But the 16 Newton force, we need to actually pull like this in the other direction. So what we have inherently is that this is the 16 Newton force, and here this is the 10 Newton force. So this particular location here, this region here, is going to be the angle between the 16 Newton and the 10 Newton force. And if that is the case, this angle that we are looking at is not going to be accurate. It is obtuse. It has to be greater than 90 degrees, because by solving this particular question, we are going to get theta, but that theta is not going to give us our answer. So from here, it's as if we are moving the point of action of the force to this particular location, such that the 10 Newton force is acting here. So that you just need to understand this to be able to get this question effectively. So it's as if we are having this as the 10 Newton force. You can see I just knew it. But then emanating from that same point as the 10 Newton force is the 16 Newton force. And the angle that we are interested in is going to be this particular angle here, which we can see from the diagram that angle alpha, okay, this alpha here, we can see from this diagram that theta plus alpha is equal to be 180 degrees. Why am I saying that? Because they are the angles that are included in a transversal and two parallel lines. We are going to see the parallel lines here now. So here, it is the 10 newtons. This 10 newtons is parallel to this particular 10 newtons that I have here. And you can see the question that we are asked to find is to find the angle between the 16 Newton force and the 10 Newton force. So it's going to be this angle here, and that will be the correct solution to our question. And in that case, if you are to do that, that means that here we can just say our alpha that we are looking for is going to be 180 degrees minus the value of theta. Okay, so the question before us first and foremost is to find the angle theta. And looking at this particular diagram, you know this is looking like a triangle in which we know one of the sides, we know the three sides and one of the angles, and with that we can use the cosine rule. So using cosine rule can effectively help us to solve for this particular unknown angle. And we can just say here 14 is the side that is facing that angle. So the square of 14 is equal to the sum of the square of the other two sides, 16 square plus 10 square minus 2 multiplied by 16 multiplied by 10 cos that angle that we are looking for, which is theta. Okay, so if we just rearrange this and bring the whole of this cosine to the left hand side, we can have it at 2 times 16 is, okay, let me just write that 2 times 16 multiplied by 10 cos theta is equal to, on the right hand side now we have 16 square plus 10 square minus 14 square. Okay, so 2 times 16 is 32, 32 times 10 is 320, so we have 320 cos theta is equal to 16 square plus 10 square minus 14 square. Let's just use our calculator for that. So we are going to have 16 raised to power 2 plus 10 raised to power 2 minus 14 raised to power 2. That is 160. This is 160, and I can just divide both sides by 320. So here this 320 will cut this 320. 160 here 1, 160 here 2. So cos theta is 1 over 2, which is 0.5, and in that case theta will be arc cos 1 over 2, and arc cos 1 over 2 is 60 degrees. So we have gotten theta to be 60 degrees, but nobody asked us to find theta. So note where the angle is not just at 60 degrees, just like I explained before. The angle is actually the angle alpha, and from the foregoing we have said that alpha is defined as 180 minus theta, and theta we have obtained to be 60 degrees. So alpha is 180 minus 60, which is 120 degrees. So 120 degrees is the value of the angle between the 16 Newton force and the 10 Newton force. Just look at it that at the point where the forces are acting, they need to pull in two different directions, and that is how we can find the angle to be obtuse and not accurate. All right. In this question on moment of forces, we are told that a uniform beam WX of length 90 centimeters and weight 50 newtons is suspended on a pivot, which is 35 centimeters from W. Now, the beam is kept in equilibrium by means of forces T and 20 newtons applied at Y and Z respectively. WY is 10 centimeters and SZ is 10 centimeters, and we are asked to find the value of t. So to go ahead trying to solve this question, we can as well just try and draw the particular beam that we are being told here. The fact that it is uniform means that it's going to be evenly distributed, okay? So if you have something like this, we can say the weight, which is the 50 newtons, will be acting at the middle of the beam. So we're told it is 90 centimeters, and the weight we just need to act down here. So this is 50 newtons, and that 50 newtons is going to be acting at the midpoint of the uniform beam, okay? Because it's uniform, this will act at the midpoint. And now we're told that the length is 90 centimeters, so the midpoint will be 45 centimeters. Let's just note that. So we're not told that it is being suspended on a pivot which is 35 centimeters from W. So if we take this as the point W and we'll take this as the point X, now 35 centimeters from W, since the weight is at the middle from here to here, that will be half of 90 centimeters. So it will be 45 centimeters, which is half of the length of the beam, okay? Then we are told that from 35 centimeters from W, so maybe somewhere like here, we have the support on a pivot, can have a pivot here, okay? So that pivot is 35 centimeters from W, so the distance from here to here, that will be 35 centimeters, okay? So it is kept in equilibrium by means of forces T and 20 newtons applied at Y and Z respectively, okay? So what is the position for Y? We are told that WY is 10 centimeters, so W to Y will be 10 centimeters, and at that point we have a force which is, so down here we have a force T that is 10 centimeters from W. So this point is point Y, and it is 10 centimeters from W. Between W and Y is 10 centimeters. And then XZ from the other end, X to another point here, we have another force which was given as 20 newtons, and this is also 10 centimeters, okay? From the 20 newton force to X, so this is point Z, okay? And we are now being asked to find the value of T. T is what we are looking for, so we can do well to finish up our diagram, because if you look at this, to find T, we can just take moment about one of the pivots, okay? So taking moment, if we take the moment about the pivot, shade that in blue, okay? So we will try and evaluate the distance of each of the forces to this particular pivot. Now look at this, we have seen that from W to the pivot is 35 centimeters, from W to T is 10 centimeters, so the remaining here will be 35 minus 10. So this place here is going to be 25 centimeters. So I can just append that this is 25 centimeters from this force to the pivot, okay? Then from the center of the uniform beam to this pivot, already from W to the center is 45 centimeters. Now we have taken 10 and 25, which is 35 centimeters out. So the remaining here is also 10 centimeters, okay? All right, good. So now we also have this force, the 20 Newton force here, and we are told that it is 10 centimeters from X. The whole of the length is actually 90 centimeters as given in the question. If we take 10 centimeters out, then this remainder from W down to here should be 80, or better still, we can say since half of that length is 45 centimeters, we're taking 10 centimeters out. So from here to Z, from the midpoint to Z will be 35 centimeters. Okay, so 35 plus 10, that is 45 on this right hand side. But we are looking at the distance from this 20 Newton force to the pivot, and that will be 35 plus this particular 10 that we have. So from here, this will be 45 centimeters. So those are the parameters that we'll be needing to actually evaluate this particular question here. And if we take moment about the pivot, this is our point of interest now. I want to take the moment about the sum of the clockwise moment is equal to the sum of the counterclockwise moment. So that's what we are going to be using here. And if we look at that, taking this pivot, this particular force T will have a moment that is tending towards this side, okay? But for the 50 Newton, which is the weight of the uniform beam, it will be going like this, which is clockwise, okay? T will be counterclockwise, but the weight of the uniform beam will be clockwise. So we have this here to be clockwise, we have this to be counterclockwise, and for the 50 Newton, we also have this to be clockwise. So the sum of the moment in the clockwise direction is equal to the sum of the moment in the counterclockwise direction. So in the clockwise direction, we have 50 newtons multiplied by the distance, okay, because it is the product of the force and the perpendicular distance. And you can see the force is acting downwards, the distance is acting horizontally, the force is acting vertically. So that is perpendicular to one another. So 50 multiplied by the distance from the midpoint of the uniform beam to the pivot, that will be 50 multiplied by 10 centimeters, okay? This is the first clockwise, plus the second clockwise, that will be 20 multiplied by the distance from this 20 Newton force to the pivot, which we have gotten to be 45 centimeters, okay, is equal to, now this is the clockwise. The counterclockwise will now be the product of the force T and its distance to the pivot, which is 25 centimeters, is equal to T multiplied by 25. All right, so we can just say from here 25T is equal to 50 times 10 is 500 plus 20 times 45, that will be 2045 is 90, then with that 0, 100. So 25T is equal to 500 plus 900, that is 1400, such that the force T will be 1400 divided by 25. Okay, so 1400 divided by 25 is going to give 56 newtons. So T is nothing but 56 newtons, and we have been able to get that because we are able to interpret our question appropriately and find the distance from each of the active points to the pivot, and then we take moment about the pivot and we're able to get the value of force T to be 56 newtons. In this question of statistics, we are told that the table shows the age distribution in years of a group of people. So we have that table here, age in years and the number of people, okay? So we are to use an assumed mean of 13 years to find the mean age of the people. So the very first thing we need to understand is how do we use the assumed mean to evaluate the mean of a set of given data like this. So we are going to be generating a particular table, but that mean for this type of question is giving us the mean x is equal to the assumed mean plus the summation of the product of the frequency and the deviation over the summation of the frequency. So we are going to find the deviation interpolated on our table as is going to be shown now. Now, the age in years, so this is the column for the age. Here we are going to have the class mark, which I'm going to call X. Now, X is going to be the midpoint of that particular set of data that we are looking at. Like in the first case, when we have the age is 1 to 5, X will be the midpoint of this particular data set. And we can get it by saying the lower limit, which is 1, plus the upper limit, which is 5, divided by 2. So that is going to give us 6 over 2, which is 3, okay? And we can do that for each of the entries of those age brackets. So it's just the midpoint, and this is also a means of finding the midpoint of that particular data set. So let's just keep that in mind as we go ahead trying to solve our question. So that's how we get the value of the class mark. Okay, then we can input the frequency, which is going to be the number of people in this particular question. Then we can find the deviation, which is defined as the difference between the class mark and the assumed mean. So it is the class mark that we got here in this column, this second column. We are going to subtract the assumed mean that we are given as 13 years from that mark to get the deviation. Okay, then we can also find the product of the frequency and the deviation. So this is what we need, and in populating this, we know we have 6 to 10, then 11 to 15, then 16 to 20, then 21 to 25, and finally we have 26 to 30. So for this particular case, I exemplified that the class mark, which is the midpoint, is going to be 3. For this, 6 plus 10 is 16, 16 over 2, that is 8. Here, 11 plus 15 is 26. 26 over 2 is 13. And in short, it's going to be a consistent incremental value of 5. Like 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. 18 plus 5 is 23. 23 plus 5 is 28. You can also check by looking at the midpoint of this data set, and you will see that it is consistent with what we have got. Now, the number of people is the frequency. In the first case, we have 18, then 12, then 25. Just inputting these values directly here. Then we have 15, we have 20, and we have 10. Okay, so we can sum all of this so that we can have 18 plus 12, that is 30. 30, okay, 25 and 15, that is 40, plus 30, that is 70, plus 20, that's 90, plus 10, that is 100. So summation F is 100, because we are going to make use of that. So to get our deviation, it is the class mark, this column, minus the assumed mean that we are giving us 13 years. So that's what we are going to be doing. Students, don't make the mistake of using frequency to subtract. Okay, it is the class mark X. So 3 minus 13, that will be minus 10. Okay, 8 minus 13, that will be minus 5. 13 minus 13 is 0. 18 minus 13 is 5. 23 minus 13 is 10. And 28 minus 13 is 15. You can also see that there is a consistency to this particular value. Now we want to find the product of the frequency and the deviation in this column. 18 times minus 10 is minus 180. 12 times minus 5 is minus 60. 25 times 0 is 0. 15 times 5, that is 75. 20 times 10, that is 200. And 10 times 15, that is 150. So we can also find the summation FD. Here, summation FD. And let's just make use of our calculator. We say we have minus 180 minus 60 plus 0 plus 75 plus 200 plus 150. What's that? That is 185. So this is 185. And meaning that if we can now bring this particular set of values that we have into our equation, the mean will be the assumed mean, which is 13, plus the summation of FD, that is 185, over summation F, that is 100. So this is going to give us 13 plus 185 over 100 is 1.85. So the mean for this particular set of data is 13 plus 1.85, which is 14.85 years. So that is going to be the way that you evaluate the mean of a set of values given the assumed mean as given in this particular question. All right. In this question on probability, we are told that 2 fair dice are thrown together 2 times. We are to find the probability of obtaining a sum of 7 in the first row and a sum of 4 in the second row. So to solve this question, we will need to bring in our truth table. And here, these are truth table. Our operation is sum. So we are going to be summing the entries for both set of dice. And now in the first case, the first die can show any of 6 possible entries. Okay, those are the numbers that are on the face of the dice. So you can have 1, 2, 3, 4, 5, or 6. Okay, and in the second case, the same thing will also happen. We can have any of 1, 2, 3, 4, 5, or 6 as a number to display on the dice when it is thrown. Now we are looking for a sum of 7 or a sum of 4. So in both cases, we are looking at sum. Summation is what we are looking at, so that's how we can sum. 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6, 1 plus 6 is 7. So we can just sum all like that. So having populated all of this, we can see that this is very concerned with what we're looking for. Like when you have 2 6, this is 1 6, this is another 6, then the sum will be 12. If you have 4 and 5, this is 4 and then 5, then the summation will be 9. Okay, so that's good, that's wonderful. What we're asked to find is the probability of obtaining a sum of 7 in the first row. So where are we going to have the possibility of having 7? Yeah, look at this. If you look at this entry, you can see that that's where we have the sum to be 7. So we should know that. And then in the second case, we are told that the sum will have to be 4 in the second row. So for 4, here we have this for 4. Okay, so now having gotten that, we can say the probability of obtaining a sum of 7 is going to be the number of entries of the addition that is giving us 7, in this case 1, 2, 3, 4, 5, 6, over the total number of possible outcomes, which is 6 times 36, because that's the definition for probability, is the total number of desired outcome over the total number of possible outcomes. Here we have it as 6 over 36, and we can actually cut 6 here 1, 6 in 36, that is 6. So this is 1 over 6. But that's not all. We're also looking at the probability of obtaining a sum of 4, that's in the second row, and you can see the desired outcome for 4 only occurred 3 times. So we have 1, 2, 3. So that will be 3 over the total number of possible outcomes, which is 36. And again, we can cut 3 here 1, 3 in 36 is 12. So this is 1 over 12. But nobody asked us to do that. We are originally asked to find the probability of obtaining a sum of 7 in the first row and the sum of 4 in the second row. And is the word that we need to take note, because in probability, when we see that, that means we multiply. So the probability of obtaining sum of 7 and in the first row and the sum of 4 in the second row is going to be the product of these two. So it's going to be the probability of sum of 7 multiplied by the probability of the sum of 4. Okay, so that will give us 1 over 6 multiplied by 1 over 12, and the numerator will still be 1 multiplied by 1 is 1, 6 multiplied by 12 is 72. So 1 over 72 is the answer to this question as we're asked to solve it. In this question, the question of a line and the curve, we are told that the curve y is equal to 7 minus 6 over x, and the line y plus 2x minus 3 is equal to 0. The two of them, they intersect at 2 points. Then we are to find first the coordinate of the 2 points and the equation of the perpendicular bisector of the line joining the 2 points. So now we can go ahead to say we want to solve this question, and in the first case, what we're having is that we are to find the coordinate of the 2 points. Now look at this equation. If I say I'm giving the y for the curve, okay, the y for the curve is given as x minus 6 over x, but then for the line, I was told that y plus 2x minus 3 is equal to 0. If I rearrange this, I'm going to have the y is equal to minus 2x when 2x moves to this side, then plus 3. And this is the y for the line, okay, for the line and the curve as given. But when we are told that they intersect at 2 points, that means that what we are looking at is the y curve is equal to the y line. At the point of intersection, this is what is taking place. The curve is equal to the line, okay? So at that particular point, we can equate these two equations to say we have 7 minus 6 over x is equal to minus 2x plus 3. So we need to actually try and find the solution to this x. On the left hand side, we can take the denominator to say this is going to now give us 7x minus 6, because x being divided by 1 is x, and x times 7 is 7x, and this is just as it is, then is equal to minus 2x plus 3, as if we are having this over 1. So having this expression now, we can cross multiply, and by the time we cross multiply, we'll have on the left hand side 7x minus 6 is equal to x multiplied by minus 2x is minus 2x squared, okay? X multiplied by 3 is 3x. So once we are able to get to this point, we can just rearrange because it's looking like quadratic equation already. So if I bring all of this on the left hand side to the right hand side, so if I bring all of this on the right hand side to the left hand side, I will have it be 2x squared, okay, then minus 3x, then plus 7x minus 6 is equal to 0. I can simplify further to say this is going to give me 2x squared minus 3x plus 7x is plus 4x minus 6 is equal to 0. I can see 2 is common to this term, so if I divide each of those entries by 2, okay, then here the 2 will cut out and I will have 1 remaining. 2 in 4 is 2, 2 in 6 is 3. So the new quadratic equation I can work with is x squared plus 2x minus 3 is equal to 0. So to solve this, I'm looking for a product that will amount to minus 3 and x squared. So minus 3x squared is the product, and then the sum is 2x. What two number can I multiply together to give me minus 3x and add together to give me 2x? If I look at minus 3x and x itself, I will see that minus 3x times x will be minus 3x squared. Good. But if I sum them, it will be minus 2x. So the negative sign is not supposed to be on the 3x. It should be on the x. So it will be 3x and minus x, because the product will be minus 3x squared and the sum will be 3x minus x, because it will be 3x plus minus x, and that is 2x. Here the product is minus 3x squared. So these two terms, 3x and minus x, is what I will use to substitute for 2x, which is the second term of the quadratic equation, and I will have it as x squared plus 3x minus x minus 3 is equal to 0. I can factor out x from the first two entries, because I'm saying it is common to both. So here will remain x, then here you have plus 3, and here I can factor out minus 1. Look at this, we have minus x minus 3. So I can bring minus 1 out, and it will remain x plus 3, not x minus 3, please, because minus 1 times x is minus x, and minus 1 times plus 3 is minus 3. If this is minus 3, it would have been minus 1 times minus 3, and that would have been plus 3. So the correct expression is minus 1 into bracket x plus 3 is equal to 0. So looking here again, I can factor out x plus 3 out because it's common to those two entries. Then x plus 3 here, taking out, it will remain x, and here taking out, it will remain minus 1. So this is equal to 0, meaning that x plus 3 is 0, or x minus 1 is 0. For the first case, x will be minus 3, and in the second case, x will be 1. So that is not all to our question, okay? That's not all to our question. We are only able to get the coordinate for x. We also need to find the coordinate for y. So we need to input into any of these equations so that we can get that appropriately. Let me just clear some portion of my board. So here now we can say when x is minus 3, we can take any of these two equations, okay? I can say y, okay, let me say I want to use the y for the curve. It's going to be 7 minus 6 over minus 3, okay? So these two negative signs will multiply each other and they will become plus 3 here 1, 3 here 2, okay? So that will be 7 plus 2. So that means y is going to be 9, okay? That's in the first case. And in the second case, let me now use the linear equation. When x is 1, okay, y using the y line is going to be minus 2 times 1 plus 3, okay? Now, minus 2 times 1 is minus 2. Minus 2 plus 3 is 1. So, the coordinates of the point which we were originally asked to find, the coordinates, please students, you need to understand what you are asked to do. In the first case, x is minus 3 and y is 9. So we will have minus 3, 9, okay? X is minus 3 here and y is 9, okay? And in the second case, x is 1 and y is also 1, okay? That's interesting. So these are the coordinates that are the point of intersection of the two equations, the one for the curve and the one for the line. So these are the intersection points. All right. So that is good. So now to answer the second question, we have gotten our coordinates to be minus 3, 9 and 1, 1. So if we tag this as, let's say this is point A and this is point B, okay? We are now asked to find the equation of the perpendicular bisector of the line joining these 2 points. If we are to just consider a simplified look at the Cartesian coordinates, just something like this. Let's just have just a small pictorial view. So here we have minus 3 and 9 and then 1 and 1. So this point and this point, okay, so this is say 9, this is minus 3, this is 1 and this is 1, okay? So what we have is a straight line joining these 2 points, in which this is point A, that is 3, 9, and here this is point B, okay? What we are now asked to find is the equation of the perpendicular bisector of the line joining those 2 points. That equation is going to be something that is defining the perpendicular bisector of this particular line, okay? So for that particular bisector, we are going to know that it is inclined at angle 90 degrees to this. Now, from point A and B, we can say we want to evaluate the equation of the line AB, in which we have the coordinates of A and the coordinates of B. And then we know that for these two equations, if this one is carrying the slope M1 and the perpendicular bisector is carrying the slope M2, by reason of the geometry of straight lines, M1 multiplied by M2 is given as their product is minus 1. Okay, so once you can find the product of, when we can find the slope or the gradient of this particular line in which we have two coordinates A and B, then we can use this gradient to evaluate the equation of the second line in which the slope is going to be M2. So how do we find the equation of a line given these 2 points like this? We can say we want to look at the equation y minus y1 over y2 minus y1 is equal to x minus x1 over x2 minus x1. Just maintain a consistency, and here for the first case this will be x1, this will be y1, okay, and this will be x2, and this will be y2. So we have to bring in those equations. We can say y minus y1. y1 is 9, so we have y minus 9 over y2 minus y1. y2 is 1 minus y1, that is 9, is equal to x minus x1. So we have x minus, what's the value for x1 is minus 3. Don't make a mistake of saying it is 3 over x2. x2 is 1 minus x1, that is minus 3. So this we can just simplify to say y minus 9 in the first case, okay, over 1 minus 9 is minus 8, is equal to x minus minus 3 will become x plus 3, and then 1 minus minus 3 will become 1 plus 3, and 1 plus 3 is 4. I can just cut. This is becoming interesting now. 4 here 1, 4 here minus 2. So I can now cross multiply to say I have it as y minus 9 is equal to minus 2 times x is minus 2x, and minus 2 times 3 will be minus 6, so that y will be minus 2x minus 6 but plus 9, and that will be y is equal to minus 2x plus 3. Okay, I love this. It's also in consistency with the graph that we just quickly sketch. It's not really to scale, but even though it's not to scale, we can see that this is looking like the point 3 on the graph, which is the intercept, and then the slope is negative of 2, which is minus 2. So this slope here is minus 2. But having this as equation of the line joining the point A and B, that's not what we're asked to find. We're asked to find the equation of the perpendicular bisector. So, but from here, we can see that since our y is obtained to be minus 2x plus 3, then comparing with y is equal to mx plus c, this is why I was noting that c, the intercept is 3 already. We can see that this implies that the m, which is m1, the one for this line, is minus 2. Okay, and if that is the case, then m2 will be minus 1 over minus 2, because from here we can see that m2 is going to be minus 1 over m1. So minus 1 over minus 2, the negative sign will cancel out. So m2 is 1 over 2. Good, I love this. Okay, so we've been able to find the equation of the line joining AB. Okay, then we've been able to find the slope to be minus 2. We've also been able to find the gradient of the perpendicular bisector to be 1 over 2. So what is left for us to now do is to get the equation of that perpendicular bisector. So we need to just do that. I will just clear this right hand board. So now I want us to notice something. This question is becoming interesting. At this particular point where the perpendicular bisector is going to touch this other line, this is going to be the midpoint of the line AB. Okay, so we know a point, the point, if I call C, if I call this point C, so that point C is the midpoint of the line AB. So wow, this is interesting. So C is the midpoint of the line AB, and for us to get its coordinates, the coordinate of C is going to give us the half of the sum of x1 and x2, okay, comma y1 and y2. Okay, and you will see how that will play out. So that's going to give me half of x1. x1 is what? Minus 3, and x2 is 1, okay, comma y1 is 9 and y2 is 1. So this is going to be half of minus 3 plus 1 is minus 2, 9 plus 1 is 10. So this is the coordinate of C. C, which is x comma y, is going to be half of minus 2, that is minus 1, comma half of 10, that is 5. So you can see that that's still a bit consistent with what we have here. Like here can be actually minus 5, and here you can see that it's actually something like minus 1. Okay, here can be 5, here can be minus 1, but no problem with that. It's just an indication that we are on point. So we have this particular point defined for our C, which is the midpoint of line AB, and we have the slope to be 1/2. So we can easily get the equation of the line, that is the perpendicular bisector of the line joining those 2 points, to be that we can have it that it will be y minus y1 is equal to m into x minus x1. Okay, so y minus y1 will be y minus, what's the y1 for C now? That is 5. Okay, is equal to m, what is our m, is 1/2, multiplied by x minus, what's the x1 is -1. Okay, so here we can just say we have it that these two can just cross multiply to the other side to have, we have 2y, okay, minus 10 is equal to x minus -1 will become x plus 1. So if minus 10 is to go to the other side, we just have it as 2y is equal to x plus 1. Then when 10 moves to the other side, it becomes plus 11. And so this is the equation of the perpendicular bisector of the line joining the 2 points A and B as requested in the diagram. And if you want to see that the slope is 1/2, just divide both sides by 2. Okay, so y will be standing alone here, and then of course the coefficient of x will now be 1/2, and then the intercept will be 11/2, which will be like 5.5. So it's not too reflecting here, but we just get the general idea of what we are trying to depict, and the solution to our question is now done and dusted. We've been able to find the coordinate of the 2 points by equating the curve and the line to get the points A as -3,9 and B as 1,1. And then we went ahead to find the equation of the perpendicular bisector of the line joining the 2 points by first evaluating the slope and then looking at the midpoint of the line AB to get C. And of course, after getting that, we can put into the equation for a straight line to get it as 2y is equal to x plus 11. In this question on quadratic equations, we are told to find the range of values of p for which 4x squared minus px plus 1 is equal to 0. This equation for which it has real roots. So we need to understand what are the conditions for real roots. So looking at this question, the condition for real roots is that for equation as squared plus bx plus c as a quadratic equation, for real roots, we need to be able to evaluate that b squared minus 4ac is greater than or equal to 0 for real roots. So if we are to take this as a guide and we will consider our equation here, which was given as 4s squared minus px plus 1 is equal to 0. If we compare it to, just compare this to as squared plus bx plus c is equal to 0, we can see that readily a is 4, okay, by comparing the two, b is minus p, okay, and c is 1. So if you are to use 4 as a, minus p as b, and 1 for c in this particular condition for real roots, we are going to have it that in that case b squared will be minus p raised to power 2, okay, minus 4 times our a is 4, times c, our c is 1, okay. This ought to be greater than or equal to 0. So minus p squared is going to give us p squared. 4 times 4 is 16, 16 times 1 is 16, is equal to, is greater than or equal to 0. But this I can express as p squared minus 4 raised to power 2, which is greater than or equal to 0. I did it because I can easily try and solve this as a difference of two squares. Instead of saying I move minus 16 to the right hand side, then find the square root of both sides, then plus or minus 4. Let me just do this because this is a bit more seen. So I can say this is now p plus 4 multiplied by p minus 4 is greater than or equal to 0. In this case, that means that p plus 4 is greater than or equal to 0, or p minus 4 is greater than or equal to 0. So for the first case, p will be greater than or equal to minus 4, and on the second case, p will be greater than or equal to 0. Now, students, you don't just leave your answer like this and say, yes, I have done the work and through with it, I blasted it. No, let's test for this particular value. Okay, like on this note, if you want to look at the number line when you are working with inequalities, these are the rule of thumbs that you need to follow. Okay, so you look at the number line in which you have the positive and the negative as this. Let's say we have the origin 0. Okay, let's say we have this to be -4, we have this to be 4. Let's say this is like it's not linear, so you can just call this 5 and this is -5. Now, looking at the graph that we have, looking at the solution that we have profiled, we can see that we say P is greater than or equal to -4. Because of the or equal to, I'm going to make this a solid line. Okay, and then P greater than this -4 means that P is moving in this direction. Okay, then P, this is not 0, this is 4. That's going to be quite a costly mistake. Not 0, it is P is greater than or equal to 4. Okay, so here for this particular case, okay, in this case it is that P is greater than or equal to -4, so it's moving towards this side. In this case also, it is that P is greater than or equal to 4, so it's also moving towards this particular side. We need to check where is the range in which we are going to have our correct value. Is it going to be here in this particular region, or is it going to be here, between here, or is it going to be here in this particular region? So I'm going to test for each of the values. I'm going to take -5, okay, I will take -5, I will take 0, and I will take 5 as the values with which I want to test. Okay, I'll take -5, 0, and I'll also take 5 for each of those regions to see where this particular equation is going to be real. For example, look at this. When P is -5, that is, it is actually to this side, then our equation, the quadratic, is going to give me 4x squared minus P is now -5, okay, multiplied by x plus 1 is equal to 0. And here we can see that the equation will become 4x squared plus 5x plus 1 is equal to 0. Now, if we want to test with b squared minus 4ac, in this case, b squared minus 4ac is going to be, what's my b? B is 5, so 5 raised to the power 2 is 25, minus 4 multiplied by a, which is 4, multiplied by c, which is 1. So this is 25 minus 16. So I can just say it's 25 minus 4 times 4 times 1 is 16. So this is 9. Here is 9. And that particular 9, of course, is greater than, well, let me just put or equal to, but I know it's greater than 0. So this condition is looking quite okay. But don't worry, let's look at another condition. When P is equal to, let's say 0, then in that particular case, we'll have it that 4x squared minus P is now 0, 0x plus 1 is 0. So for that particular case, we just have it as 4x squared plus 1 is equal to 0. And if you are to test for b squared minus 4ac, that will be b is 0, okay, minus 4ac will be minus 4 times 1, and this is going to be minus 16. Of course, minus 16 is not satisfying this condition, is not greater than 0, okay, so definitely this is not a point for us to consider. And on the third case, when P is, let's say it is equal to 5, so we'll have our equation to be 4x squared, okay, minus P is now 5, okay, of x plus 1 is equal to 0, and then that will simplify to be 4x squared minus 5x plus 1 is 0. So in this case, b squared minus 4ac will be, b is now minus 5. Minus 5 raised to the power 2 is 25, okay, then minus 4 times 4 times 1 is 16, and this is also 9. So this is also satisfying the equation. So we have only two conditions, here and here, and those range is corresponding to look at this. So P is less than or equal to -4 and P is greater than or equal to 4. It is this region here. Okay, I will just recollect what I had initially so that students will get this right. So the point that satisfy the particular condition we are looking for is not the one that we just solved. We need to test actually when we are working with inequality. So that point that satisfies the equation is going to be here and here. Okay, it is this side, and that is giving us P is less than or equal to -4, and here P is greater than or equal to 4. How did I get that? I got that by testing for the values that I got to ensure that they conform to the condition for real root, which is B square minus 4AC is greater than or equal to 0. So this is the way you go about trying to solve questions, ensuring that you work only through your question. You don't just leave halfway. You don't just get some values and you think that yes, I've blasted. No, you need to test and eventually get the totality of your question. And with this, you've been able to finish this question as appropriate. In this question on binomial expansion, we are told that first we should expand 1 plus 3x all raised to the power 6 in ascending powers of x, and then using our expansion in 1 above, we have to find correct to first significant figures the value of 1.03 raised to the power 6. Okay, good and wonderful. Now, to evaluate this in ascending powers of x, is actually the binomial formula that we have, but as a rule of thumb, I generally will advise students to make use of the Pascal's triangle, in which we have for expression in which we have a plus b hypothetically raised to the power 1, then we are just having the coefficient as 1. But when we have a plus b raised to the power 2, we have 1, 2, 1 as the coefficient of the factors. So a square, we have 1 as its coefficient, AB will have 2 as its coefficient, and B square will have 1 as its coefficient. So just on and on like that, we are going to have 1, 3, 3, 1, in which you are just adding these two numbers. 1 will always begin, 1 will always end, but you add the internal number. So 1 plus 2 is 3, 2 plus 1 is 3. In this next case, we have 1 to start. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1 will end. Okay, so next one we have 1, 4 plus 1 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then 1 will also end. Okay, and then the next one we have 1 to start. 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and we have 1 to also be ending. Then this is actually that I want to clear this. So this is to the power of 2, this is to the power of 3, this is to the power of 4, this is to the power of 5, and this, as in the case in which we are trying to work, is to the power of 6. All right, so this is the Pascal's triangle that we can make use of to say we want to expand 1 plus 3x all raised to the power 6. So this is synonymous to the a plus b raised to the power n that we are looking at initially. But for this particular one, we can actually expand it to say we have 1 plus 3x raised to the power 6 will be, in the first case, 6 combination 0, okay, then 1 raised to the power 6 multiplied by 3x raised to the power 0. I will come to explain this later, plus 6 combination 1 multiplied by 1 raised to the power 5, then 3x raised to the power 1, plus 6 combination 2 multiplied by 1 raised to the power 4, then 3x raised to the power 2, plus 6 combination 3, 1 raised to the power 3 multiplied by 3x raised to the power 3, plus 6 combination 4, 1 raised to the power 2 multiplied by 3x raised to the power 4, plus 6 combination 5, 1 raised to the power 1 multiplied by 3x raised to the power 5. Okay, let me just squeeze that in. Okay, then finally plus 6 combination 6 multiplied by 1 raised to power 0, 3x raised to power 6. Okay, so this is what I was doing originally. This is it. Now, so 6 combination 0 and 6 combination 6, they are both 1, so they are going to take these extreme values 1 and 1. Okay, 6 combination 1 is 6, 6 combination 2 is 15, 6 combination 3 is 20, 6 combination 4 is 15, 6 combination 5 is 6, 6 combination 6 is 1. Okay, so that's that. But for the entries, you can see in the first entry, 1 started with the highest power, which is 6, and then it is reducing sequentially. You can see 6, 5, 4, 3, 2, 1, and 0. Okay, so those are the way that we deal with the power of the first entity. And then the second entity will start from 0. So here you have 0, 1, 2, 3 as the power of 3x, 4, 5, and 6. Okay, so those are symmetries you want to watch out for. Then, in addition, the addition of the power per entity per term is going to add up to 6. So you have 6 plus 0 is 6, 5 plus 1 is 6, 4 plus 2 is 6, 3 plus 3 is 6, 2 plus 4 is 6, 1 plus 5 is 6, and 0 plus 6 is 6. So if you want to really expand this out now, we can say this is going to give us, now for these combinations, this is what I've used the Pascal's triangle to evaluate out. So I have, in the first case, this is 1. 1 times 1 is 1. 3x raised to power 0 is also 1. So 1 is the only entity that we have here. Plus, in the second case, 6 combination 1 is 6. 1, in short, in all the places where we have 1 raised to power any number is 1. So we don't need that. But here we have 3x. So 6 times 3x is what we can evaluate here. Okay. Then plus, in the second case, 6 combination 2 is 15. Then we have 3x raised to power 2. 3 raised to power 2 is 9. So we have this as 9s squared. Okay, so I open the bracket for the number, but the variable is still retaining the power. Then plus 6 combination 3 is going to give me 20, which I've already evaluated with the Pascal's triangle as a guide. Then 3 raised to power 3 is 27. So I have this as 27 multiplied by x raised to power 3. Okay, then plus 6 combination 4 is 15, which Pascal's triangle is helping us to solve out. Then 3x raised to power 4. 3 raised to power 4 is 81. So this is times 81 multiplied by x raised to power 4. Okay, plus 6 combination 5 is 6. Then 3x raised to power 5. 81 times 3 is 243. So that is as 243 multiplied by x raised to power 5. Okay, then finally I'm going to have 6 combination 6 is 1. Then 3 raised to power 6. I think I will make use of the calculator there. 3 raised to power 6 is equal to 729. So this will be 729 multiplied by x raised to power 6. Okay, so we just need to now find out the product of all of this. So this will be 1 plus 6 times 3 is 18x. Okay, 15 times 9, 15 times 9, that's 135. So we have plus 135 s squared. Okay, then here plus, so 15 times 81, you can say 15 times 81 is equal to what? 1215. So here we have it as, this is 1215 x raised to power 4. Then plus this next entry, 243 times 6, 243 times 6, that is 1458 plus 1458 x raised to power 5, and finally plus 729 x raised to power 6. So this is the way to go about evaluating this value out. So we've been able to get that what we just wrote out, this long equation is 1 plus 3x raised to power 6. So this is the very first question that we're asked to find. You can see how we use the Pascal's triangle, or you can go ahead and just use the combination formula, whether by your calculator or you want to work it out to express this equation out. All right, now in the next question, we are told to use the expansion that we got here to find correct to four significant figures, the value of 1.03 raised to power 6. We are going to be doing that right about now. We can know this, that this is the question 1. So we are going to question 2 now. So now from the previous question, we've been able to expand 1 plus 3x raised to power 6 as this binomial expression. But now we are being told in this second question that we are to find correct to four significant figures, the value of 1.03 raised to power 6. Now, if you are to comparing, let's just do this. If we compare, now if you are to compare 1 plus 3x raised to power 6 and 1.03 raised to power 6, we can see that, 1 is common here. We can see that 1 can actually be taken out so that we can have it as, let's say we have, I'll just write this as equality. So I can have 1 plus 3x is equal to 1 plus 0.03, okay? Because this one is standalone, so if I make this to be standalone, then I can knock out this 1 and I can say, therefore, 3x is equal to 0.03, and if I divide both sides by 3, then I can find my x to be, x is equal to, look at this please, 3 can cut here 3 here 1, 3 here to be 0.01. So the value of x is actually 0.01. So I've been able to compare the original expansion that we carried out with the new solution that we are asked to find, and I've gotten the value of x to be 0.01. Students, you may just want to say here x is 0.3, then you are going to miss it because already we have a factor, a coefficient in front of x. So you need to take that out to get the original value of x as 0.01. So the binomial expansion therefore will not be that 1.03 raised to power 6 will be in this expression. Anywhere you find x, you don't use x now, you now use 0.01. So that will be 1 plus 18 times 0.01, okay, plus 135 times 0.01 raised to power 2 plus 540 times 0.01 raised to power 3 plus 1215 times 0.01 raised to power 4 plus 1458 multiplied by 0.01 raised to power 5, and finally plus 729 multiplied by 0.01 raised to power 6. Okay, so this is the ideal way to go about carrying out this particular expression. So if we want to do that, this will be in the first entry we have 1, in the second entry 18 times 0.01, we'll put those decimal places in front of 18 itself, so we have plus 0.18, okay, plus, students, just be careful when you are trying to solve this out, okay. Here we have 135 times 0.01 raised to power 2, so I have 135 times 0.01 raised to power 2, that is equal to 0.0135 plus, here I have 540 times 0.01 raised to power 3, so 540 times 0.01 raised to power 3 should be shift s squared, okay. So this is now 5.4 times 10 raised to power minus 4 times 10 raised to power minus 4 means it is 0 in 4 places, so we have 0.00012354, okay, plus 1215 times 0.01 raised to power 4, so 1.215 times 10 raised to power minus 5. So I have decimal place in 5 places, and then I can write 1215. So I have 0.1234, then I have 1215, okay, plus, just be careful in trying to express this out. So we can just continue on the next line. So we have it is that plus here we have 1458 times 0.01 raised to power 5. Okay, so this is 0 in 7 places, then 1458. So 0, 1, 2, 3, 4, 5, 6, and then the 7th one will be 1458, and then finally the last term 729 multiplied by 0.01 raised to power 6. Okay, so now it is in 10 places, and we'll still add that 729 maintained. So we have 0.1, 2, 3, 4, 5, 6, 7, 8, 9, and then the third one will now be 729. Okay, so let's try and evaluate this very carefully so that we don't make mistake. We have 1 plus 0.18 plus 0.0135 plus 0.00054 plus 0.00001215, okay, plus this now 0.1234561458 1, 2, 3, 4, 5, 6, 1, 4, 5, 8, okay, plus this last entry. Now we can move our calculator to see that clearly. Okay, plus 0.1234567891, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 729. So this is what 1.19405. So this is 1.19405, but we are asked to find it correct to 4 significant figures. So okay, this is good and fine, but recollect that from the question we are told to find it correct to 4 significant figures. And what's the meaning of that? That means that the number of relevant digits we should be seeing should be only 4. So here, if we want to take 4, we'll take 1, 2, 3, 4. So that will be approximately 1.194 correct to 4 significant figures as requested. Okay, so this is the solution to this question, and we're able to find it because we're able to successfully carry out our binomial expansion. But more importantly, we're able to also compare to get the value of x as 0.01, not at 0.3, and with that we've been able to solve this question on binomial expansion. In this question on transformation, we are told that given the transformation m on x, y to be defined as 7y, 3x minus y, and transformation n on x, y to be 2x minus y, 5x plus 3y. In the first case, we have to write down the matrices m and n of the linear transformations. Then we have to find the image of P, which is defined as 2, minus 3, under the linear transformation n followed by m. Then we have to find the coordinates of the point Q, whose image is Q prime for 2, 4 under the linear transformation n. So students, we need to understand what we are doing when we are talking about linear transformation for us to be able to perfectly understand this particular question that we are looking at. And we've actually done graphical illustration on transformation on the Cartesian coordinates, and you can do it to check out those videos on our playlist on linear transformation and matrices. So you will have a very good grasp of what we are talking about when we are having linear transformation like this. But as a general rule of thumb, linear transformation is actually ways to move around the space, especially in this case, we are looking at the 2D Cartesian plane, in such a way that your grid lines remain parallel and evenly spread, and your origin remains fixed. So if we just have, let's say we have this Cartesian coordinate, and it is defined as x and y. Okay, now if we take a particular point, okay, if we take a particular point here and we are to carry out a linear transformation, that means that for this linear transformation we can have some transformation carried on this. Maybe you can transform it from this particular, if this is a comma b, we can transform it to the other side to be here, we'll have it as minus a comma b, or it can come here to be minus a comma minus b, or it can also be here to be a comma minus b. So these are just linear transformation in which we are using a matrix to work or operate on this particular given vector so that it will transform it from this coordinate on the Cartesian plane to this particular location, or it can be from here to here, or it can be from here to here. And this is employed by making use of the matrix. So matrix is a very good way to translate transformations on the Cartesian plane, or we can say that matrices are a very good means of translating a transformation in our space. So for this particular question that we are being told that we should write down the matrices M and N of the linear transformation. Look at this. M is defined such that it will transform x comma y into 7y comma 3x minus y. Okay, now if you look at this, what are we going to operate on xy to give us 7y comma 3x minus y? If you recall your product of matrices, this is as if we are having x and y, okay, but we are looking for the matrix M that is going to give us 7y. Okay, let me just write that to include the argument of x. X is not here, so we have this as 0x. Okay, so we have 0 plus 7y, and here we have 3x minus y. So looking at this, what matrices are we going to have here that will multiply xy to actually give us this result? That is what they're actually asking for. And if we want to get that, we will see that here, that means that we have 0 here, okay, we have 7 here, and here we have 3, and here we have minus 1, such that 0 times x is 0, okay, then 7 times y is 7y, and 3 times x is 3x, and minus 1 times y is minus y. This is how we actually carry out our transformation, and it is a very good application of matrices. So that is actually M. M is defined as 0, 7, 3, comma minus 1. Okay, and in the second case for N, we can also define our N to be, we were told originally that N is operating on x comma y such that it will transform it to 2x minus y comma 5x plus 3y. So again, we need to get that matrix that will operate on x comma y to give us, in the first case, 2x minus y, and in the second case, 5x plus 3y. Once you are able to have a good understanding of this, then matrices and transformation will be on your graphs. Here you can see that it is 2 that we have here, and we have minus 1 here, and here we have 5, and we have 3 here, such that 2 times x is 2x, minus 1 times y is minus y, then 5 times x is 5x, 3 times y is 3y. This is how we actually go ahead to try and define our transformation. So the matrix M is this one here. Okay, so I can say M is defined as 0, 7, 3 minus 1, whereas our N is defined as 2 minus 1, 5, 3. Okay, that is the solution to question A. So this is A. Okay, so now we can move on to question B, in which we are asked to find the image of P, which is defined as 2 comma minus 3 under the linear transformation N followed by M. But if we want to carry out the operation N on P, we can say, so this P will translate to 2 and minus 3 such that the transformation of N on 2 comma minus 3 is going to give us the matrix of N, which we got initially as 2 minus 1, 5, and 3 is going to be operating on 2 and minus 3. And this we can evaluate to say it's going to give us 2 times 2 here, 2 times 2, okay, plus minus 1 times minus 3. So we can say it is plus minus 1 times minus 3, okay. Then here, 5 times 2, 5 times 2, plus 3 times minus 3, 3 times minus 3. This is the way to go about carrying out the multiplication of vectors, in which in the first case, the first row of the first matrix is multiplying the column of the second matrix, and after doing that, we will also carry out the operation by using the second row of the matrix, the first one, to multiply the column of the second matrix. So if we simplify this, we can say the operation of n on 2 comma minus 3 is going to give us here 2 plus 2 multiplied by 2 is 4, then plus minus 1 multiplied by minus 3 is plus 3, okay. 5 multiplied by 2 is 10, then 3 multiplied by minus 3 is minus 9. You need to be consistent with your sign so that you don't make mistakes. So if we evaluate this, this is 4 plus 3 is 7, and 10 minus 9, that is 1. So the linear transformation of n on P is this. So this is the image of P under the linear transformation n, but we also need to follow that by the linear transformation of m on this particular evaluation that we just do. So we are going to have it that in the second case, we are now going to have m to be operating on 7, 1, okay. And if m is operating on that, it will be that we are having it to be the linear transformation matrix of m, which we got initially to be 0, 7, 3 minus 1, multiplying by 7, 1. Again, we are going to multiply the row multiplied by the column. So we have 0 times 7, 0 times 7, okay, plus 7 times 1, 7 times 1, okay. Then for this, 3 times 7, 3 times 7, plus minus 1 times 1, minus 1 times 1, okay. So if we are to evaluate that, that's going to give us 0 multiplied by 7 is 0, 7 multiplied by 1, that is 7, 3 multiplied by 7 is 21, minus 1 multiplied by 1, that is minus 1. So we have this to be 7 and 20. So the linear transformation of n followed by m on P, which is defined as 2 comma minus 3, is 7, 20. So that is the solution to this particular second question B as requested in this question. So we can write it to say the image P prime is 7, 20, okay. Now in this third case, we are asked to find the coordinate of the point Q, whose image is Q prime as given as 2, 4 under the linear transformation n. So already we are given the image. So what we are looking for is Q, and we say that is x, y. As what we are looking for, we are told that Q prime is 2, 4 under the linear transformation n. So here our task is to find the coordinate of Q when the image of Q is 2, 4. So that means that originally you want to find a transformation on s, y such that what we have is that we're having the product of the matrix n, which we got initially to be 2 minus 1, 5, 3, multiplying x, y to give us 2, 4, okay. So this is the interpretation of the transformation, the linear transformation of n on Q. So that's why we're having this matrix multiplying Q to give us the image of Q as 2, 4. So this we can actually multiply out to get a set of simultaneous equations that we can solve to get the value of x and y, which define the coordinate of Q originally. So that's what we are going to do now. We are going to multiply this row with this column, and for us to do that, we are going to have 2 times x, that will be 2x, okay, minus 1 times y, that will be minus y, is equal to the first entry here, that is 2, okay. Then we are also going to multiply this row with this particular column to get this answer, and for that case we are going to have 5 multiplied by x, that is 5x, then 3 multiplied by y, that is plus 3y, is going to give us 4. Alright, so from here we can choose whatever method is suitable for us to try and solve this particular question. Okay, so if I call this equation 1 and I call this equation 2, I can say let me have equation 1 multiplied by 3. So if I have equation 1 multiplied by 3, because I can see that this is minus y, so if I get it to be minus 3y, I can add the 2 so that I can solve for x, and then I will have an head. So 2x multiplied by 3 is 6x, minus y multiplied by 3 is minus 3y, then 2 multiplied by 3, that is 6. So this, if I take the equation 2 and this equation 3 and I add them together, I'm going to have 5x plus 6x, 5x plus 6x, okay, and here plus 3y minus 3y, you can see that that's going to cancel out. So this is going to give me 4 plus 6, and that is 10. From here, that means 11x is equal to 10, such that x is 10 over 11, okay? But then from equation 1, I can see readily that from 1, if I make y the subject of the formula, y is going to be 2x minus 2. Therefore, y will be 2 multiplied by 10 over 11 minus 2, let's say 2 over 1, okay? And here, 2 multiplied by 10 over 11 is 20 over 11 minus 2 over 1. We can find the LCM such that I can say 11 is my LCM. 11 divided by 11 is 1. 1 times 20, that is 20, minus 11 divided by 1 is 11. 11 times 2, that is 22. So this is going to give me 20 minus 22, that is minus 2 over 11. All right. So that means that the coordinates of the point Q that we're told is x, y, which we are looking for, is nothing but what's the value of x? 10 over 11, and the value of y is minus 2 over 11. And with that, we have been able to find the coordinates of the point that we apply the linear transformation n on to give us the image 2, 4 by solving for this simultaneous equation and arriving at our final answer. So this is how you go about solving questions on linear transformations, and you can watch out for more videos from us on this particular topic, right? In this question on binomial probability, we are told that in an examination, 60% of the candidates passed. If 10 candidates are selected at random, we are to find the probability that at least 2 of them failed, exactly half of them passed, at most 2 of them failed. Now, so this is a classical example on binomial probability in which we can evaluate the probability of getting R success in n repeated trials in an exercise with 2 possible outcomes. And here you can see our 2 possible outcomes is that it's either the candidate fail or the candidate pass. So those are the 2 possible outcomes. So the probability of R success in these n repeated trials is given as n combination R multiplied by the probability of success raised to power R multiplied by the probability of failure, which will be 1 minus probability of success raised to power n minus R. So this is the formula that can effectively help us to solve this particular question, and we can take the question piecewise. Okay, so in the first case, in question A, we're told that we have to find the probability that at least 2 of them failed. Because before we start looking at the probability of them failing or passing, let's get the probability of failure and pass. Okay, here we are told that 60% of the candidate pass. So the probability of success, which I can call P, is going to be 60 over 100. And 60 over 100 we can evaluate to be 6 over 10. And I can use 2 to divide that. That will be 3 over 5. Okay, that's the probability for success. And if that is the case, then the probability for failure, which I'll call 1 minus P, or I can call it Q, that's going to be 1 minus the probability for success, which is 3 over 5, and in that case that will be 2 over 5. So this is probability for failure. and that's what we are going to be using in this binomial expression like n combination r. P we have gotten to be 3 over 5, then 1 minus p, that will be 2 over 5. So in the first case that we're looking at least 2 of them failing, that probability, the probability that will capture that event will mean that for the people that fail, at least 2 of them fail, means that 2 or 3 or 4 or 5 or 6, 7, 8, 9 or 10 are the people that failed. Okay, so out of those 10 that we are looking at, we are saying 10 candidates are being selected at random. So at least 2 of them failed means that the minimum number of those that failed is 2. That's why we have 2 here up to 10. So that would have warranted that we need to start saying that is probability of 2 failing, which is the event x is equal to 2, plus probability of 3 failing, okay, plus probability of 4 failing up to probability of 10 failing. Okay, and you can see this is going to be very Herculean, and that is not a smart approach to actually take. Or instead of doing that, because we know that probability always add up to 1, we can say this particular probability of the event that at least 2 of them failed, we can express it as 1 minus the probability that x less than 2. Why are we saying x less than 2? You can see here it is x is equal to 2, x is 3, x is 4, up till x is 10. That is what we have expressed here. 2, 3, 4, 5, 6, 7, 8, 9, 10 are the case scenarios in which they fail. So the other scenarios will be the scenarios in which 0 failed or 1 failed. That is x less than 2. So this will be 1 minus the probability of x is equal to 0. In that case, none of them failed. Okay, then we need to just put this in brackets, minus the probability that one of them failed. Okay, so this particular scenario is the scenario that 0 failed, no student failed here. Okay, and here it is that 1 student failed. So you can see, if we really want to express that, we can say this will now be 1 minus, we need to put everything in brackets. So the probability that 0 failed will be 10 combination 0, but now the failure is 2 over 5. This is the expression for the failure, 2 over 5. So we have 2 over 5 raised to power 0. And if 0 failed, that means all of them pass. So we can have 3 over 5 raised to power 10. Alright, so that is for this particular case scenario. Then plus this is plus, this is not minus, this is plus. We are having those two scenarios. So here plus 10 combination 1, and then the case in which 1 failed, that will be 2 over 5, which is the probability for failure raised to power 1, multiplied by 3 over 5 raised to power 9. And you can see the consistency in this, that the addition of the power of the two probabilities, 0 and 10, that will be 10, 1 and 9, that will be 10. So this is what we need to evaluate to effectively solve this particular question as appropriate. Okay, so here we can say we have this expression as a probability for at least 2 of the student failing to be 1 minus this particular probability in which none fails and all pass, and the probability in which 1 fail and 9 of them pass. So if you want to evaluate this will be 1 minus, so in this first case 10 combination 0 is 1, any number raised to power 0 is also 1, so we need to evaluate 3 over 5 raised to power 10. So 3 over 5 raised to power 10. Okay, that's what. So this is exponent of minus 3 means it is decimal places in 3 places. So we have 0, 1, 2, 3 of 6, 0, 4, 6, 6, 1. So this is 0.1260 4661, okay, plus 10 combination 1. You can get that from the calculator to say 10 combination is this button for the division, but we need to use shift with it. So we have 10 combination 1, and that is equal to 10. Okay, so we have plus 10 multiplied by 2 over 5 raised to power 1 is 0.4. Okay, this is just 2 divided by 5. Then 3 over 5 raised to power 9, we can evaluate with the calculator to say we have, let's open our bracket. Here we have 3 over 5. And close that bracket. Then raised to power 9, that's what? 0.010077696. 0.0100, let me check that, 77696. 77696. So this is the expression for that particular probability. So we can have it as 1 minus. Okay, you could have, well, just say you want to open up this bracket, or you just want to evaluate that straight. So we have decimal place 1, 2. Okay, so I can say 0.00604661 plus, now I want to put this in brackets, 10 times 0.4 times 0.010077696. Close the bracket. So this is supposed to be 60. So I can solve that. So this is 0.046357. 0.046357 394. This is what we need to subtract from 1 to get our final answer, and I can say 1 minus just this previous answer. That's 0.95364. 0.95364 2606. So you can just take a suitable approximation. I think I'll be sufficient to use 4 decimal place. So I will say this is 0.9536 as the solution to this particular question. Okay. So now in question B, we are to find the probability of the event that exactly half of them passed. So that's probability that half of them passed the exam. And if you look at what we are dealing with in the binomial probability, that will be 10 combination 5. Then the probability that half of them pass, 3 over 5 raised to power 5. Then the probability that half of them fail, 2 over 5 raised to power 5. This is quite straightforward, quite direct. So we can say we want to express that to say this is going to give us, what's 10 combination of 5? 10 combination shift divided 5 is equal to 252. So this is 252 multiplied by 3 over 5 raised to power 5. 3 over 5 is 0.6, so I can say 0.6 to the power of 5. So this is 0.0776, 0.077, is that 2 or 3? 7776. Then multiply by 2 over 5 raised to power 5. That is 0.4 raised to power 5. So 0.4 to the power of 5. And this is 0.01024. 0.01024. And if you are to multiply all of them together and just approximate to 4 decimal place, we'll have it as, let me see, 252 times 0.07776 multiplied by 0.01024. Okay, so this is 0.200 I want it in 4 decimal place, so I can round up 5 to, I will round it up to 1 and add to 6. So this is approximately 0.2007 as a probability that exactly half of them passed. Okay, so we are almost through. Finally, in the third case, we have to find the probability that at most 2 of them failed. The probability of at most 2 of them failed, the probability of that event that is described in C is going to be that first, at most 2 of them failed means that we are going to have none of them failed, okay, plus only one of them failed, plus 2 of them failed. Okay, that's what I'm trying to express in this particular case. So in the first case, at most 2 of them failed means that the maximum number of those that failed is 2. And if that's going to occur, we are going to first have a case in which none of them fails. That's why we have x is 0, none failed. Okay, so I can just note and append that this is none failed. And here, then after that case scenario, we also have the probability of only one of them failing. So here we have 1 failed. And finally, we have that they say at most, then in this case 2, which is the maximum number for this condition, 2 failed. But you now need to know that the event we are looking at here is failure. So we are going to be looking at 2/5 as the event that we are determining here. So instead of using the probability for the success, now 2/5, which is the failure, that is what we are looking at here that we should actually take note of. So if you want to find this, we can just say this is going to give us, in the first case, it is 10 combination 0. Then none failed will be 2/5 is none multiplied by, if none failed, then all of them passed. So that will be 3/5 raised to the power 10. Okay, plus in the second case 1 failed, so we have 10 combination 1 multiplied by 2/5, which is for failure, raised to the power 1 failing, then 3/5 raised to the power 9. Okay, and then for the third case we have 10 combination 2 multiplied by 2/5 raised to the power 2 are now failing, then multiplied by 3/5 raised to the power 8. Okay, so that is the ideal way to go about solving this, and I'm going to just input this directly in the calculator. We've been working it together, so now I just want to get the value straight. I'm even running out of space, so I'm going to have 10 combination 0 2/5 raised to the power 0, which is 1. This is 1. 10 combination 0 is also 1, so I just need 3/5 raised to the power 10. So let me just say I have 3/5, 3/5 raised to the power 10. That will be quite enormous. Okay, so 0.00604661. Looks like we worked with something like that before. Okay, 0.00600417 plus, in this second case, 10 combination 1, that is 10. 2/5, I will just say it is 10 times 2/5 is 0.4, okay, times 3/5 raised to the power 9. So I have here 3 and down 5. Can close that bracket to the power of 9. Okay, so I'm just evaluating them straight. This 0.0403, 0.0403 10784 10784 plus, in the third case I have 10 combination 2. Let me just write this straight. Okay, so I have 10 sheet division, okay, 2 multiplied by 2/5. Here we have it to the power of 2, that's square, then multiply by 3/5, and close that bracket, to the power of 8. Okay, so this is the whole expression for this third entry, and if I press equal to, maybe I should just put my multiplication sign here. So times, okay, good. So it's actually expecting me to put the multiplication sign there. So I have this at 0.12093, 0.120932352. So these are the entries that I need to add together. I'm running out of space, so I'll just move that now. So I can just find the approximated value of this, and I'll just have it as 0.0604616. Okay, 0.0064604. 6 is 17, 6 is 17 plus, in the second case, 0.0403, 0.0403, 0403. Okay, I think I can see others directly now. 10784, then plus 0.120932352. All right, so this is 0.167289, approximately to 4 decimal place. 8 will be rounded up to 1 and added to 2, so I have 0.1673. so this is 0.1673. okay, all right. So in this case, this is the solution for question C, and this is the solution for question B. So just like that, we've been able to look at the probability of R success in an n repeated value in which we have exactly two outcomes for the event that we are looking at. The two outcomes here is that students either pass or fail, and then we are picking 10 candidates out of those particular sets, and we can use the binomial theorem, the binomial probability, to successfully evaluate that as shown in this particular example. Here is a question on the Spearman's rank correlation coefficient, and we're told that in a research to determine the relationship between performance of students in an entrance exam and the subsequent school performance, the result of 10 randomly selected students were obtained as follows. So we can already say that we have the number of students that we are looking at here, that n is 10, and note that, so this is actually the table for the scores in the exams, both the entrance exam and the school exam. So now we have to calculate the Spearman's rank correlation coefficient and find what the researcher's conclusion from the results in A is going to be. So to find the Spearman's rank correlation coefficient, we make use of the formula R is equal to 1 minus 6 multiplied by the summation of the deviation square over n multiplied by n square minus 1. And we have already seen that the number of students is 10, so we have n, but we need to get the deviation. However, the deviation is not just gotten by subtracting the marks from each of the exams. It is that we first rank the marks. So that's why we are talking about the Spearman's rank correlation. Is the rank, in which case is the student performing best, followed by which one, followed by which one. It is the ranking, not the scores. So we are going to get our table to get that now. So this is what our table is looking like, and we have tabulated for the student, and then this is the performance in the entrance exam in this second column, and this fourth column is the performance in the school exam. So now we need to rank the performance in the entrance examination and the performance in the school examination. Then we'll find the difference between the two, which will be our deviation. Then we can find the square of the deviation, which we can sum to use in this equation. All right, so if you want to rank this now, we can see that where is the highest mark? 17 is the highest mark, so this will take the rank of 1 because that is where the student scored the highest. Student I scored the highest, so is number 1 is position 1, and the second is J, and then the third is 15. Okay, and then number 4 will have to be 14, number 5 will have to be 13, number 6 will be 12, number 7 will be 11, number 8 will be 10, number 9 will be 8, and number 10 will be 6. So this is the ranking that we make use of, not discussed in the exam. And then in the school performance, who is the best student, who comes first in this particular exam? The highest mark we are saying it is 14. Okay, so this is number 1, then followed by 12, this is number 2, followed by 11, number 3, then 10, this is number 4. Do we have 9? Yes, this is number 5. 8, this is number 6. 7 is number 7. Okay, then 6 will have to be number 8. Okay, 5 is number 9, and 4 is number 10. So it is this ranking that we now look at to find the deviation that we will be using. So the deviation will be 7 minus 9, that is minus 2. Okay, 6 minus 4, that is 2. 9 minus 5 is 4. 5 minus 7 is minus 2. 10 minus 10, that is 0. Okay, then 3 minus 6, that is minus 3. 8 minus 8 is 0. 4 minus 1, that is 3. 1 minus 3, that is minus 2. Then 2 minus 2, that is 0. Then we need to find the square of this deviation. So minus 2 raised to power 2, that is 4. 2 raised to power 2 is also 4. 4 raised to power 2, 16. Minus 2 raised to power 2 is 4. 0 raised to power 2, 0. Minus 3 raised to power 2, that is 9. 0 raised to power 2, 0. The square of 3 is 9. Minus 2 raised to power 2, that is 4. And 0 raised to power 0. 0 raised to power 2, that is also 0. So this is the square of the deviation that we need to add, and we can say, let's just use our calculator so that we don't make mistake. And say 4 plus 4 plus 16 plus 4 plus 0 plus 9 plus 0 plus 9 plus 4 plus 0. Okay, so this is 50. So we can see that summation this square is 50. Then we can evaluate the Spearman's coefficient as 1 minus 6 times the summation of this square is what we just want to be 50 over n is 10. Then n square will be 100 minus 1. So if you are to find this and look at it critically, I can just put this in my calculator. Or a student, you can choose to evaluate this first. You can say, okay, this is now going to be 1 minus 10 here 1, 10 in 50, that is 5. 6 times 5 is 30, so this is 1 minus 30 over 100 minus 1 is 99. 3 can go here 10, 3 can go here 33. So we have the ranking to be 1 minus 10 over 33, and that will be 33. Here we have 33 minus 10, which is 23 over 33. So 23 over 33 is the value here, but I can just say I want to put that in decimal because that will be more suitable for us. So 23 divided by 33, so that is 0.69, meaning that this bar means that it is repeated, so we can say it is approximately 0.697, okay, as the Spearman's rank correlation coefficient. So in the second case, this is question A. In the second case, we are now being asked that what will be the researcher's conclusion from the result in 13A? Let's look at this together, because the rank coefficient is actually trying to help us evaluate how the performance in one exam in this particular case and the performance in the second exam, how they correlate. Are they correlating well in such a way that the student that came first also came first in the second test, the student that came second also came second, third, the person also came third? Okay, so if we are to even look at this, we can see here candidate H came first here, but he came third here. However, candidate J came second and he also came second here. Look at this last candidate. He came 10th here, he also came 10th here. So we just want to look at how is the relationship between those two. So if we want to conclude, we can have R to be either +1, 0, or -1. This is the scale that we can use. If it is +1, there is a perfect correlation. If it is 0, there is no correlation. If it is -1, there is negative correlation. So the more positive the number, the better the correlation between the set of values that we are comparing. If it is 0, then there is no correlation. If it is negative, there is negative association. They are not even associated at all. But for this particular question, we can see that 0.697 is what we got as our Spearman's rank correlation coefficient. So the conclusion of the researcher should be that the relationship between the performance in the entrance exam and that of the school exam is fairly positive. So you can just have that, and with that we could have been able to get quite a good juxtaposition of the comparison of the student performance in the entrance examination and that of the school examination. All right. Here is a question on the velocity time graph in mechanics, and we are told that a body moving at 20 meters per second accelerates uniformly at 2.5 meters per second square for 4 seconds. It continues the journey at this speed for 8 seconds before coming to rest 3 seconds after that with uniform retardation. If the ratio of the acceleration to retardation is 3:4, first we have to sketch the velocity time graph of the journey, we have to find t, and we have to find the total distance of the journey. So let's bring our ingenuity of our understanding of the velocity time graph to bear in this particular case. We just try to give some sketch as they are requesting from us. So if you draw the velocity time graph with the time on the horizontal axis, just like this, this is the time, and then the velocity on the vertical axis, this is the velocity. We can just label as appropriate that this is v in meter per seconds and this is t in seconds. Okay, now to interpret the information that we're given, we're told that a body moving at 20 meters per second, so the initial velocity that the body is starting from is 20 meters per second. Okay, so we can say this is 20 meters per second. Then from there it accelerates uniformly at 2.5 meters per second square for 4 seconds. So if I'm to take my gradation here and say this is like 4, this is another 4, another 4, just taking a gradation of 4. Okay, so I can say that there is an acceleration from the starting velocity to a new velocity. Okay, and the time for that was actually 4 seconds. So this will be 0, this is 4, so this is 4 seconds, and by that 4 seconds it had gotten to this particular location here, which I can denote like this. Okay, then we're not told that after doing that, this same body is just continuing the journey at this speed for 8 seconds. Now to interpret 8 seconds means that 8 in addition to that 4. So it's not that it's stopping at 8, it is that we have to add 8 to 4, and if you add 8 to 4, that will be 12. So if I say this is the 8th mark, this is the 12th mark, it is 8 plus 4 that's giving me 12. So this is where it's going to get to, and I can denote that by just drawing on the velocity time graph. Okay, and then I can just point this down that yes, this is on the 12th second mark. Okay, so we are getting on point. So we are not told that if the body comes to rest 3 seconds after that with uniform retardation. Okay, uniform retardation means that the movement from this particular point where we have gotten to the point where the velocity is 0 here, this is the origin where that velocity is 0, so it moves with a uniform retardation. So that we need to dip nose down. Okay, that would nose dive. I'm just taking this arbitrarily, I don't know what that value is going to be. So that is the uniform retardation, and it comes to rest 3 seconds after. So 3 seconds after means that from here to here. Okay, so this is going to be, please, you need to note this. So it is from here to here, that is t, that's 3 seconds after the time consideration that we are looking at. Okay, So this is the very first thing that we have to find to sketch the velocity time graph of the journey. But I want to include the acceleration. In the first case, we are told that the body moving at 20 meters per second, accelerates uniformly at 2.5 meters per second square. So here, this is 2.5 meters per second square. Okay, that's 2.5 meters per second square. Then here, the retardation here, we are told that the ratio of the acceleration to retardation is 3:4. So acceleration to retardation is 3:4. Therefore, if you cross multiply, the retardation will be 4a over 3. But acceleration was given as 2.5. So the retardation is 4 times 2.5 divided by 3. 4 times 2.5 is 10. Okay, so we have this as 10 over 3, and that will be 3.33 meters per second square. So here, this particular slope is 3.33 meters per second square. So we need to just capture that so that we will be able to know what we are going to be working with respect to acceleration and deceleration. Now, that is the velocity time graph. Then we are asked to find t. Okay, if you are to label our diagram and call this point A, this is point B, this is point C, and here this is point D. Okay, we can solve for the velocity here. We can find this final velocity V. Okay, that is the final velocity that the body attained to and moved uniformly with for these 8 seconds that we are given. And that slope, since we can get here, we can actually use it in this particular region to find the value of t. Okay, so we want to solve for the B. From the velocity time graph, what we will notice is that if we consider the line AB, which is actually the slope of the graph, it is actually the change in velocity over the change in time. Okay, so now look at this. If we just take this here, we can look at it as if we have a triangle. AB was given as 2.5. Okay, we were told in the question that this is 2.5. It is the change in the velocity, that is the V, the final velocity here, minus the initial velocity is moving from, that is 20, over the change in time. So our time was starting from 0 and ending at 4. So this is over 4 minus 0. So we can say we want to cross multiply by saying this is over 1. So 4 minus 0 is 4. 4 times 2.5 is 10. So 10 is equal to V minus 20, such that the velocity is 10 plus 20, and that is 30 meters per second. So V here is 30 meters per second, but what we are looking for is the time t in this particular case. So we can say, if we look at, if we now consider the line, and this is how you actually work with the velocity time graph. If we consider the line CD, also we will see that this line CD is the slope such that CD is equal to change in that velocity over the change in time. Okay, change in t, it is from here to here, that is t. Then from here to here, that is gotten as 40. So we can say, therefore, CD, which is 10 over 3, I can use 10 over 3 directly instead of 3.3. 10 over 3 is equal to, what's the change in velocity? The change in velocity will be from this final velocity V that we got as 30 meters per second down to the point at which the body is at rest, which is 0. So we can have it as 30 minus 0 over, what is the change in t? Initially, the time is at 12 seconds, but now we don't know the final one. But the difference between them is this particular time, t. Okay, so it is just t. Don't say that this is t minus 12. That means we are considering the whole of this particular diagram. We just want to look at this triangle here, this one here. So the change in velocity is from 30 to 0, and the change in time is actually the t. This t is a change in time. So by the time we look here, I will say we want to just cross multiply. If we cross multiply here, we can say that 10t is equal to 3 times 30, that is 90. Therefore, t is 90 over 10, and that is 9 seconds. Okay. So now in the last question, we have to find the total distance of the journey. The total distance is going to be, that total distance is going to be the area under the graph. So this is actually, the total distance is the area of the particular shape that we have here. And we can see that that is taking us to find the area of this. Let me just further label this A, B, C, D. You can say this is E and this is F. So this is O, the origin where we are coming from. So it is the area of the trapezium ABFO, this first one here, ABFO, okay, plus the area of the rectangle BCEF, plus the area of this triangle. Wow, this is interesting now. This area of this triangle CED. Now this is a trapezium, this is a trapezium, this is a rectangle, and this is a triangle. So it is the sum of these areas that we want to find to actually get the area under the graph that is going to give us the total distance covered by that particular object. Now already we have seen that we have all the values that we have. V here is 30, then we know T, this T we have just gotten to be 9. So we can go ahead to look at that area. In the first case, the area of the trapezium ABFO is half the sum of the parallel sides multiplied by the height. So where are the parallel sides? We have, for this particular trapezium, the parallel side will be this and this OA and BF. So that will be OA is 20, so I have 20, plus BF is 30, so I have 30, multiplied by the height. The height is now from 0 to 4, and that is 4. Okay, so that's the first case, plus the area of the rectangle BCEF. Now this length is 12 minus 4, which is 8, so I have 8, multiplied by this height is 30, so it's 8 times 30, then plus the area of this triangle CED, and I can say it is half base times height, so I can say that is 1 over 2. The base is T, which we got to be 9, then the height is EC, which is 30. Okay, so for students, if you want to get that, this is actually half the sum of the sides multiplied by the height for the trapezium. Here it is the length multiplied by the breadth for the rectangle, and here it is half base times height for the triangle. So this is what we're actually doing, and we're finding the area under the graph, which will correspond to the total distance traveled for the particular body. So if you want to evaluate that, this is 2 and 4, that will be 220 plus 30 is 50, so we have 2 times 50 here, plus 8 times 30 is 240, okay, plus half of 30 is 15, so we have 15 times 9, and we can just solve that. 2 times 50 is 100, plus 240 plus 15 times 9 will be 150 minus 15. 150 minus 15 is 135. So the total distance covered will be 100 plus 240 is 340. 340 plus 135, 340, 135, that is 475. Okay, so for this particular question, in this velocity time graph, the total distance covered is 475 meters as taken from the graph. This is how we actually go about solving questions on the velocity time graph, and we have been able to find the acceleration, the retardation, the unknown time, and then the total distance covered. All right. In this question on vectors, we are given that m is I minus j, vector n is 2i plus 3j, and 2m plus n minus r is equal to 0. We are to find the modulus of vector r. Okay, no problem with that. It's just an algebra process on vectors. But from the question already, we can see from this particular expression here, since we are looking for the modulus of r, we can find r and then we'll be able to find its modulus, its magnitude, okay? Or to find the magnitude of R. In this question on vectors, we are told that given that m, the vector m is I minus j, the vector n is 2i plus 3j. Good morning. In this question on vectors, we are told that given that vector m is I minus j, vector n is 2i plus 3j, and 2m plus n minus r is equal to 0, we have to find the magnitude of the vector r. No problem. What we just need to do is that from this expression, we should be able to find r, and from r, we should find the magnitude of that vector r. So if you want to start from here, we are given 2m plus n minus r is equal to 0. So to make r the subject of the formula, we can say therefore r moving to the other side will be r is equal to 2m plus n. But from the question, look at the question here, we're giving m to be I minus j and n to be 2i plus 3j. So in that case, r will be 2 multiplied by m, and that is I minus j, okay, then plus n, which happens to be 2i plus 3j. Okay, we can open this bracket to say this will become 2i minus 2j plus 2i plus 3j. So if we take the component wise, 2i plus 2i, that will be 4i, okay, then minus 2j plus 3j, that will just be plus j. So this is the expression for vector r, but that's not what we have to find. We have to find the magnitude of that particular vector. So to find the magnitude, that is expressed as the square root of the sum of the square of the components, and the component here, the first one is 4, so we have 4 raised to the power 2, and here the component is 1, the j component is 1, so we have 1 raised to the power 2. So this is going to give us the square root of 4 raised to the power 2 is 16, 1 raised to the power 2 is 1, so the magnitude of r is the square root of 17. You can leave your answer like this, or you can say you want to use your calculator to find root 17, and that is 4.1231. So you can say this is also equal to 4.1231, and with that you've been able to answer this question on vector algebra. In this question on differentiation, we are told that the distance s in this question on differentiation, we are told that the distance s meters of a moving particle at any time t seconds is given by s equal to 3t minus 3 to the power 3 over 3 plus 9. Now we have to find the time and the distance traveled when the particle is momentarily at rest. So our understanding of how to interpret this question is going to help us to solve it, because we are told that it is a moving particle, but then we are looking at a case scenario when it is momentarily at rest. But what we are given is the distance. So s is the distance that we are given as 3t minus t raised to the power 3 over 3 plus 9. Okay, so that is the distance of the particle. But we know when we're talking about the particle coming to rest, that means there is a change in its rate of movement. The rate of movement means there is a change in its velocity, and velocity is the rate of change of the distance with respect to time. So the velocity is ds dt, and if we want to find ds dt in this particular case, generally as a rule of thumb, if you have a multiplied by h raised to the power n, the differential of this particular expression with respect to x, if y is this, the differentiation of y with respect to x will be a multiplied by n, which is the power, then the power will be reduced, multiplied by x, and then we'll reduce the power by 1. So if you are to make use of that in this particular case, we are going to have this, that it is going to be the differential of 3t is 3, okay, because t is like 3 raised to the power 0, and when we are subtracting, t is like 3 raised to the power 1, and when we are subtracting another one from it, that's 3 raised to the power 0, which is 1. So we only have 3 here. Then here in this case, minus, here we have it as the 3 will come down, then we have t raised to the power 2 over that particular 3. The differential of a constant is 0, so this is actually not going to take any effect. So we have this to be 3 So we have this to be 3 minus t squared, because the other two 3's here, this and this, they will cut off. So this is the expression for the velocity. Now look at what we are being told in the question. First and foremost, we are being told that the particle is momentarily at rest. So at rest, just momentarily, the velocity is going to be 0. Therefore, we can say 3 minus t squared is equal to 0, such that our t squared is going to be 3. So for this, we can just say t is going to be the square root of 3, and the decimal point, that will be 1.732. That's 1.73205 seconds. Okay, good. We could have left that as root 3, but no problem. However, in this is the solution to the first question. In the second question, now we are being asked that we should find the distance traveled when the particle is momentarily at rest. That means that we can use this value of the time t in the original expression for the distance, and we'll say s is equal to 3t minus t raised to power 3 over 3 plus 9. Okay, so that s is going to give us, if we want to use the value of t, that is going to give us 3 root 3, okay, minus root 3 raised to power 3 over 3 plus 9. I will just use my calculator to express this. We say 3 root 3, okay, then minus, I want to put this in fraction, root 3 square root of 3, then raised to power 3 to the power of 3 shift square. Okay, you can see how that is working out. Divided by 3, then I have this plus 9. Just check to see that you didn't make any mistake, and this is 9 plus 2 root 3. Okay, I can write this as s is equal to 9 plus 2 root 3. I love the way the calculator just gave me that answer, but if I want to get it out in decimal, it will be 12.464. so this is 12.464 meters. And with that, we've been able to solve this question because we understood how we can apply the law of differentiations to solve in a case like this as appropriate. All right.
In this question, we are to find the value of x minus 1 over x and leave the answer in the form m plus n root 5. So if we say we want to express x minus 1 over x, we can say we can find the LCM. Now this will be over 1. 1 in s is x. X times s will be s raised to power 2 minus x is s is 1. 1 times 1 is 1. So we've been given x to be 2 plus root 5. So we can put in that value, 2 plus root 5 raised to power 2 minus 1 all divided by x, which is 2 plus root 5. So 2 plus root 5 raised to power 2 will be 2 plus root 5 multiplied by 2 plus root 5 minus 1 all divided by 2 plus root 5. So we are to multiply out these two sorts. First, we do 2 multiplied by 2, then 2 multiplied by root 5, then root 5 multiplied by 2, and root 5 multiplied by root 5. So if you want to carry that operation out, you can say 2 multiplied by 2 is 2 into root 2, plus 2 multiplied by root 5 is 2 root 5. Again, we are having another 2 multiplied by root 5, that is again 2 root 5, then multiplied by root 5 times root 5, minus 1 all divided by 2 plus root 5. Now if we are to solve this, 2 root 5 and 2 root 5, we can say is just like 2x plus 2x, which will give 4x. So we can say this is now going to be 4 root 5. Then square root of 5 multiplied by square root of 5 is as if we are having 5 raised to power 1 over 2 times 5 raised to power 1 over 2. And by the law of indices, that will be a single 5. Then we add the power, which will be 5 raised to power 1, and that is 5. So we can say to give us 2 multiplied by 2 is 4 plus 4 root 5 now, then plus 5 minus 1 all divided by 2 plus root 5. So we have 4 plus 5 is 9, 9 minus 1 is 8. So that will be 8 plus 4 root 5 divided by 2 plus root 5. Now, when you have an expression like this, I want to solve it. What we do is we rationalize this surgical expression. And how do we rationalize? We take the denominator and find its conjugate, then multiply both the numerator and the denominator by the conjugate of the denominator. The conjugate means that for a surgical, for this type of surd expression, we have 2 plus root 5. The conjugate will be the change in sign so that we have 2 minus root 5. So we are multiplying both the numerator and the denominator with 2 minus root 5. And that will give, and now we have 8 multiplied by 2, that is 16. Then 8 multiplied by minus 5, that will be minus 8 root 5. Okay. Then 4 root 5 multiplied by 2. The 2 will multiply the 4 to give us plus 8 root 5. Then 4 root 5 multiplied by minus root 5. That's if we have 1 in front. 4 and 1 is 4. But root 5 multiplied by root 5 we have got initially to be 5. So that would be like 4 multiplied by 5. That would be minus 4 multiplied by 5. All divided by 2 multiplied by 2 is 4. Let's just write this out. Okay. 2 multiplied by minus root 5 is minus 2 root 5. Plus 2 multiplied by root 5 is 2 root 5. Then minus root 5 multiplied by root 5 is 5. So we can now write this out. Minus 8 root 5 and 8 root 5 will cut out. Minus 2 root 5 and 2 root 5 will cut out, leaving us with 16 minus 20 divided by 4 minus 5. 16 minus 20 is minus 8. 4 minus 5 is minus 1. And our answer will now be, the negative will cancel out and we have 8. But we have to leave our answer in the expression in the form m plus n root 5. There is no root 5. That means 0 is a coefficient of root 5. And our answer is 8 plus 0 root 5. In our question from integration here, we are given that the integral of 2x plus 5 dx, when we are taking the integral from t to 1, is equal to 18. And we are asked to find the value of t. Right from the onset of this question, I want us to note something. We are asked to find the value, not the values of t. So here, normally, ideally, if you want to find the integral of a coefficient a multiplied by x raised to power n, that will give us a multiplied by that x, now increasing the power by 1 and dividing all through by the new power, which is n plus 1. So for our equation here, we can say this equation will now give us 2 multiplied by x raised to power 1 plus 1, because the power initially is 1. We had another 1, and also divide by the new power 1 plus 1. Then plus, you can say plus 5. 5 standing alone is as if you are saying 5 multiplied by x raised to power 0, because x raised to power 0 is 1, and 5 times 1 is 5. So now we now add 1 to the power of x plus 1 over the new power 0 plus 1. And we are taking that integral from t to 1. And that will be equal to 18. If we open up this is going to give us 2 multiplied by x raised to power 2 divided by 2 plus 5 multiplied by x over 1. And the 2 can cancel out. That integral will take from t to 1 and we say is equal to 18. So we'll cancel that our 2. This is equal to 18. Meaning that what we are going to have eventually is x squared plus 5x, and we need to take the integral between 1 and t is equal to 18. So now we are asked to find this value of t, and the lower value for the integration that we are taking is actually 1. The higher value is t. So we can now substitute first t into the equation. So where we see x, we are going to use t. So we have t squared plus 5t minus, instead of x, we are now using 1
1 raised to power 2 plus 5 multiplied by 1 is equal to 18. If we were to open that up, that will give us t raised to power 2 plus 5t minus 1 raised to power 2 is 1 plus 5, that will be 6. So we have minus 6 is, and if we bring 18 to the left hand side, minus 18 is equal to 0, such that we have a quadratic equation t squared plus 5t minus 24 is equal to 0. Now, how can we solve for t here? We can easily use our factorization method, and what we are looking for is the factors that will give a product of 1 t squared and minus 24, giving minus 24t squared. So, and then the sum is going to be 5t. So what are the factors of minus 24t squared? Let's leave the negative sign for now. To get 24t squared, you can say 12t and 2t. You can say 8t and 3t. You can say 6t and 4t and co. Now, 12 and 2 and 6 and 4 is not going to add up to get 5t. But if you have 8t minus 3t, that will give us 5t. So, instead of writing 5t, you can say t raised to power 2 minus 8t plus 8t minus 3t minus 24 is equal to 0, such that if we take out the common term, in the first two terms t is common, then we'll have t plus 8 remaining. In the last two terms, minus 3 is common, then we'll have t plus 8. Note it's plus now, because minus 3 by plus 8 will give minus 24. So this means that we have t minus 3 and t plus 8 multiplying each other to give us 0 as the same as our quadratic equation. In such a case, t will now be 3 or t is minus 8. But now, remember in the initial question, I said we should note that we were asked to find the value of t, not the values of t. And here, 1 is the lower value, 18 is a positive number, and t is the higher value, meaning that we are starting our integration from 1 as a lower value, then the higher value has to be positive. So t, the value for t will have to be positive, and we'll conclude that our t is 3 and not minus 8. Minus 8 is quite far. It's also on the negative value of the x coordinate. So our correct answer is 3. Here in this question on matrix 6, we are given that the matrix B is 2, 3, 1, 4, and then b squared plus 3b plus 2i is 3n, and I is a unit 2 by 2 matrix. So we have to find the value of the matrix n. Now we have b squared, 3b, and 2i, and these are all we need to add together to get 3n. So let's go ahead and take them piecewise. Now, b raised to power 2 will be the multiplication of this matrix in two places. So we have 2, 3, 1, 4 multiplied by 2, 3, 1, 4. So how do we multiply? We multiply row by column. So the 2 and 3 is going to be multiplying the 2 and 1. 2 and 3 in the first row, 2 and 1 in the second row. And what we do is, first we are going to multiply 2 multiplied by 2, then plus the second entity in the row and the second entity in the column, multiplied by 3 multiplied by 1. Then we take the same first row multiplied by the second column of the second matrix. So we have 2 multiplied by 3. Okay. So we have 2 multiplied by 3 plus 3 multiplied by 4. We are multiplying the row by the column. Then the second row of the first matrix and the first column of the second matrix, then the second column of the second matrix, we have 1 multiplied by 2 plus 4 multiplied by 1. Then the last entry, 1 multiplied by 3 plus 4 multiplied by 4. There is a symmetry we need to note so that we don't make mistake. We can see that 2, 1, 3, and 4, they maintain their position. Then 2 and 2, 3 and 3, 1 and 1, and 4 and 4 like this. We just need to watch out for this symmetry to know that we are actually on track. So we are to do this. Will be 2 times 2 is 4 plus 3 times 1 is 3. Then 2 times 1 is 2 plus 4 times 1 is 4. 2 times 3 is 6 plus 3 times 4, 12. 1 times 3 is 3 plus 4 times 4, 16, such that b raised to power 2 will be 7, 18, 8, and 19. That's b raised to power 2. Then, what is the value of 3b? We just introduce 3 to the matrix B. So we have 3 multiplied by each of the entity of the matrix. 3 times 2 will be 6, 3 times 3, 9, 3 times 1, 4, 3 times 4, 12. Then, we want to get 2i, where I is the 2 by 2 matrix, 2 by 2 unit matrix. The 2 by 2 unit matrix will be 1 is the only entity in the leading diagonal of the matrix as shown. So if we multiply out, we have 2, 0, 0, 2, and that is 2i. So all of this, if we add them together, we are going to get 3n. So we can now say 3n is equal to b raised to power 2, and that is 7, 18, 6, 19, 7, 18, 6, 19, okay, plus 3b, we got 3b as 6, 9, 3, 12, so say plus 6, 9, 3, 12, okay, plus 2i, and 2i is just 2, 0, 0, 2, so we have 2, 0, 0, 2, and if we are to add that, the entries in the first column and first row, we add them together. In the second column and the first row, we add them together. Just 7, 6, and 2 here. Then we add 18, 9, and 0 because they are in the first row, the second column. So we have 18 plus 9 plus 0. Then in the same manner, we also do 6 plus 3 plus 0 and 19 plus 12 plus 2. And if we add all this, 7 plus 6 plus 2 will be 13 plus 2, that will be 15. 18 plus 9 is 27, 6 plus 3 is 9, 19 plus 14, that will be 33. So this is the value of 3n. This is the value of 3n. And to get n, all we just need to do, just as if we are working with our normal mathematical operations, we divide both sides by 3, such that now we can have, say, we can have 3n over 3, and the 3 we cut out will be 1 over 3 multiplied by 15, 27, 9, and 33. Each of those entities will be divided by 3. The 3 on the left hand side will cut themselves out, such that we can now say this is 15 over 3, then 27 over 3, 9 over 3, and lastly 33 over 3. Meaning that the value of n that we are asked to find out, n will be 15 over 3 is 5, 27 over 3 is 9, 9 over 3 is 3, 33 over 3 is 11, and that is the value of n. Here in this question, we are given that the radius of a circle whose equation is given is 3 root 2, and we have to find the value of c and the equation of the diameter through the point 9, 2. Now, the equation that we are given in this particular question, if we notice, it is the general form of a circle equation. And for us to get the value of c, how best can we go about this? We can easily get the value of c if we are to employ the standard form of a circle equation that is given as x minus a all raised to power 2 plus y minus b all raised to power 2 is equal to r raised to power 2. This is the standard form of a circle equation, and the definition of the parameters is that a comma b is the center of the circle, and then the radius is given as r. So a comma b is the center of the circle, and r is the radius of the circle. So now, how do we translate from this equation of the circle that we are given with an unknown c and go to the standard form of the equation of a circle? If we are able to actually get that, then our question will be easily solved. The first thing we need to do is to first rearrange. So we have x squared minus 4x plus y squared minus 2y is equal to minus c. And if you want to get the standard form, what we do is we complete the square. So the question before us now is, how do we complete the square of a given equation? We complete the square by following what I broke down into 3 steps. First, here we are having x squared minus 4x, we get half of the coefficient of the variable, not the square, half of the coefficient of the variable. Now the variable is x. We are going to get half of its coefficient. The coefficient is -4. So we get half of -4, then we square it and add it to the equation. But since here we are talking about x raised to pi, so we do that for x and we do that for y. Now, the coefficient of the variable x is -4 and the coefficient of the variable y is -2. So half of this coefficient is going to be -2 and -1. And by the time we square them, we get -2 raised to power 2 and -1 raised to power 2. These are the values that we had to both sides of the equation. So if you are to carry that out, we have x squared minus 4x plus -2 raised to power 2. But we know -2 raised to power 2 is 4. So we say plus 4. Then plus y squared minus 2y plus -1 raised to power 2. And -1 raised to power 2 we know is 1 is equal to minus c. But what we are adding to the left hand side, we also add to the right hand side. So we add 4 and 1 to the right hand side. So we have minus c plus 4 plus 1. We are doing it to both sides. So now, if you look at this equation, let's take the x and group them together and y, group them together. Now, this expression x squared minus 4x plus 4, how do we express it to translate into the standard form we are looking for? We need to recall that if we have, let's say, now x plus -2, since that is half of the coefficient we were talking about, x plus -2 raised to power 2 will be the same for us as x minus 2 all raised to power 2. That will be x minus 2 multiplied by x minus 2. So if we are to multiply this out, x and x will give us s squared. So we have s squared. Now x and -2 will give us -2x. If you multiply them out, -2 and x will give us again -2x. Then -2 and -2. The negative signs will multiply each other to give us plus. Then 2 times 2 is 4. So we have plus 4. This is nothing but s squared minus 4x plus 4. So instead of writing the whole of our equation in x, instead of writing s squared minus 4x plus 4, we can substitute x minus 2 all raised to power 2 into our equation. So we have x minus 2 all raised to power 2. And the same thing applies for y. So we have plus y minus, now what we are going to use is 1. Y minus 1 raised to power 2. And that is equal to minus c plus 4 and plus 1 is plus 5. So now we have this format of our equation, and we can now compare with the equation that we are given. We can know that now we have x minus 2 raised to power 2 plus y minus 1 raised to power 2 is equal to minus c plus 5. If we compare with the standard form of the second equation, which is given as x minus a all raised to power 2 plus y minus b all raised to power 2 is equal to r raised to power 2, we can see that the center of the circle, a comma b, which is the center of the circle, is now equal to 2 comma 1. And then the radius of the circle, now we are having the radius raised to power 2, that will give us minus c plus 5. So in the equation we are given that the radius is nothing but 3 root 2. So if you are to use that value, that r is equal to 3 root 2 into the equation for the radius, we can say 3 root 2 raised to power 2 is equal to minus c plus 5. Saying now 3 root 2 raised to power 2 is like saying 3 root 2 multiplied by 3 root 2. And we can carry this as by saying that now the 3 will multiply each other. 3 times 3 is 9. Then we have root 2 times root 2 is 2. And that will be equal to minus c plus 5. And if you just rearrange the expression that we are getting now, we can have it that when c moves to the left hand side, that becomes c. Instead of minus c, we have c will be 5 minus 18, and that is minus 13. So the value of our c is nothing but minus 13. And expressing our equation in the standard form of the circle equation had helped us to solve this question. So we can now move on to the equation of the diameter through 9,2. Equation of the diameter through 9,2. Now, a diameter is normally a straight line. And if we want to depict that, remember that we have gotten the center of our circle. We have gotten the center circle from the standard form of the equation as AB, and our AB is 2,1. So that means that we have a point. Normally, a diameter will pass through the center of the circle, starting from the circumference of the circle, go through the center of the circle to the other point on the circumference of the circle. So we have the center AB as 2,1, and we are told that the diameter passes through the point 9,2. If you are to draw our Cartesian coordinate and try to locate this point, let's say we have a gradation of our Cartesian coordinates like this, and on the y-axis we can say we just have 1,2. Then on the x-axis we can say 2, 4, 6, 8, and 10. Let's try and locate this point 21, point 2,1. It will be where 2 on the x-axis and 1 on the y-axis are intersecting, just as shown. Then point 9,2, 9 will be between 8 and 10, then 2 is there. So where they intersect is just as shown also. Now, this is A, B, which is 2,1, and then 9,2. The equation of the diameter will be the equation of the straight line that is passing through these 2 points. So what we are now left with is, how do we get the equation of this straight line passing through the point 9,2 and the point 2,1? There is a standard form of, there is a general way that we can get the equation of a straight line, because this is a straight line. And if we are to employ that, we can easily solve this question by saying y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. That means these 2 points, we take one of the points as point 1, take the second as point 2. We can take any one, is going to give us the same answer. So taking the center of the circle as point 1 and the point 9,2 as point 2, we are going to have y minus y1. y1 will now be 1, x minus x1. x1 will now be 2 over y2 minus y1. That will be 2 minus 1 over x2 minus x1 will be 9 minus 2. And that will give us 1 over 7, such that if we cross multiply, by the time we cross multiply, we can say that 7 multiplied by y minus 1 is equal to 1 multiplied by x minus 2. So opening our bracket, that will give us 7y minus 7 is x minus 2. And we take 7 to the other side, we can have 7y is x minus 2 plus 7, such that we will have 7y is equal to x plus 1 whole 5. And that is the equation of the diameter through point 9,2. What we need to note is that the diameter will run through that point and also through the radius of the circle. And with that, our question is solved for us. We're told that a basket contains 4 ripe oranges, 3 unripe oranges, and 5 bananas. And we are to find the number of ways in which, first, 1 orange and 1 banana can be selected from the basket. Now, this is a good question on combinations. And in the first case, in which we want to select 1 orange and 1 banana from the basket, there are a total of 7 oranges, including the ripe and the unripe ones, and a total of 5 bananas. So our task is now to get the number of ways in which we can select 1 orange out of 7 oranges. Understand that whether it is ripe or unripe, that is not the factor. We are only considering that 1 out of 7 oranges and 1 out of 5 bananas. Now, this is given by the formula 7 combination 1, that is 1 out of 7, and for the banana, it's 5 combination 1. So we just need to put in our combination formula, which 7 combination 1 is 7 factorial over 7 minus 1, 1 factorial, and 5 combination 1 is 5 factorial over 5 minus 1 factorial, 1 factorial. So 7 factorial is 7 times 6 factorial, because I know that 7 minus 1 will be 6 factorial at the numerator, so that the 6 factorials will cancel out. Multiplied by 5 factorial which is 5 times 4 factorial over 5 minus 1 factorial is 4 factorial. So the 4 factorial will also cancel out. We are left with 7 multiplied by 5, and that is 35 ways to get 1 orange and 1 banana out of a basket full of 7 oranges and 5 bananas. Now, in question number B, you want to select 3 oranges and 4 bananas. Just like in the first case, what we are going to have is we want to select 3 out of 7 oranges and 4% out of 5 bananas. So that is going to give us 7 combination 3 multiplied by 5 combination 4. So that will be 7 combination 3 multiplied by 5 combination 4, because it's 3 out of 7 and 4 out of 5. That will be 7 factorial over 7 minus 3 factorial multiplied by 3 factorial times 5 factorial divided by 5 minus 4 factorial 4 factorial. So since we will be dividing, we can stop at the factorial that we can cut out the numerator factorial. So we can have 7 times 5, 7 times 6 times 5 times 4 factorial divided by 7 minus 3 factorial is 4 factorial. Then 3 factorial is 3 times 2 times 1. So 4 factorial will cancel out. 3 times 2 is 6. And that will cancel out 6. And on the other case, we have 5 factorial is 5 times 4 is 1. So that 4 factorial can cancel out. Then 5 minus 4 is 1 factorial. And that is 1. Then times 4 factorial. The 4 factorial cancels out. So here we're also going to have this will give 7 times 5 times 5. And that will be 7 times 5 is 35. 35 times 5, that will be 175 ways. Good. So now we can move on to this third case, in which we need to note what we are being told. These first two cases are quite easy to get. But now in question number C, we are being told that we are to select 2 unripe oranges out of 3 unripe oranges. So that will be 2 out of 3 unripe oranges. Now we are separating the oranges. That okay, these oranges are ripe, these oranges are unripe. So 2 out of 3 unripe orange, 3 combination 2. 1 ripe orange out of 4 ripe oranges will be 1 out of 4 ripe oranges, and that will be 4 combination 1. 4 combination 1. Okay. And then 3 bananas out of 5 bananas. That will be 3 out of 5 bananas. That will also give us 5 combination 3. So because we are separating ripe oranges from unripe oranges, this is the way that we go about it. And the number of ways to select everything will be the multiplication of these combinations. So we have 3 combination 2 times 4 combination 1 times 5 combination 3. So to solve that, that will give us 3 times 2 factorial divided by 3 minus 2 factorial 2 factorial. So, and the next one will be 4 times 3 factorial divided by 4 minus 1 factorial 1 factorial. Now I'm stopping at 3 and 2 at the numerator because I know that will eventually cut the factorials at the denominator. So the third case, we have 5 times 4 times 3 factorial divided by 5 minus 3 factorial 3 factorial. So I can cut out the factorials that are similar. 2 is cutting here. 4 minus 1 is 3, so that will cut 3 factorial. Then 3 factorial will also cut here, so that what we are left with is 3 divided by 3 minus 2 is 1. 1 factorial is 1 times 4 over 1. Okay. Multiply by 5 times 4 divided by 5 minus 3 is 2 factorial, which is 2 times 1. So 2 can go here 1, 2 in 4, 2, and the multiplication of the remaining numbers, 3 times 4 is 12, times 5 is 60, times 2 is 120. So we have 120 ways of picking 2 unripe oranges, 1 ripe orange, and 3 bananas from the basket. In this question, we are asked to use the graph method to estimate the modal age of the workers, whose statistics of age and the number of workers were given in the table as shown. So, what this is telling us that we should actually get to draw our histogram, and from the histogram estimate the mode, because the histogram is what we normally use to get the mode and in this case we are getting the modal age of the workers. So if we tabulate the information that we are giving, we need to get the lower class boundary and the upper class boundary. We subtract 0.5 from the lower class boundary and add 0.5 to the upper class boundary, so that in this case we have 19.5 to 24.5 as our class boundary. Okay, the first entry is the lower class boundary, the second entry is the upper class boundary. So we do that for each data that is indicating the age of the worker. So here we have 39.5 to 44.5, okay, then 44.5 to 49.5, then 49.5 to 54.5, and finally 54.5 to 59.5. So we are going to plot the histogram by making use of the class boundary against the number of workers that we're given. So here we are bringing in our graph, and we are noting that on the class boundary we're having 19.5 to 59.5 as the data that we need to put on the class boundary as is. And then for the workers, we are noticing that 12 is the least, but 38 is the highest number of workers when we group them by age. So we have 12 to 38 on the number of workers as is, which will also correspond to something like, say, our frequency. Now, I'm noting this because I want to scale appropriately. When we are working with questions like this, it's not necessarily, it's not a compulsory, it's not by compulsion that we should actually start from 0. We can actually, for the best fit of our graph, it's best that we look at a point where we can start, not necessarily 0. So if I draw my horizontal and my vertical axis, and for the histogram, normally on the vertical axis we have the frequency, but in this case is the number of workers, okay? And then on the horizontal axis we have the class boundary, and our class boundary we have defined already from our table, and the class boundary is in years, okay? So now how best can we actually put in this data starting from 20.5 to 59.5 on the class boundary axis? And then we will notice that if we say we are not starting from 0, we notch our graph as shown, then we put in the first entry, that is 19.5. then if we just increase each of the step of the graph, the thicker lines, if we just take it as the entries that we are going to be using, 19.5, 24.5, 29.5, 34.5, 44.5, 49.5, 54.5, 59.5. We notice that in this we are having a spacing of 5 units, because from 19.5 to 24.5 is 5 units, okay? Now our unit here is here, so we can put our scale that centimeter, which is the space between the thicker lines of the graph, represents 5 years on the class boundary as this, okay? So if you are using that, and then we can go to our vertical axis now, we are through with the horizontal axis. We see that our least value is also 12 and the highest value is 38. We don't also need to start from 0, so I'm going to also notch that. So I'm putting, let's say, an increment of 4 units, so 12 plus 4, 16, 16 plus 4, 20, 20 plus 4, 24, and we will end at 40. So between 12 and 40, we have all the inputs that we need because we are stopping at 38. So on the vertical axis, we are seeing that 2 centimeter is representing 4 workers, okay? 2 centimeter is representing 4 workers on the number of workers axis, which is the vertical axis. So with this, we can now go ahead to say we want to plot our graph. We want to plot our histogram so that we can estimate the mode from the histogram. Now, for the number of workers, we have 22. Then the class boundary, we have 19.5 to 24.5. So 22 is in between 20 and 24. Then 20.5 to 24.5 is as shown. And we can just draw our bar, okay? So in the next case, we are having 24 as the number of workers, then taking the value from 24.5 to 29.5, just as shown. Then the next one we're having 30, okay? 30 is here, and on like that, we can just plot the next, the class boundary for the 30 is 29.5 to 34.5, and then the next entry is for the 38 number of workers, and their class boundary is 34.5 to 39.5. The next we have 36 and 39.5 to 44.5, which is as shown. Then we have 30 and 44.5 to 49.5. We've gotten 30 before, so we just also go there, 30, then between 44.5 to 49.5. Then we are coming down to 18, okay, 49.5 to 54.5, and then finally to 12, 54.5 to 59.5. So we just need to complete our graph by just joining all the bars, and then this, when we are through, will give us the histogram of the data that we are given. And how do we get the mode from that histogram? We look at the highest bar, okay, then we draw from the two adjoining bars to meet the opposite side of the bar, and the point of intersection of that joining, it will look like X. That will be our modal age. All right, so now we have our histogram already, so let's go ahead to see how we can just, okay, let's label this. This is the histogram. This is the histogram of the given data. Okay, it's always appropriate to label your graph. So now we can look at how to get our modal age. Just like I said before, we take the highest bar, that's the one here. So we draw a line from the adjoining bars to the opposite side. Then we do the same thing here, and the point of intersection here, we are going to trace to the class boundary axis, that's the horizontal axis, and whatever value we have there is going to be our modal age. Now we have 34.5 to 39.5, and we already know that that's 5 units, so each is just 1 unit because we have 5 division on my graph here. So we have 34.5, 35.5, 36.5, 37.5. So this is 38.5. So from the graph, as we are requested from the question, the modal age, okay, the modal age is 38.5. The modal age is equal to 38.5 years, and that is the solution to our question. All right. And in this question, we are given that a triangle PQR have vertices 2, 2, 3, -1, and 4, 0 respectively. Now we are to use vector method. Notice that we have been told what method to use. We are to use vector method to calculate angle PQR. Now, all these points that we have been noting, 2, 2, 3, 1, -1, and 4, 0, if you are to write them out, that means P is 2, 2, Q is 3, -1, and R is 4, 0. Let's see how we can locate this on the Cartesian coordinate so that we can get our vector out and use the vector method to calculate the angle PQR. So if you are to draw a Cartesian coordinate and scale it on a gradation of 1 unit, so we have -1, -2, then 1, 2, 3, 4. Okay, 1, 2, 3, 4. If you are to locate all these points, point P is 2, 2. So 2 and 2. This is point P. Okay. Point Q is 3, -1. 3 on the x-axis, -1 on the y-axis. So this is point Q. And the R is 4, 0. That will be 4. And so these are the vertices that were given. And if we are to join the 3 points together Q to P, and Q to R. Here, since we are told that we are to use the vector method, what we can say is we can take Q as our origin, then vectors emanating from it will be vector QP and vector QR, and then we have to find angle PQR, Q being the center. So the angle we're asked to find is being shaded in red. So this, let's call it angle theta. So now, with respect to vector, how do we go about solving this type of questions if you are to find angle PQR? Now, what would be ideal for us to use is just to know that the angle theta, the angle PQR, is actually the angle between the vectors QP and QR. And now the order is of utmost importance to us. We don't want to mix that order of angle. It is angle between the vector QR and vector QP. Q being the emanating point, since that's where we are taking our angle from. So now we are being saddled with some responsibilities. We know that using the dot product, we can say that the vector QP dot the vector QR is going to give us the magnitude of the vector QP multiplied by the magnitude of the vector QR multiplied by the cosine of the angle between the two vectors, in this case cosine theta. So now vector QP and QR, we're going to evaluate the magnitude of QP and the magnitude of QR. We are going to evaluate, and cos theta is going to give us QP dot QR divided by the magnitude of QP multiplied by the magnitude of QR. So evaluating the vectors QP, QR, and their magnitude is going to help us to solve this question. So now, how do we get the vector QP? QP will be the difference in the position vectors P and Q. Since Q is the source, we are going to say P minus Q. And since we know our P to be 2, 2, that will be 2I plus 2J minus Q. Q will now be 3, minus 1, which is 3I minus J. You know, we have 3, minus 1, so we say 3I minus J. And if you are to open that bracket, that will be 2I plus 2J minus 3I. Now, minus J will give us plus J, because negative will multiply each other to give a positive number. So if you are to resolve that, that will be 2I minus 3I is minus I, 2J plus J is 3J. And that is vector QP. And the magnitude will be the square root of the sum of the square of its components. So we have square root of minus 1 raised to power 2 plus 3 raised to power 2. That will be square root of 1 plus 9, which is root 10. That is the magnitude of vector QP. Now, moving on and solving for QR in the same manner, QR is going to be R minus Q, again because Q is our common point where we are originating from, and the position vector of R is 4, 0, so R will correspond to 4I plus 0J. 0J because 0 is the component for Y, then minus Q, which is 3I minus J. If you are to open this bracket also, we have 4I plus 0J minus 3I. The negative sign again will multiply each other to be positive, so we have plus J. So this will give us 4I minus 3I is I, 0J plus J is J. And then we can also find the magnitude of the vector QR to be the square root of, now it's just 1 raised to power 2 plus 1 raised to power 2. And that will be the square root of 2. So root 2 is the magnitude of vector QR. After clearing our board, we can now say our cos theta is equal to the dot product of our two vectors, vector QP dot vector QR, divided by the magnitude of the two vectors, magnitude of QP, multiplied by the magnitude of QR. All we just need to do is to slot in all these that we have gotten initially, such that cos theta is going to be equal to our vector QP, which is minus I plus 3J dot our vector QR, which is I plus J divided by the magnitude of QP, which we got to be square root of 10 multiplied by the square root of 2, which is the magnitude of vector Q. To find the dot product of the vectors, we multiply the I component and add it to the product of the j component. So here we have minus 1 multiplied by 1 plus now the j component, we have 3 and 1 plus 3 multiplied by 1 divided by, we have root 10 multiplied by root 2, that will be root 20. So minus 1 times 1 is minus 1 plus 3 times 1 is 3 divided by root 20. So if you are to evaluate that, that means cos theta is minus 1 plus 3 is 2 divided by root 20. Well, root 20 is the same thing as square root of 4 multiplied by 5, and then that will be 2 over square root of 4 multiplied by square root of 5. Now square root of 4 is 2, so we can say that is 2 over 2 root 5. The 2 will cancel out, so cos theta is 1 divided by root 5, and we can say in that case theta will be arc cos 1 over root 5. So we can bring in our calculator now to evaluate the value of theta. Say that arc cos 1 divided by root 5. Okay, that will be 63.43494882. We can round that up as appropriate as we like, and I can say that is 63.43 degrees. That is the angle PQR that we got using the vector method. In this question, we are told that a motorist is moving along the straight road with a uniform acceleration. The motorist passes a village X with velocity 8 meters per second and another village Z with a velocity 30 meters per second. The distance between X and Z is 2,700 meters. If village Y is the midpoint of the distance between X and Z, we have to find the time taken by the motorist to move from village X to village Z. So if we are to look at our information and interpret them, we have village X, we have village Z, and then the velocity when it's passing through village X is 8 meters per second. So as X, we have U is 8 meters per second, and the velocity when passing through village Z is 30 meters per second. So we have V, and at Z is 30 meters per second. So okay, we are given the distance between the two villages X and Z as 2,700 meters. So we can denote that this is 2,700 meters. Alright, then we are told that village Y is the midpoint of the distance between X and Z. Okay, so we are now given all this information. We are now being asked to, okay, we are told also that the acceleration is uniform. Uniform acceleration means that the rate of change of the velocity is constant. Okay, so we are now being asked to find the time taken to cover the distance between village X and village Z. Okay, now having a good understanding of our question is the first step that we need to take, and we have taken that. Now the next step we need to take, what we need to ask ourselves is that how do we go about solving these questions? This is actually a question of equation of motion, and there are three equations that we can use. We can say V square is U square plus 2AS. We can use S is UT plus half AT square, and then acceleration A is V minus U over T, where V is the final velocity, U initial velocity, T is the time taken, A is the acceleration, and S is the distance taken. Now, for this particular question, we're looking for t. So, the last two equations, if we take the value of the acceleration v minus u over t and use in the equation for the distance, we can get our time. So, getting the acceleration, we can say is the final velocity minus initial velocity, which is 13 minus 8 over t. That will give us 5 over t. So, if we are to use this in the equation, s is equal to ut plus half at squared, we are going to have s is equal to u, which is 8, multiplied by t, plus half. Our acceleration is now 5 over t, multiplied by t squared. The t's will cancel out, so that s will be 8t plus 5 over 2t. And if we are to find the LCM, we have to, this will be 16t plus 5t. Cross multiplying is going to give us 2s is equal to 16 plus 5 is 21t, such that our t will now be 2s divided by 21. Now, what's the value of s? We're giving us 2,700. So, t is 2 times 2,700 over 21. 2 times 2,700 is 5,400. And if you bring in our calculator and we are to express it to the nearest whole number, we can find the value of the time t. That will be 5,400 divided by 21. Okay, just the question is to the nearest whole number, so our answer is going to be 257 seconds. That is the time taken between village X and village Z. In this question, we are told that point L, which has its coordinate as -1, 0, and then point M 37 and N 5, -2 are the midpoints of the sides BCC and AB of triangle ABC, and we have to find the equation of line AB. Now, for how to go about this, it will be best for us to see the position of all these locations with respect to one another. And so, if we draw our Cartesian coordinates and we try to locate all these points, we will say that gradating with respect to 1 units, we are going to be able to locate point L, which is -1 on the x-axis and 0 on the y. That is point L. And then point M, which is 3 and 7. This is just a rough sketch. This is point M. And then point N is 5, -2. That will be located here. So this is N. So now these are the spatial arrangements of the 3 points. And we are told that they are the midpoints of the sides BC, CA, and AB respectively. So the midpoint of BC is L, the midpoint of CA is M, and the midpoint of AB is N. So if we are to try and draw out our triangle, just to have a feel of how these are distributed on the triangle, let's say we have first AB, and the midpoint is N. So we are going to have point A and point B. Then BC and AC. Okay. So the midpoint of CA is M and the midpoint of BC is L. So now, since M and L are the midpoint of the sides AC and BC, that means they are going to be parallel to the point AB. So if you draw a straight line from M to L, that line will be parallel to the line AB. And now, if two lines are parallel, there are some characteristics that they share. In this case, we are going to say that first, what we are noticing is that point N is located on the line AB. So the coordinate of point N is going to bear relevance to the line AB, which we are asked to find. And then the line LM and the line AB, since they are parallel to each other, they are also going to share the same slope. Now, lines that are parallel to each other are always having the same slope. So LM and AB, they have the same slope. And we also notice that N is a point on the line AB. Now, for us to get the slope of either LM or AB, we know that slope is change in y over change in x. Now, to get the change in y, we have point M and point L. What is the difference between the coordinates with respect to y and with respect to x? So we can say for ML, M is 3, 7, L is minus 1, 0. So the change in y will be 7 minus 0 for the y, and then the change in x will be first for M 3 minus 1. We don't want to leave out that negative 1, and this, if we solve, is going to be the slope of line LM, which is 7 over 3 minus 1 is 3 plus 1, and that is 4. So now that means that for the equation of line AB, we have gotten the slope to be 7 over 4, and then we also know that one of the points is point N. So we can use this to say the line AB and the line LM, they also have the same slope, which is given as 7 over 4. And if we want to use this to actually get the equation of the line, all we need to do is to go ahead and say that point N, which has coordinate 5, minus 2, we can actually use this slope and this point to get the equation of the line AB. And how do we go about that? There is a general form of equation of a line. So if we are to use the general form of the equation of a line, that's saying y minus y1 over x minus x1, ideally we say is y2 minus y1 over x2 minus x1, which is the same as change in y over change in x. Then y1 and x1 we have gotten as 5, minus 2. So if we are to use this value, we are going to have y minus, the value of y at point N is minus 2, then x minus the value of x at point N, which is 5, is equal to our slope 7 over 4. So if you are to cross multiply and say y minus 2, the negative sign will multiply to give y plus 2 is equal to 7 into x minus 5. And opening the bracket, we have 4y plus 4 times 2 is 8 is equal to 7x minus 7 times 5 is 35. So if you rearrange, you can have 4y is 7x minus 35. Now, plus 8 crossing to the other side will be minus 8, such that our equation is 4y is 7x minus 43. And with that, our question is solved. In this question, we are given that the function f of x is equal to ps squared plus qs plus r, and pq and r are constants. Then if function of 1 is 0, function of minus 1 is 4, and function of 2 is 7, we are to find first and foremost the values of pq and r. Now what we are going to do is we are going to be substituting for the function of 1, minus 1, and 2 into the equation. So in the first case, when they are saying function of 1 is 0, that means in the equation, everywhere we see x, we are now going to use 1, just as being shown, and we equate everything to 0. So for the first case, we have p plus q plus r is equal to 0. This we can call equation 1. Okay. Then we can go to the second case, function of minus 1 is equal to 4. So function of minus 1 is equal to 4. Meaning that everywhere we see x, we are going to put minus 1. So we have p into minus 1 raised to the power 2 plus q multiplied by minus 1 plus r is equal to 4. And minus 1 raised to the power 2 is 1. So we have p minus 1 times q is minus q plus r is equal to 4. I can call this equation 2. Then for the third case, function of 2 is equal to 7. So function of 2 is equal to 7. Then substituting 2 for x, we're having p multiplied by 2 raised to the power 2 plus q multiplied by 2 plus r is equal to 7. So 2 raised to the power 2 is 4. We have 4p, and 2 times q is 2q plus r is equal to 7. This is equation 3. So we have a simultaneous equation in 3 variables here. First check with your calculator. So if I'm to bring in my calculator now, and I'm going to the mode, then 5 corresponds to equation 5. Then M2 is the one that is looking similar to what I'm trying to solve. So I'm pressing 2. So now I will input the coefficient of my unknowns. For P, Q, and R in the first equation, it is just 1, 1, and 1, and it is equal to 0. So for the second equation, I'm having P, that's 1, then minus Q, that's minus 1, R, that's 1, then 4 as D. And in the third equation, I have 4P, so 4, then 2Q, 2, R is just 1, then everything is equal to 7. So if I just press my equal to, it's telling me that the calculator is using X, Y, and Z. I know I'm using P, Q, and R. So I'm having 3, minus 2, and minus 1 as my solution. I will just keep this, and while I'm working, just to check that I'm on track, I know that that should be my final answer. So let's go ahead to try and solve this ourselves. We have equations 1, 2, 3, and we are going to be eliminating some variables. So if you add equation 1 and 2, we can see that we have plus Q in 1, we have minus Q in 1. So P in the two instances is going to give us 2P. Q plus minus Q will knock themselves out, so that will be 0. Then R plus R is 2R, 0 plus 4 is 4. Now I can divide this equation also by 2, because I can see that 2 can go in all of the entities, so that I can have P plus R is equal to 2. I can call this equation 4. Then, okay. Now looking at equations 2 and 3, now if I multiply equation 2 by 2, I can eliminate Q also, because I have minus Q and 2Q. So if I make that minus 2Q and add the 2, it's going to eliminate Q also. So I will say equation 3, I will add to 2 multiplied by equation 2, okay? Because my target is, just like I eliminated Q in equation 4, I also want to eliminate Q again. So equation 3 will be 4P plus 2Q plus R is equal to 7. Then 2 multiplied by equation 2 will be 2P minus 2Q plus 2R is equal to 8. Each of the entities are multiplying by 2. So if I'm to add the 2, you can see that the 2Q and minus 2Q will cancel out. 4P and 2P is 6P. Then the Q's will cancel out. R and 2R is 3R. 7 plus 8 is 15. So I have 6P plus 3R is equal to 15. And again, if you're observant, 3 can go in all the entities, such that if I divide all 2 by 3, I will have 2P plus R is equal to 5. I can now call this equation 5. Now, looking at equations 4 and 5, I have P plus R is equal to 2, 2P plus R is equal to 5. I can also eliminate R if I subtract these equations one from another. So I'm going to say equation 5 minus equation 4. Okay, if I say equation 5 minus equation 4, that will give me here 2P. Maybe I should just write all that out. 2P plus R minus, in equation 4, P plus R, that's the left hand side, is equal to 5 minus 2, and that is the right hand side. So going ahead to solve this will mean that 2P minus P, then R minus R, the R will cancel out. We have P will now be equal to 3. So now I've gotten my P to be 3. I can take any of the equation as is appropriate to me, either from 4 or 5, and use P is equal to 3 in that. So if I'm to say using P is equal to 3 in equation 4, I'm going to have, instead of P now, I have 3 plus R is equal to 2, so that R will be 2 minus 3 when 3 moves to the right hand side, and that will be minus 1. Now I have the value of P is 3, R is minus 1. I can use in any of the original 3 equations that I'm starting from initially. So using equation 1, where we have P plus Q plus R is equal to 0, if I'm to use P is 3 and R is minus 1, so I'm going to say 3 plus Q now minus 1 is equal to 0, such that 3 minus 1 is 2, then 2 plus Q is 0, and when 2 moves to the right hand side, Q will be minus 2. So with this, I've also been able to get what I was able to obtain with the calculator initially that P is 3, okay, Q is -2, and R is -1. And that is how we solve for simultaneous equation in 3 variables corresponding to what my calculator gave me initially also. So that question is done and dusted now. And we can now move ahead to say we want to find the factors of the function of x. Now, originally, we are given that the function of x is equal to px raised to power 2 plus qx plus r. But from our solution so far, we've been able to find the value of p, q, and r. And if we are to put that into the equation, we know that our p is 3, then q was gotten to be -2, and r was gotten to be -1. So if we put that into the equation for the function of x will now be equal to 3s squared plus -2x plus -1. That's substituting for each value of p, q, and r. So the function of x is 3x raised to power 2 minus 2x minus 1. And now we are asked that we are to find the factors of this function of x. So now what we need to do to factorize this is, looking at this, we are saying that let's try and factorize, but we have some products and we have a sum that we need to take cognizance of. The product in this case will be the coefficient of x and the last term. So we have minus 3s squared, and the sum is going to give us the second entity, which is -2x. So what two factors can we multiply to get minus 3s squared? And when we sum them, it will give us -2x. And that factors, if you consider minus 3x and x, minus 3x multiplied by x will be minus 3x squared. Okay, minus 3x plus x is -2s. So the second entity in our quadratic equation, we are going to use not minus 2x now, we say it is now minus 3x plus x, because those are the factors that are suitable for us. So from here, we can now say that in the first two terms, we want to factor out 3 already and x, because 3x is common to both. So we can say it's 3x into x minus 1, and then already x minus 1 is remaining in the last two terms. So that means 1 is just multiplying them. So this will now give us 3x plus 1 into x minus 1. We are asked to find the factors, not the solution to the quadratic equation. So our factors have been gotten to be 3x plus 1 and x minus 1. And that is the solution to our problem. In this question, we are to express the function f of x into partial fractions. And that f of x, it was given as 2s raised to power 2 minus x plus 3 divided by x plus 1 into bracket and x raised to power 2 plus 2 into bracket. Now, how do we express in partial fractions? We express in partial fractions by reverse engineering our original function and separating it into its constituent fractions. So in this case, we have something divided by x plus 1 over something divided by x raised to power 2 plus 2. Now, because in the first denominator we're only having x, the numerator will be a, but in the second denominator we're having x raised to power 2. So that something is going to be bx plus c. So this is the task before us, and we are to find the value of a, b, and c. If we can find that, then we'll be able to, that means we have been able to express this function into partial fractions. So we can go ahead to say we want to find the LCM of this function, the one to the right hand side. And to do that, all we need to do is to multiply the two denominators, x plus 1 into bracket x raised to power 2 plus 2. Now, if we find the LCM, x plus 1 will go into each other, such that in the first case we have a into bracket x raised to power 2 plus 2, then plus, now x raised to power 2 plus 2 will go in each other, so that we have bx plus c multiplied by x plus 1. Now, looking at the left hand side and the right hand side, we will notice that the denominator is the same. We can leave out the denominator and just take the numerator in both cases, equate them to one another. We will open the bracket and try to find what we are going to get as a means of solving for A, B, and C. So if you take the numerator, 2x raised to the power 2 minus x plus 3 will be equal to A multiplied by x raised to the power 2 plus 2a plus, now if you want to open this other bracket, we first take bx and x, so that will be x in two places. We have bx raised to the power 2, okay, then bx and 1, that will be plus bx, because any number multiplied by 1 is that number, okay, plus c multiplied by x will be cx, then plus c multiplied by 1 now, so plus c, because c times 1 is 1. Now we can go ahead to say we want to rearrange such that we are going to find both on the left and the right hand side similar case scenarios in which we have coefficient of x raised to the power 2, coefficient of x, and the constant. So now that will give us the coefficient of x raised to the power 2 are just a and b, and it is additive, so we have a plus b all into bracket of x raised to the power 2, okay. Then the terms for x, we have b and c, bx plus cx, so we have b plus c into x, okay. Then the constants, the ones who are not carrying x at all, we have 2a and c, so we have plus 2a plus c. Now looking at the left hand side and the right hand side, we can see that for both cases we have coefficient of x raised to the power 2, we have coefficient of x, and we have the constant. So if you are to compare this, we can equate the coefficient of the term plus the one to the left hand side and the one to the right hand side. Like for x raised to the power 2, we have 2 and a plus b, meaning that a plus b is 2. Then for the one for x, we have minus 1 and b plus c, meaning that b plus c is minus 1. Then the constant 2a plus c is going to give us 3. So this is what we are going to do, and once we get that, we can now say we want to go ahead to solve for all these unknowns a, b, and c. So if you take all this, we have a plus b is equal to 2. Those are the coefficient of x raised to the power 2. Then we have b plus c is equal to minus 1. That will form equation 2, which is the coefficient of x on both left and right hand side. Then the constant 2a plus c is equal to 3. So we have a simultaneous equation in 3 variables that we can go ahead to solve. This will be quite easy for us because at least in each of the equation we are that we are only having two terms, so we can easily look at how to juxtapose. Do we want to substitute? Do we want to eliminate? And once that is done, our work will be solved easily. So we have our 3 equations. The first one, a plus b is equal to 2. The second one, b plus c is equal to minus 1. And the third one, 2a plus c is equal to 3. So these are 3 equations. They form simultaneous equation in here. We are having 3 variables. So we are going to see how we are going to solve them. From equation 1, we can make a the subject of the formula, and a will be 2 minus b. This formula for a, we can say we can use it in equation 3. Let's use a is equal to 2 minus b in equation 3. So instead of 2a, we are now going to have 2 into bracket 2 minus b, all right? Then plus c is equal to 3. We can open up this whole bracket to see 2 times 2 is 4, minus b times 2 is minus 2 minus b plus c is equal to 3, such that minus 2b plus c is equal to 3 minus 4 when 4 moves to the right hand side, and we have minus 2b plus c is equal to minus 1. To make it easier, we can just multiply all through by minus 1, so we have 2b minus c is equal to 1. We can call this equation 4. Now looking at equation 4 and equation 2, we can say we can add the 2. Why am I doing that? Because I have plus c in equation 2 minus c in equation 4. If I add that together, the c's will cancel out. So I will be left with an equation with only b as an unknown, which I can solve for. So if I'm to add that now, the c's will cancel out. B plus 2b is 3b, minus 1 plus 1 is 0. So the value of b from that is 0. So b is 0. Then I can take either of equations. Okay, let me just say, since b is 0, I can use this in equation 4 to get the value of c. All right. So in equation 4, instead of 2b, I will have 0 minus c is equal to 1, so that c is now minus 1. Okay. So now I have b to be 0 and c to be minus 1. All that is left for me is to just get the value of a, and I can use what I got initially as a is equal to 2 minus b. Now b is 0, that means a will just be 2 minus 0. So if I'm to say I'm using b equal to 0 in, okay, let me even say from equation 1, then a will just be a plus 0 is equal to 2, since b is 0, and that means that my a, b is 2. So now we have found our partial fractions, and we are saying that to express the function that we are given originally in partial fraction, we said that that function f of x that we are given originally in the question is equal to a over x plus 1 plus bx plus c, all divided by x raised to the power 2 plus 2. Now if we are to slot in the values of a, b and c, a was gotten to be 2, b was gotten to be 0, c was gotten to be minus 1. So if we use these values for a, b and c in the expression for the partial fraction, that means our function of s expressed in partial fraction will be 2 divided by x plus 1. You can say plus b is 0. All right. So that is knocking itself out. Then expression c is minus 1 plus minus 1. But instead of saying plus minus 1, we can just say it is minus 1 over s raised to the power 2 plus 2. And that is the expression in partial fractions as requested. You are welcome to DaveTuts Academy, and today we are going to be getting the derivative of a function by using the first principles. Now, the function that we are given was 5x minus 6 divided by x raised to the power 2. And for us to use the first principles to get the derivative, we need to define another function f of x plus h, where h is just a very small addition to x. So from our original function, any place where we see x, we now input x plus h. So we now have our new function to be f of x plus h to be 5 into bracket s plus h minus 6 divided by s plus h over 2. Wherever we just have x, we are now putting x plus h. So these are the two equations that we're going to use to get our derivative from the first principles. And there's a general formula that is employed to find the derivative from the first principles. And is given that the derivative of the function of x is the limit as h tends to 0 of the function of x plus h minus the function of x, all divided by h. And you know, from our initial equation, we have the function of x defined already. We also have the function of s plus h defined already. We just need to plug this into the formula for the derivative from first principles. So our derivative, the derivative of the function of x, will be limit as h tends to 0 of, now we have function of x plus h. Okay, so the whole of our function of x plus h was gotten to be 5 into bracket s plus h minus 6 divided by x plus h raised to the power 2. Okay, that's the whole of the function of x plus h. Then minus the function of x. Now I'm going to put the function of x in brackets to have minus 5x minus 6 over x raised to the power 2, all divided by h. Okay, so now we can try and open this a little to say this will give us limit as h tends to 0 of, if I am opening the bracket of 5 into bracket x plus h, I will have 5x plus 5h, now minus 6 divided by x plus h raised to power 2, okay, minus 5x. When this minus and this minus interact, they will multiply to be positive, so minus 6 over x raised to power 2, all divided by h. The task before us now is to simplify this. Already we are seeing that 5x and minus 5x will cancel out. So once we are getting all the remaining entities, our aim is that as much as possible, we want to eliminate h from the denominator. Why are we doing that? Because originally, if we take a value of h tending towards 0, in the extreme case in which h is equal to 0, we'll see that the denominator will be 0. And in that case, we'll be dividing a number, whatever the numerator is, by h, which is 0, and that will be infinity. So we don't want to use that. We just want to eliminate the h, such that whatever values we have remaining, that will take the of our derivative. So we'll go ahead to do that and have our equation as limit as h tends to 0 of, now we have 5h, all right, minus 6 divided by x plus h raised to power 2, okay, plus 6 over x raised to power 2, all divided by h. So now I can actually bring out my h, which is the denominator, to say I will have limit as h tends to 0 of 1 over h, okay, into brackets. Now 5h, I'm leaving 5h because already the 1 over h can easily cut 5h, and I will know that that will remain 5. But these other two entities, let's say I'm finding the LCM, I have x squared multiplied by x plus h raised to power 2. So if I'm taking 6, x plus h raised to power 2 will cut out, so I have minus 6 x raised to power 2 plus 6 into bracket x plus h raised to power 2. All right, so with this I can further open up my bracket to see how to also eliminate h from the denominator. So I want to open up this x plus h raised to power 2 to see what I'm going to get. So if I'm to actually write out my equation again, having in mind that I want to open the bracket of x plus h raised to power 2, I'll find the derivative of x to be limit as h tends to 0 of 1 over h multiplied by, now I have 5h already, all right, 5h plus, I found the denominator to be, okay, I'll come back to that. Now this is minus 6 into bracket minus 6s squared, okay, plus 6 into bracket x plus h raised to power 2 is what we have initially, and that will be x plus h multiplied by x plus h, all divided by x squared multiplied by x plus h all squared. Now if I'm to open up the bracket of x plus h multiplied by x plus h, okay, we know, okay, we have 6 as the multiplying factor, so x multiplied by x is x squared, x multiplied by h in two places will be 2sh, then plus h multiplied by h is h raised to power 2. So if I'm to put that into my equation now, I'll have this as the limit as h tends to 0 of 1 over h multiplied by 5h, okay, plus minus 6s squared plus 6s squared in opening that bracket, then 6 multiplied by 2sh will be 12sh, and 6 multiplied by h squared is 6h squared, all divided by s squared into bracket s plus h squared. Now minus 6s and 6s squared will cut each other out, all right, so I will have my new expression to be limit as h tends to 0 of 1 over h multiplied by 5h plus, now I'm only having 12sh and 6h squared. 6h is common to both, so I can write out, in this case you can see 6h is a common factor to both, So I can just say I want to write out my plus 6h. So in the first entity, I will have 2x remaining, and the second one I will have h remaining, divided by x raised to power 2 multiplied by x plus h raised to power 2. Now we can see that we are having h common in the two entities now. We have 5h and 6h. So if I'm to factor out that particular h, noting that I have 1 over h initially, and remembering that our aim is to eliminate h from the denominator as much as possible. So I can have this as limit as h tends to 0 of 1 over h into bracket h. Okay, so the remaining will be 5 plus 6 into bracket 2x plus h divided by x raised to power 2 multiplied by x plus h raised to power 2. So with this, I can see that h standing alone as the denominator can easily cancel out, so that my new expression now I can have to be limit as h tends to 0 of 5 plus 6 into bracket 2x plus h divided by x raised to power 2. But now the expression for x plus h raised to power 2, if you remember, we have gotten initially as written in red with the 6 multiplying it. So if you want to just open that up, we'll see this is limit as h tends to 0 of 5 plus the numerator is still the same, 6 into bracket 2x plus h, all divided by x raised to power 2. So now I can write this as the value that I got initially for x plus h raised to power 2. Okay, so that will be x raised to power 2 plus 2xh plus h raised to power 2. So if I'm to now express that, I will have limit as h tends to 0 of 5 plus 6 into bracket 2x plus h divided by, now if I'm multiplying x raised to power 2 into each of the entities in the quadratic function, I have x raised to power 4 plus 2x raised to power 3h, okay, plus s raised to power 2 h raised to power 2. So now I can now use the extreme value of h tending to 0 just to say h is equal to 0 as an extreme case. Now we'll see that all the multiples of h, they will cancel out. So wherever we have h and the number that is multiplying that, we know that that will be like multiplied by 0. So all those will cancel out, and that will leave us with our solution to be the derivative is 5 plus 12 divided by x raised to power 3, and that is the derivative from first principles. Now we are to find the integral of x multiplied by the square root of 1 minus x dx, and the best way for us to solve this is to use integration by substitution, because we want to actually find this straight away. We are going to see that it's going to be quite difficult, but if we introduce another element and we can say let u be 1 minus x, so we are going to rewrite our equation as a function of u, not as a function of x now. So from u is equal to 1 minus x, the u dx will be minus 1, because the integral of minus x is minus 1. All right, and if we are to cross multiply, we see that du is minus dx, and consequently if we also reverse that, dx will be minus du. So from u is equal to 1 minus x, we can make x the subject of the formula. When x moves to the left hand side and u moves to the right hand side, we'll have x is equal to 1 minus u. So from our original given question, instead of writing the integral of x multiplied by the square root of 1 minus x dx, let's substitute for all the values of x, 1 minus x, and ds. So now x will be 1 minus u, right? Then 1 minus x, we notice that that is u. So we have root u, because square root of 1 minus x, so we have square root of u. Now instead of writing dx, you can see that dx is now minus du. the x is now minus the u, and this is what we can now go ahead to try and solve, because we've substituted for the value of x, 1 minus x, and the x. So we can try and solve this because this is quite simpler for us. We can easily open up the bracket, bring in the law of indices, differentiate, and our answers will come out for us. So this will give us integral of 1 minus u multiplied by u raised to power 1 over 2, because square root of u is u raised to power 1 over 2, then multiply by minus the u. Alright, so if you bring the negative forward, that will be minus u raised to power 1 over 2 multiplied by 1 minus u du. So if you want to just solve this, we can see that this is quite better than what we have initially, and we can go ahead to try and solve that. If we are to open the bracket, we know that minus u raised to power 1 over 2 times 1 is minus u raised to power 1 over 2. Minus u raised to power 1 over 2 times minus u, the negative signs will multiply each other out to be plus. Then half we add to 1, so we have u raised to power 3 over 2, and we're integrating with respect to u, so we have du. Alright, so now generally if you want to bring the formula for integration, now we just need to add 1 to the power and divide by the new power. So the negative sign is still retaining its position. We have u raised to power half plus 1 divided by the new power, which is half plus 1. The same thing applied to u raised to power 3 over 2. We add 1 and divide by the new power, which is 3 over 2 plus 1. And solving this, we have u raised to power 3 over 2 divided by 3 over 2, because half plus 1 is 3 over 2. Alright, then 3 over 2 plus 1, that will be 5 over 2. Okay, and then the new power will also be expressed as the denominator, 3 over 2 over 2. Then we have the constant of integration plus being introduced. Now these two will normally come up for us to have minus 2 over 3 multiplied by u raised to power 3 over 2, okay, plus now 3 plus 2 divided by 2 is 5 over 2, and in the same way 2 will come up, so we have 2 divided by 5 u raised to power 5 over 2 plus c. But nobody gave us u originally in the question, so we can recall that our u is actually 1 minus x. So we can bring in 1 minus x back, so that our equation will now be the integral of x multiplied by the square root of 1 minus x ds is, we just write this equation to say 2 over 5. Now instead of writing u is 1 minus x raised to power 5 over 2, okay, minus 2 over 3, 1 minus x raised to power 3 over 2 plus the constant of integration c, and that is our solution. So here in this question, we are given the ranks of 10 candidates in 2 tests, and we have to calculate the Spearman's rank correlation coefficient. Now, what do we use the Spearman's rank correlation coefficient for? Is this to test for the strengths or the weaknesses in the relationship between 2 sets of data, and in this particular case, it will be a means of testing for how strong or how weak the candidate perform in the 2 tests that are being considered in this particular case. So there is a general formula that is used to obtain the Spearman's rank correlation coefficient, but for us to use that formula, we are going to generate a table of values, and from that table of values, we will look at the marks in each of the tests. We'll find the difference in the marks, and then we'll find the square of the difference. As a rule of thumb, for us to know that we're on track, the difference will sum up to be 0. After we have gotten the difference of all the tests, the difference should sum up to 0, but then we are still going to find the square of the difference. So if you are to populate our table here, for test 1, we also input the values as given in the table, and then the same thing we also do for the test 2. Okay, now once this is done, we can now say we want to find the difference difference will be the difference between the test 1 and test 2. Like in the first case, we have 10 and 10. So you can say 10 minus 10, and that will be 0. So 6 minus 9 minus 3. 4 minus 3 is 1. 5 minus 4, 1. 3 minus 2, 1. 1 minus 1 is 0. Okay. 8 minus 5 is 3. 9 minus 6 is 3. 7 minus 8 is minus 1. And 2 minus 7 is minus 5. For us to know that we are not missing our question, we need to check. Let's check for the sum of these differences. And if we bring in our calculator and input all the values, 0 minus 3 plus 1 in 3 places, plus 0 plus 3 in 2 places, then minus 1 and minus 5. Okay, that is 0. That means that we didn't make any mistake from our calculation so far. Then we can now go ahead to say we want to evaluate the square of the difference. So for each entry we can get the square. Square of 0 is 0. Square of minus 3 is 9. Square of 1 is always 1. Square of 0 is 0. Square of 3, as we got before, is also 9. Square of minus 1 is 1. Square of minus 5 is 25. Okay, so now what is the formula for the Spearman's rank correlation coefficient? We are going to be making use of the sum of the square of the difference. So if we input all those, 0 plus 9 plus 1 in 3 places, plus 0 plus 9 in 2 places, plus 1 plus 25, that's 56. So sigma d raised to power 2 is 56. Then we are going to try and evaluate our Spearman's rank correlation coefficient from this. And generally, the Spearman's rank correlation coefficient R is given as 1 minus 6 multiplied by sigma d square over n into n square minus 1. Now, n is the number of entry, and d raised to power 2 is the square of the difference, and we have summed that already. So we need to consider that n is the number of, in this particular case, number of samples we are giving, which corresponds to the number of candidates, which is 10, such that our R is equal to 1 minus 6 times 56 over 10 into bracket 10 raised to power 2 minus 1. Okay, so we want to evaluate that. That will be 1 minus, let's bring in our calculator. So 56 times 5 times 6, so that's 336 divided by 10 into 10 raised to power 2 is 100. 100 minus 1 is 99. Okay, so if we want to use our calculator to solve for that, 336 divided by 10 times 99, the calculator will just divide also. So we add that to be 56 over 165. So we have 1 minus 56 over 165. Okay, and as we find the LCM as 165, we are going to have 165 minus 56. So what's 165 minus 56? Okay, we can even just say 1 minus answer. So that's 109 over 165. So we have this to be 109 minus 109 divided by 165. And if you want to get that in decimal places, that's 0.660. So this 0.66. The fact that the rank correlation is positive means that the two tests are a good juxtaposition of one another. They have a strong relationship. In this question, we are told that a committee of 3 men and 2 women is to be formed from 4 men and 6 women. So let's note that we are given that is a committee of 3 men and 2 women out of 4 men and 6 women. So we are to find the number of committees that can be formed if there are no restrictions, then the number of committees that can be formed if a particular man and a particular woman cannot serve together on the same committee. Without any restrictions, okay, that's the condition that we are giving. We are to get 3 out of 4 men, okay, and 2 out of 6 women. This is a simple question on combination Okay, so 3 out of 4 men will be 4 combination 3. Okay, then we have multiplied by 2 out of 6 women will be 6 combination 2. So it's as simple as just getting this value and multiplying them together. So what we can do, 4 combination 3 will be 4 factorial, and 4 factorial is 4 multiplied by 3 factorial, because I know the 3 factorial will cut out, then divided by the same 3 factorial multiplied by 4 minus 3 factorial, and 6 combination 2 will be 6 times 5 times 4 factorial, then 6 minus 2 factorial multiplied by 2 factorial as the base. So if I were to open up those brackets and simplify this, in the first case the 3 factorials will cut out, then 4 minus 3 is actually 1, so I will have 4 over 1 here. Then multiply by the second case, we can have 6 times 5 times 4 factorial over 2 factorial is 2 times 1. Alright, then multiply by 6 minus 2 is 4 factorial. The 4 factorials will also cancel out, then 2 can cut 6, and this will be 4 times 3 times 5, that's 12 times 5, which is 60 ways. So we have 60 ways to pick this particular question if there are no restrictions. Okay, good. Now in the second case, we are told that a particular man and a particular woman cannot serve together on the same committee. As an advocate for working smartly, let's consider a case in which first they can serve together. We are told that they cannot serve, okay, but let's consider a case that they can serve together. Then we know that the number of ways will be now the total fixed number of ways minus a case in which they cannot serve together. So if you are to assume that they must serve together, that means that we are fixing their position, we are restricting their more, we cannot actually take them out. So that will mean that we have taken out one man, then we have taken out one woman also. So we'll now be left with 2 men to be taken out of 3 men and 1 woman to be taken out of 5 men. So if they must serve together, that means their positions are fixed, and then we can find the remaining options, of which we can actually just substitute this answer here from 60 committees that we got initially. So if you are to evaluate this particular case in which they must serve together, you can say it's 3 combination 2 multiplied by 5 combination 1, okay, because one of the men is fixed already and one of the women is fixed already also. So we can just evaluate this to be this multiplied by 5 multiplied by 4 factorial over 1 factorial into 5 minus 1 factorial. Okay, so if you want to evaluate that, that will just be 3 multiplied by 2 factorial over 2 factorial. 3 minus 2 is 1. Those 2 factorials will cut out, then 5 times 4 factorial divided by 1 times 4 factorial. The other 4 factorials will also cut out. So this will just be 3 times 5, and that is 15 committees. Now, this is the case in which they must serve together. And already, you know, we're only talking about the same 3 men out of 4 and 2 women out of 6. So, the case in which they cannot serve together will be 60, which is the total when we don't have any restriction, minus this particular case in which they must serve together. So we can just express that out that if they cannot serve together, then we have 60 minus 15. So it's just 60 minus 15, and that is 45 committees. 45 committees is what we can get if they cannot serve together on the same committee. So here we have this lovely question that I love so much. We are told that 1 out of every 3 boats produced by a machine is effective. If 4 of the boats produced by the machines are selected at random, we have to find the probability that exactly 2 are defective, at least 1 is effective, or at most 2 are defective. This is a classical example of what is called the binomial probability. And the formula that is used to express this is n combination r multiplied by the probability of success raised to power r, then multiplied by the probability of failure, which will now be 1 minus p. If p is success, then 1 minus p is failure, raised to power n minus r. Now, I'm going to interpret this. So this is the probability of getting r successes on n repeated trials in an exercise that has 2 possible outcomes. And this formula is actually fitting our question perfectly because we have our 2 possible outcomes to be that is either the boat is defective or the boat is not defective. So we are looking for R successes out of n repeated trials. So now that will fit exactly into our question, but we need to note, okay, what is the case of a success and what is the case of a failure? For this particular question, we are being told that we have some boats that are produced. Some may be defective, some will be non-defective. So we can take the defective as failure, the non-defective as success, or we can even reverse it as I'm going to do here. So I'm going to say that the probability of selecting a defective boat, that's the P, probability of D, probability of selecting a defective boat, is going to be, we are told that 1 out of every 3 boats is defective, so that will be 1/3. Then the probability of selecting a non-defective boat will now be 1 minus the probability of selecting a defective boat because of the rule of probability. The sum will add up to 1, so that will now be 1 minus 1/3, which is 2/3. So if you want to use the binomial probability in this particular case, like the first question is quite straightforward. We are told that we have to find the probability that exactly 2 boats that are picked out of 4 are defective. That means we are going to be having 2 boats that were picked to be defective, 2 to be non-defective. And already we know that the total possible outcomes is 4 because we are selecting 2 out of 4. So that will give us like 4 combination 2, probability of having defective raised to power 2, then probability of having non-defective raised to power 4 minus 2. And that is what we are going to do exactly. So the probability that exactly 2 of the 4 boats are defective will now give us, now we have 2 out of 4, all right? So that will be 4 combination 2 because our n, the total number of outcomes is 4. We want to pick 2 cases out of it. So we have 4 combination 2 multiplied by the probability of defective raised to power 2, then probability of non-defective raised to power 4 minus 2. And we have to just evaluate that 4 combination 2 is 4 factorial divided by 4 minus 2 factorial multiplied by 2 factorial. Then multiply by what's the probability for the defective? That's 1/3 raised to power 2. Multiply the probability for the non-defective. That's 2/3 also raised to power 2. So if you are to express this out, I can just say this is 4 times 3 times 2 factorial over 4 minus 2 is 2. So we have 2 factorial. Then 2 factorial is 2 times 1. The 2 factorials will cancel out. Then this I can multiply with 1/3 raised to power 2 is 1/9. 2/3 raised to power 2 will be 4/9. Okay? So if I'm to multiply all that out and cut as appropriate, as you can see, that will give me 8/27. That is the probability of selecting exactly 2 boats that are defective. Again, question number B, we have to find the probability that at least one of the 4 boats selected is defective. Now, let's interpret this question. That means that we're having 4 boats, okay, but at least one of them is defective. I've always been telling us, I'm an advocacy for working smart. We don't want to be trying to evaluate situations in which 1 is defective, 2 are defective, 3 are defective, 4 are defective. No, we don't need that. So if you are to pictorially depict this, let's say in this first case, we don't have any that is defective being represented by the red ink. Then in the second case, we have 1 that is defective being represented by blue. In the second case, we have 2 that are defective being represented by blue, then 2 non-defective being represented by red, and on like that. Now we can see each of these scenarios, all right? But the case in which we are going to have at least one of the boats to be defective are the second to the last scenarios that are being shown in the box. They are being boxed together. These are the cases in which at least one of the boats is defective, all right? I use blue to represent the defective boats here. So this implies that the probability that we need to get is 1 minus the case in which none of the both is defective. The standalone case, the one to the left, is the case in which none of the both that is selected is defective. So instead of just taking the probability for each of the 4 cases, you can just say it is 1 minus probability that none is defective. So if you want to bring in our formula, so we have none is defective out of 4, that is 0 is defective out of 4. That will give us 4 combinations 0 multiplied by the probability of defective, which is 0, okay, raised to power 0, then multiply by the probability of the non-defective times 2, in this case, which is now 4. I'm trusting that we just get this because it's quite easy if we take our time to understand it. So if you bring in our formula, expressing 4 combinations 0 as 4 factorial over 4 minus 0 factorial 0 factorial, then probability of the defective is 1 over 3 raised to the power 0, then non-defective 2 over 3 raised to the power 4. So now if you want to just write this out, this will be 1 minus 4 factorial over 4 factorial. 0 factorial is 1, so we don't need that. 1 over 3 raised to the power 0 is also 1. Then multiply by 2 raised to the power 4 is 16. 3 raised to the power 4 is 81. So that will give us 1 minus 16 over 81. And we are to express that, that will be 1 minus 16 over 81. And that will give us 65 over 81. Just noting that we can use 1 minus probability that none is defective out of 4 will help us to solve this instead of taking each cases in which at least 1, at least 2. No, we don't need to follow that track. So in this C scenario, we are told that at most 2 boats that are picked are defective. Again, let's just find this as a very good means that we can use to interpret it. We are told that, of course, there are 4 boats, but we are asked to ask the probability that at most 2 of those boats that are picked are defective. Okay, now just like we are doing in the other case, I will also draw out all those case scenarios in which at most 2 of the boats are going to be defective. So we are going to have that stretched out now. So we are told at most. Okay, so let's draw those case scenarios in which you can have at most 2 out of the 4 are defective. So I have, in this case, all blue. I'm using blue to represent those that are not defective. They are okay. So blue is okay in this case. Okay, so for this first case, we are saying that all of them are good. All of them are not defective. Okay, so in the second case scenario, let's have a case in which one of them will be defective. So we have 3 blues and 1 red. Okay, so yeah, we have that 1 out of 4, okay, just only 1 out of 4 is defective. And then in the third scenario, let's have that just 2. In this case now, we are going to have 2 out of the 4 boats to be defective. So the 2 in red are defective, the 2 in blue, they are quite good, they are non-defective. So here we have, this is the case in which we have at most 2 are defective. All right, so the probability that we are being asked to find will be the consideration of these 3 scenarios, because initially none is defective, in the middle case 1 is defective, in the last case that is the maximum, that's the point at which we have the maximum defective to be 2. So we are going to have, to get the probability of at most 2 are defective, we'll have probability of none is defective, okay, plus the probability of 1 is defective and 3 are not defective, okay, plus the probability that 2 are defective and 2 are non-defective. So we just need to plug in our combination formula for the binomial probability here. None is defective will be 4 combinations 0 into probability of defective raised to power 0. We now multiply by the probability of non-defective raised to power 4. So once we have that, plus the probability for 1 is defective will be 4 combination 1 now, because we are having 1 to be defective, multiplied by the probability of the defective. Defective will now be 1, multiplied by the probability of non-defective now to be 3. You can notice this is just like the binomial expansion. In the third case, we have probability of 2 are defective, 4 combination 2, multiplied by the probability of defective raised to power 2, okay, multiplied by the probability of non-defective raised to power 2 also. So this is what we just need to open up. 4 combination 0 is just 1, just like we found in the previous question. Then 1 multiplied by 1 over 3 raised to power 0 multiplied by 2 over 3 raised to power 4. Okay? Plus 4 combination 1. Well, we can also work that out. ID that is 4. So we can say if you want to show the working, 4 combination 1 is 4 times 3 factorial divided by 4 minus 1 is 3 factorial, and then we can see that will give us 4. Then 4 combination 2 is 4 times 3 times 2 factorial over 4 minus 2 is 2 factorial, then multiply by 2 factorial. The 2 factorials will cut out, and this will give us 6. So we can just plug in those values into the equation straight. Okay. So we can add plus, this is 4 multiplied by probability of defective 1 over 3 raised to power 1 times probability of non-defective 2 over 3 raised to power 3 plus, now 4 combination 2 is 6 multiplied by probability of defective 1 over 3 raised to power 2 times probability of non-defective 2 over 3 raised to power 2. So I'll just simplify this. The 1 times 1 over 3 raised to power 0 is 1. Then 2 over 3 raised to power 4 is 16 over 81. 2 raised to power 4 and 3 raised to power 4. Then in the second case, we have 4 multiplied by 1 over 3. Then 2 over 3 raised to power 3. That will be 8 over 3 times 3 times 3. That's 27. Alright. Okay, and the last case in which we have 6 multiplied by 1 over 3 raised to power 2 will be 1 over 9. 2 over 3 raised to power 2 will be 4 over 9. Now, I don't want to cut out because the same base will apply to all the 3. Now, we have 8 times 4, 32 over 81. Okay, and the third is 6 times 1 times 4, 24 over 9 times 9 is 81. So, if you are to add 16 and 32 and 24, 16 plus 32 plus 24, that will be 72. So, we have 72 over 81. I think 9 can go in both numerator and denominator. So if I divide by 9, this will be 8 and this will be 9. So the probability of getting at most 2 of the both to be defective will be 8 over 9. What an interesting question. We are given 3 forces acting on a body of mass 1.2 kilogram, and we are to find the resultant force and the acceleration of the body. Now, to get the resultant force, that will mean that the concentration of all 3 forces and finding a force that can represent all of them that is acting on the body. And to do this, the best approach is to divide this into the components of the resultant force. We are going to have an horizontal component and we are going to have a vertical component. So if we denote that with X and Y, we can see that the 6 Newton force is only lying on the Y-axis, whereas the 8 Newton force is inclined at an angle to both the X and the Y-axis. So we are going to find the resolution to both the vertical and the horizontal axis, and we can use that to get the vertical and horizontal component of the 8 Newton force, and the same thing we do to the 4.5 Newton force. So taking the 8 Newton force, we have a vertical component and an horizontal component. So how do we go about this? Now, at the point of its angle, we will see that this will be angle 30 degrees, so that 30 and 150 will add up to 180, which is the angle of a straight line. So here we are going to have the resolution on the vertical axis will be 8 cos 30. And not to be confused, you can work out how we got that. This is forming a triangle in which you can take 8 as the hypotenuse. This is angle 30. Then we have here as the opposite of angle 30, and this as the adjacent. So 8 is the hypotenuse. And then by the principle of SOHCAHTOA, we can consider sine theta, cos theta, and tan theta. But if we want to find the vertical component, which is the adjacent, we can say that will correspond to cos 30 is equal to, cos 30 is adjacent over hypotenuse. So here we have the adjacent divided by 8, which is the hypotenuse, such that the adjacent, which is the vertical component here will now be 8 cos 30. That is how we arrive at this. And the same principle applies to the other side. So the horizontal component is 8 sin 30. So in the same way, we can look at the 4.5 Newton force and also resolve it into its vertical and horizontal component. Here the angle will now be 60 because 60 plus 120 is 180, which is angle on a straight line. So we have the horizontal component to give us 4.5 sin 60, and then the vertical component coming down will give us 4.5 cos 60 degrees. So we have gotten the resolution of each of these forces to the horizontal and vertical axis. Now the resultant force will be the sum of all these forces considering the horizontal and the vertical axis. So if you call this R1, this R2, and this R3, you can find R total, which you are using to denote the resultant force, as divided into the horizontal and the vertical component, and then that will be the sum of each of the forces with respect to their component, both horizontal wise and vertical wise. So we have R1x and R1y plus R2x, where x is the horizontal component and y is the vertical component, plus R3x, R3y. So our task is just to plug in our values into all these, and so that we are going to have our resultant force to be. Now let's take R1x. We can see that R1 does not have any horizontal component, so that will be 0, and then it has a vertical component which is directly on the y-axis. That will be 6 Newton, and it is positive because it is on the positive y-axis, so we have 6. Now for the second force, the 8 Newton force, we can see that on the horizontal axis, 8 sin 30 is on the negative side of the axis. So we are going to put that as negative, and 8 cos 30 is also on the negative side. So we are going to have the component of the second force to be minus 8 sin 30, and the vertical component is going to be minus 8 cos 30. It's because of the notation that I'm using here. So some other people would have said that they want to just 8 cos 150, 8 sin 150, but breaking it down into its component like this, I prefer, so that I can easily just plug in my value. So for the 4.5 Newton, the horizontal component is positive, so I have 4.5 sin 60, while the vertical component is negative, so I have minus 4.5 cos 60. So the resultant force R total is now 0 minus 8 sin 30 plus 4.5 sin 60, adding them component wise. That's for the horizontal component. Then the vertical component, 6 minus 8 cos 30 minus 4.5 cos 60. So if you are to add all this, let me bring in my calculator. So I have minus 8 sin 30 plus 4.5 sin 60. Okay. That will be minus 0.10288568. I can round that up to 4 decimal places. So we have minus 0.1089. That is for the x component, for the horizontal component. Then for the vertical component, we have 6 minus 8 cos 30 minus 4.5 cos 60. And that will be minus 3.1782. So minus 3.1782. So now these are the vertical and horizontal component for the resultant force. We have the horizontal as Rx and the vertical as Ry. But we have to find the magnitude of the resultant force. So that magnitude, the magnitude of that resultant force will be the square root of the sum of the squares of the vertical and the horizontal component. So if you are to evaluate that with our calculator, we are saying we are going to find square root of the rx raised to power 2 plus ry raised to power 2. So you can just say minus 0.1089 raised to power 2 plus minus 3.1782 raised to power 2. Now the sum will be 10.0891. So we have square root of 10.0891, and if you are to evaluate that, that will give us root answer 3.1763. You can just round off to any appropriate decimal places that we like. For me, I will just say that will be 3.176 newtons. That is the resultant, that's the magnitude of the resultant force. Okay, so now we also have to find the acceleration of the body. And from the question, we have been given the mass to be 1.2 kilogram. Then we just need to record that force is mass times acceleration. F is equal to ma. We just got our F, and m was given in the question. So F is the resultant force, which got to be 3.176 newtons. And the mass m was given in the question to be 1.2 kilograms. So m is 1.2 kg. So meaning that the acceleration is what we are looking for. And from our original equation, acceleration will be force over the mass. That will be 3.176 divided by 1.2 divided by 1.2. So we can also use our calculator to find that our answer divided by 1.2. So we have 2.6469. Okay, so our acceleration is, to round it up, is 2.647 meter per second square. Okay, here we are told that a stone is dropped from the top of a building which is 80 meters high. Then we have to find in meter per second the velocity with which it hits the ground. We have to take acceleration due to gravity as 10 meter per second square. So now if you are drawing our building and we have a stone that is to be dropped from the top of the building, okay, then we are told that this building is 80 meters high. This is 80 meters. That's the height of the building. All right. Okay. Then we have to drop that stone and we have to find the velocity with which it hits the ground. Now, when they say that they are dropping, the initial velocity is 0. Okay, because initially before they drop it, you will be holding a stone before you drop it. So the initial velocity u is 0 meter per second. We have to find the final velocity v, and we are told that the acceleration due to gravity g is 10 meter per second square. So from our equations of motion, which equation is actually best fitting our question here, we can see it is v square is equal to u square plus 2as, in which our s now will be 80 meters. V is what we are looking for. We know u to be 0, and acceleration due to gravity g will be our acceleration in this case because it's a free fall. So we have our distance to be 80 meters. So we can input all these values into the equation. I can say the v raised to power 2 that we are looking for, v raised to power 2 is equal to 0 plus 2 multiplied by acceleration due to gravity is 10, okay, then the distance is 80. So if you are to evaluate that, we have 2 times 10 is 20, 20 times 80 is 1,600. So v will be the square root of 1,600, and that is going to give us 40 meters per second. So that's our answer. In this question, we are given that vector A is 6i minus 5j, vector B is 2i plus 7j, and vector C is 8i plus 2j. And we are to find x and y such that C is equal to xa plus yb. Now, in this particular question, x and y are being given as scalars, and C was given as xa plus yb. All we just need to do is to substitute for C, A, and B, and then we open up our bracket, putting the value of C is equal to 8i plus 2j. That's vector C is equal to x. X is a scalar which is multiplying vector A. So we have x into bracket, A is 6i minus 5j, alright, plus y is another scalar multiplying vector B, and B is 2i plus 7j. So we have y into bracket 2i plus 7j. Now, having this, we can go ahead and open up our bracket. So we are going to open up that bracket, and after opening up the bracket, we can now collect the like terms. But first, let's open up the bracket. So we are going to have 8i plus 2j is equal to 6xi minus 5xj plus 2yi plus 7yj. And now, if you rearrange, you can say this is 8i plus 2j is equal to, looking at the I component, we have 6x and 2y. So we have into bracket 6x plus 2y all multiplied by I. Okay. Then looking at the j component, we have minus 5x and 7y. So we can also group those together. We have minus 5x plus 7y on the right j. And now we have two sides of the equation. We have the left hand side, we have the right hand side, and since they are equal, component wise, the component of I on the left hand side will be equal to the component of I on the right hand side. So we have 6x plus 2y is equal to 8, and now we can divide all through by 2 to get 3x plus y is equal to 4, and we can call that equation 1. Then looking at the other component, the j component, we can see that we have minus 5x plus 7y is equal to the j component on the left hand side is 2. So we have minus 5x plus 7y is equal to 2 as our equation 2. So this is now a simultaneous equation in two variables that we can solve with whatever method is suitable for. I'm going to be using the substitution method. So now from equation 1, if I am to make y the subject of the formula, I can move 3x to the right hand side such that I have y is equal to 4 minus 3x, and I can call this equation 3. Now I can use equation 3 in equation 2 so that anywhere I see y, instead of writing y, I will now put in 4 minus 3x. So equation 2 will now give me minus 5x plus 7. Instead of y, I will now put all the values of y of equation 3, which is 4 minus 3x, and then that is equal to 2. Now I can open up that bracket. Okay, so open up the bracket to now give me minus 5x. 7 multiplied by 4 is 28. 7 multiplied by minus 3x is minus 21x is equal to 2. Okay. So now minus 5x minus 21x will be minus 26x. I will move 28 to the right hand side. So I have 2 minus 28 such that minus 26x is equal to minus 26. And dividing both sides by minus 26, note minus 26, x will now be equal to 1. So now that's the value of x, and I can substitute x is equal to 1 in any of the three equations that I have. Now from equation 3, you know that y is equal to 4 minus 3x, but instead of saying x now, we can just substitute 1 for x. So that is 4 minus 3 times 1, and that is equal to 1. So the scalars x and y that we're asked to find is that x is equal to 1 and y is also equal to 1. That's the solution to our question. So here in our question, we are given vectors a and b such that the magnitude of a is 3 centimeter, the magnitude of b is 10 centimeter, and the magnitude of vectors a plus b is root 139. We have to find the angle between a and b and the dot product of a and b. First, before we just go ahead to try and evaluate this, I would like to draw a representation of vectors a and b so that we have a plus b. Now the first thing that should come to mind is the parallelogram law of vectors, since we are having vector a and vector b and vectors and vector a plus b. So if you are to note our Cartesian coordinates, and let's say this is our a and we also have our b like this, inclined at an angle to each other, the vector a plus b we can denote as the resultant of the two vectors. Okay, so if we draw a parallel to vector b and another parallel to vector a, the vector a plus b, which is the resultant vector, is going to be looking like the diagonal here. So this is vector a plus b, and then we're asked to find the angle between vectors a and b. That's being shown in green. That is the angle between vectors a and b. All right, so let's call that alpha. But now, looking at this diagram, we can note another angle here. So this angle, we will call it theta. Now, by the cosine rule, which is the resolution of the parallelogram law of vectors, normally we can express a, b, and a plus b in a relationship with one another, and that is given at the magnitude of a plus b raised to power 2 is equal to the magnitude of a raised to power 2 plus the magnitude of b raised to power 2 minus 2 multiplied by magnitude of a multiplied by magnitude of b multiplied by the cosine of angle theta. And we are noting our angle theta already. It's not the angle between the vectors a and b. It's just as noted in the diagram. So if we are to substitute with respect to all these values, we are going to have root 139 raised to power 2 is equal to 3 raised to power 2 plus 10 raised to power 2 minus 2 times 3 times 10 cos theta. Now, we don't know theta and we know the other values. So we can say we want to evaluate that. The square root and the square will knock themselves out so that we have 139. 3 raised to power 2 is 9. 10 raised to power 2 is 100. 2 times 3 times 10 is 60. So we have this. And if we move 60 cos theta to the left hand side, that will give us 9 plus 100 is 109. Then when 139 moves to the right hand side, that will be minus 139. So we have 60 cos theta is equal to minus 30. And if we divide both sides by 60, okay, so we have cos theta is equal to minus, that's 1 over 2, that's minus 0.5. So theta will be arc cos 0 minus 0.5. Now, we don't want to make that mistake. We don't want to leave out the negative sign. So we have arc cos minus 0.5. So if we take out our calculator and we try to evaluate that, that will be 120 degrees. So angle theta is 120 degrees. Now, but looking at the diagram that we noted the other time, we're asked to find angle alpha, not angle theta. But because this vector A is also parallel to this notation line that we indicated before, this is also angle alpha. And alpha and theta, actually, they are supplementary. They add up to 180. So we can say that theta and alpha, they are supplementary. So since they are supplementary like that, that means that they add up to 180 degrees. So we can say that theta plus alpha is equal to 180 degrees, and that means that alpha is equal to 180 minus theta. Now we have gotten theta to be 120 degrees, so our alpha will be 180 minus 120, and that will be equal to 60 degrees. So the angle between vectors A and B is 60 degrees. So now we're asked to find the dot product of vectors A and B. Now the scalar or dot product is defined as the product of the Euclidean magnitudes and the cosine of the angle between the two vectors. And here we are talking about vectors A and B. So A dot B is equal to magnitude of A multiplied by magnitude of B cos the angle between the two. We have gotten that angle to be 60. So we know the magnitude of A and B. Inputting that, we are going to have 30 cos 60. and cos 60 is 0.5. So that will be 30 multiplied by 0.5, and that is 15. Now, question number 1 for WAEC 2018 further maths theory paper. Here, we are given a matrix, and the determinant of the matrix is given as minus 24 with variable x featuring in the matrix, and we are asked to find the value of x from the determinant of that matrix. To solve this, we need to know that whenever we are solving for the determinant, we will first take the first value in the first row and the first column, we cross out the row and the column, and then we cross multiply the leading diagonal and subtract the other diagonal from it, as I'm going to be showing here. So we have x minus 3, then the product of the leading diagonal 2 and 6 minus x, minus the product of the other diagonal, which is 2 and minus 4. And then with this first entry, we can go on to the second entry. Now, some people make it a point of duty to use the second column, while some people make use of the second row. But here, I would prefer to use the second column, so minus 4. And then if I cross out the row and the column, I will notice that my cross multiplication will involve these other entries as shown. But I need to assign my sign, and here the second column will take a negative. So I have minus 4 into bracket the product of the leading diagonal 5 multiplied by 6 minus x, minus the product of the other diagonal, which is 2 multiplied by 2. Then with this, I will now add the third input in my third column. Now this is 3, and if I block out the row and column, I will have 5 multiplied by minus 4 and 2 multiplied by 2. So I have 3 into 5 multiplied by minus 4 minus 2 multiplied by 2. All this is the expression of the determinant, and we are told that it is equal to minus 24. So if you are to expand this bracket, what we need to be careful of is, in expanding our bracket, we don't make any mistake with respect to the signs. So like here, we have x minus 3. If you are to open the bracket, this will be 12 minus 2x. Now, negative numbers multiplying each other will be positive. So that will be plus 8. Then the negative number multiplied by another negative number again, plus 4 into bracket 30 minus 5x minus 4 plus 3 into bracket 5 multiplied by minus 4 is minus 20, minus 2 times 2 is 4. Everything is equal to minus 24. Now, if you are to look at this and try and simplify a little with what we are seeing, we are going to be noticing that our head minus 3 will be multiplying 12 and 8 is 20 minus 2x, plus 4 into 30 minus 4 is 26 minus 5x, plus 3 into minus 20 minus 4 is minus 24, and everything is equal to minus 24. Now, for the first entry, we are going to multiply these two values that we are having, so that we have 20x minus 2x squared minus 3 times 20 is minus 60, minus 3 times minus 2x will be plus, negative numbers will be plus 6x, then plus 24 times 6, 24 times 6 is 104. So we have 104. Now, 4 times minus 5 will be minus 20x, minus 24 times 3 is minus 72, is equal to, now for this minus 24, let's bring it to the left hand side so that we have plus 24 is equal to 0. So here, we can bring out, for each powers of x, let's write them out. We have minus 2x squared, and then for the x, we have 20x plus 6x minus 20x. So interestingly, we are saying that the 20x we knock out each other. So for the constant, we have 60 minus 60 plus 104 minus 72 plus 24 is equal to 0. So that means this will give us minus 2x squared plus 6x. Now, if you are to sum all this, we have minus 60 plus 104 minus 72 plus 24. That will give us minus 4 is equal to 0. Now, I can just divide all through by 6 by minus 2 because all of them, they are divisible by 2. So, everything over minus 2, minus 2, minus 2. And now, minus 2 will cancel out minus 2. So, we have x squared. Now, 6x divided by minus 2 is minus 3x. And minus 4 divided by minus 2 will be plus 2. Because the negative will also cancel out. So, here we have this quadratic equation that we can try and look for the product and the sum so that we can input here. Now, if you have 2x squared and 3x, we are looking for two numbers that we can multiply to get 2x squared. If we notice minus 2x and minus x, negative numbers will cancel out so that we have 2x squared. Then if we are to add minus 2x and minus x, we will see that it will also give us minus 3x. And just like that, we have x squared minus x minus 2x plus 2 is equal to 0. Now, moving on from here, we can bring out the common factor. X is common in the 2. X into x minus 1 minus 2 into x minus 1. Now, noticing this, you see that when you say minus 2 times x, that will be minus 2x. And minus 2 times minus 1, that will be plus 2. So, we are on track. And with this, we can bring in our factors. That will be x minus 2 into x minus 1 is equal to 0. Such that x from this, x is equal to 2 or x is equal to 1. And that is what we are asked to find in our question. And that is all about question number 1 in our further math question. Now, our question number 2, we are given that log 3x minus 3 log x3 plus 2 is equal to 0. And we are asked to find the values of x. Now, looking at this question, we need to note some simple rules of logarithm that we can make use of. Like here, we have log 3x and log x3. But one of the rules of logarithm is telling us that log 3x is equal to the same as 1 over log x3. So these are inverse of one another. So if you want to apply this, we can see that our equation will become log 3x minus 3 over log 3x plus 2 is equal to 0. So applying that rule of logarithm had helped us to have only an unknown that we can call p. Let's say p is log 3x. So now in this equation, we can say we have p minus 3 over p plus 2 is equal to 0. And if we take the LCM as p, now we will have it as p squared minus 3 plus 2p is equal to 0, or we can say 0 over 1. So that if you cross multiply, we have p squared minus 3 plus 2p is equal to 0. Now, if you are just to rearrange, because this is almost looking like quadratic equation already, it is quadratic equation actually. So if you are to arrange it appropriately, we can say p squared plus 2p minus 3 is equal to 0. So here, we are looking for two numbers that we can multiply to give minus 3p squared, and when we add them, it will be 2p. So now, if you are to look critically, we will notice that if you multiply 3p and minus p, that will give us 3 times minus 1 is minus 3, p times p is p squared, that's right. Then if we add them, 3p and minus p will be 3p minus p, which is 2p. So we can have our factors already that we can get from these, such that we can write our equation and say p squared, now it will be plus 3p minus p minus 3 is equal to 0. such that if we bring out p from the first two entities, p from the first, it will be p into p plus 3, then you say minus 1, the other will also be plus 3. Now, if you are noticing, minus 1 multiplied by p will be minus p, minus 1 multiplied by 3 will be minus 3. So, we are on track. And this will give us p minus 1 into brackets p plus 3 is equal to 0, such that p is equal to 1 or p is equal to minus 3. But notice that nobody asked us to find the value of p. We are the one that introduced p as log 3x. And so if you are to reverse back to say log 3x, which is p, is equal to 1, here the rule of logarithm stipulates that our x will now be the 3, which is the base, raised to power 1. And like this, x will be 3. Or if you are to look at the other value, or we can say log 3x is equal to minus 3. And using the same principle, that means x will be 3x raised to power minus 3. And from the law of indices, all we note is that this will yield x is equal to 1 over 3 raised to power 3. And we know 3 raised to power 3 is 3 times 3, 9 times 3, 27, 1 over 27. Now, question number 3 from our Further Maths WAEC 2018 past question. We are asked to use the substitution u is equal to x minus 2, and we are to rewrite this expression in terms of u. Now, from there we can say u is equal to x minus 2. That means x is equal to u plus 2. So wherever we see x in the expression that we are given, we can use u plus 2 in place of x. So that means we have u plus 2 raised to power 3 plus 5 divided by, now x minus 2 is the same as u, so we have divided by u over 4. Now we have u plus 2 raised to power 3, and to expand, I'm going to be making use of the Pascal's triangle. The Pascal's triangle to get the coefficient of the two entities u and 2. And from the Pascal's triangle, when we have a power of 1, the coefficient is only 1 and 1. Power of 2, we have 1, 2 and 1. And power of 3, we have 1, 3, 3, 1. These are gotten by adding the two previous coefficients. Like here, we have 1 plus 2 will be 3, 2 plus 1 will be 3, and then 1 will be at the extreme. That means we have u raised to power 3 multiplied by 2 raised to power 0. I will explain that. Plus, now we have 3 u raised to power 2 multiplied by 2 raised to power 1, plus again the second 3 multiplied by u raised to power 1 multiplied by 2 raised to power 2, and then we have 1 u raised to power 0 multiplied by 2 raised to power 3. Let me clear the board and then I will explain this. What you need to note, apart from using Pascal's triangle to get the coefficient, here for the two entities u and 2, the powers of u, which is the first entity, is starting from the highest power, which is 3, and then it is descending down the line, while the power of the second entity 2 is ascending from 0 up till the highest power, which is 3. And so that is how we do expansion. Even in binomial expansion, the same thing is what we make use of. So we have 3, 2, 1, 0 and 0, 1, 2, 3. So now we can go ahead to open our brackets. So we have 2 raised to power 0 is 1. So we have u raised to power 3 plus 2 raised to power 1 is 2 times 3 is 6. We have 6u square plus 2 raised to power 2 is 4 times 3 is 12u. Then we have u raised to power 0 is 1 and 2 raised to power 3 is 8. Then plus 5, everything divided by u raised to power 4. Now this will give us u raised to power 3 plus 6u square plus 12u. 8 plus 5 is 13, all divided by u raised to power 4. And like that, we have gotten the first question 3a that we are asked to find. We've expressed that expression in terms of u. And now in the second question, we are asked to express s cubed plus 5 over x minus 2 raised to the power 4 in partial fractions. What do we mean when we say we want to express something in partial fractions? Partial fractions is a means of expressing our whatever we are working with in progressive powers of that variable. We write the expression in progressive power of the variable just as it was shown, and that means here we want to write in terms of x, and then it will be that we'll be using this u and reverting back to x. We'll be using u, but now we want to express it back in x. So we have s cubed plus 5 over x minus 2 raised to the power 4 will be u3 over u4 plus 6u squared over u4 plus 12u over u raised to the power 4 plus 13 over u raised to the power 4. What I'm doing is I'm splitting each of the entities so that I can have the format of the partial fraction, and this will be 1 over u plus 6 over u squared plus 12 over u cubed plus 13 over u4. And now if you're observant, you will discover that we are having the denominator in increasing powers of u, but we know that u is x minus 2. So if we substitute that, what we are asked to find will come out as 1 over x minus 2 plus 6 over x minus 2 all square plus 12 over x minus 2 raised to the power 3 plus 13 over x minus 2 raised to the power 4. And that had given our expression exactly in partial fractions as we are asked to do. Here, question number 4 from WAEC 2018 further mathematics theory paper. We ask that the sum of the first 12 terms of an arithmetic progression and AP is 168. The third term is 7, and we're asked to find the common difference and the first term. Now, there is a general formula for getting the sum of the first n terms, and it's given as n over 2 into 2a plus n minus 1d as written, where a is the first term and d is the common difference. So now, when we are told that the first 12 terms is 168, that means the n is 12, the number of terms, and x12 is 12 over 2 into 2a plus n minus 1d. N is 12, so 12 minus 1d. So x12 we have been given to be 168, over 2 is 6 into 2a plus, now we have 12 minus 1, 11d. And all this is equal to 168. This is 168. 6 can be used to divide 168, and we'll have 28. That will be 28. So that we have 2a plus 11d is equal to 28. And we can call this equation 1 while we'll try and interpret the other hint that we are given in the question. And the other hint is saying that the third term is 7. There is also a general formula for the nth term of an AP. The nth term of an AP is given as Tn is equal to a plus n minus 1d. A is the first term, and n is the number of terms, and d is the common difference. So here we have been told that the third term is 7. So 7 is equal to a plus 3 minus 1d. And that means we have a plus 2d is equal to 7. And we can call this equation 2. So we have two simultaneous equations that we can solve by any method we like. I will be employing the substitution method to try and solve this so that we can get the value of a and d. So we have 2a plus 11d is 28, and we have a plus 2d is equal to 7. Now, from our equation 2, if we are looking at this equation 2, we can express A in terms of D so that we can use that expression in the first equation. So from equation 2, our A is equal to 7 minus 2D. And if we are to use this in the first equation and substitute for A, we are going to have 2 into 7 minus 2D plus 11D is equal to 28. Opening that bracket, we yield 14 minus 4D plus 11D is 28. Minus 4D plus 11D is 7D. When 14 crosses to the other side, we have 28 minus 14, which is 14, such that D will be 14 over 7, and that is 2. And already we know that A plus 2D is equal to 7. So you can say that A is 7 minus 2D, and that is 7 minus 2 times 2, which is 7 minus 4, and that is 3. And as easy like that, in our further math question, the questions we are asked to solve, we have solved. We've found the common difference. We found the first term. And our question is done and dusted. But as an additional hint, sometimes we may be asked to find the expression for maybe the nth term or the expression for the sum of the first n terms. What we just need to do is, in the general formula, for example, we want to find the general nth term for this AP, we can say Tn is A plus n minus 1D. And since we know A is 3, and D is 2, we can expand this to be 3 plus 2n minus 2, which is 2n plus 1. And using 2n plus 1 for any n term, we don't need to plug in the A or D again. We can get that. And in the same manner, we can also use this to find the sum of the first nth term. We're asked to calculate the Spearman's rank correlation coefficient for the decision of 2 panel of judges. Now, the question is, what do we use Spearman's rank correlation for? It's used to determine if 2 variables are monotonic, meaning that as one set of variables, as it increases, is the other also increasing in the same manner? Or if one set of variables, one set of ranking is decreasing, is the other ranking, is it also decreasing? So the Spearman's rank correlation is a measure of the monotonic nature of 2 variables. Here, it is the ranking of oil that we are given. And to get this, there is a general formula that is normally employed, especially since here in our ranking we don't have the repetitions. The Spearman's rank correlation is given as 1 minus 6 sigma d square over n into n square minus 1, where d, as noted in the equation, is the difference between the ranking that we are talking about. This is the difference in ranking between the variables that we are talking about, and then n is the number of entries that we are talking about, is the number of parameters that are being ranked as given in whatever question we'll be trying to solve. So here we are going to generate a set of values from the information that we are given. So we have the oil type, we have the rank X, we have the rank Y. We are going to find the value of D, then we are going to find the value of D square. So if you are to come up with a table, let me do that, then we'll come back. Rank X, rank Y, then the difference between the two is Rx minus Ry, then the square of the difference. So I'll go ahead and populate the table and then come back to finish up with the lecture. So here, 8 minus 6 is 2, 5 minus 3 is 2, 1 minus 4 minus 3, 7 minus 8 is minus 1, 6 minus 7 is minus 1, 4 minus 2 is 2. And then, as a rule of thumb, so that we'll check if you are not making any mistake, if we sum the difference, it should normally give 0. Like here, we have 2 plus 2 is 4, minus 3 is 1, plus minus 1 is 0, minus 3 is minus 3, minus 1 is minus 4, plus 2 minus 2, plus 2, 0. So the sum of D must be 0 to show that we are on track. And we can go ahead to find D square, and the sum of D square we can also find to input into our equation for the Spearman's rank correlation coefficient. Now the sum of this D square, let's bring in our calculator. We have 4 plus 4 plus 9 plus 1 plus 9 plus 1 plus 4 and plus 4. That's 36. So we have 1 minus 6 multiplied by 36 over our n is 8. So 8 into 8 square minus 1. And that will be 1 minus, we can 6 times 36 over 8 into 8 square is 64. 64 minus 1 is 63. So we can cut. Let's cut with 4 in 36 is 9, 4 in 8 is 2, 2 in 8, 1, 2 in 6, 3. So we have 1 minus 27 over 63. And if you find the LCM, that will yield, that will be 36 over 63. 3 can go in both numerator and denominator, and we'll add that is 12 over 21. So that is the correlation coefficient that we are asked to find. Here in this question, we are told that the probability that Kunle solves a particular question is 1 over 3, while that of Tayo is 1 over 5. If both of them attempt the question, we are to find the probability that only one of them will solve the question. Only one of them. We need to be able to interpret this question correctly. Now, the probability that Kunle solves is 1 over 3. So, the probability that Kunle fails will be 1. Let's say probability of K prime is 1 minus 1 over 3. And that is 2 over 3. And in the same way, the probability that Tayo will solve is 1 over 5. So, the probability that Tayo will fail, which you can call probability of Tayo prime, T prime, is 1 minus 1 over 5. And that is 4 over 5. Now, we are asked to find the probability that only one of them will solve the question. Now, we have two people attempting some question, and only one of them will solve. That means that is either Kunle solves the question, and when Kunle gets it, then that means that Tayo fails, meaning that only one solves, or Kunle will fail, he will fail the question, while Tayo will solve it. Now, this interpretation is a very good indication of how best we can go about solving our question. Instead of using while, we can use and. We can use and, meaning that either Kunle solve and Tayo fails, or either Kunle fails and Tayo solves. And in probability, when we are using and, we are talking about multiplication. When we are using or, we are talking about addition. So, what we are asked to find, the probability, will mean that we have Kunle solves 1 over 3 multiplied by Tayo fails 4 over 5, plus Kunle fails 2 over 3 multiplied by Tayo solves, which is 1 over 5. So, if you are to evaluate that, that will be 4 over 15 plus 2 over 15. Right now we had that will be 6 over 15, which you can divide by 3 to have 2 over 5. That is the solution to question number 6A. Okay? So now we can go to question number 6B. A committee of 8 is to be chosen from 10 persons. In how many ways can this be done if there is no restriction? If there is no restriction, we want to pick 8 out of 10. So without restriction, this is a question in permutation and combination. And here is only a matter of combination. We want to pick 8 out of 10. And the number of ways to generally choose 8 out of 10 is given by the combination formula 10 combination 8, which will be 10 factorial over 10 minus 8 factorial multiplied by 8 factorial. This is directly coming from the general equation that n combination r is n factorial over n minus r factorial r factorial. So if you are to try and evaluate this, what we are going to get is 10 times 9 times 8 factorial. I'm not proceeding because I know it will cut out the other 8 over 2 factorial multiplied by 8 factorial. So the 8 factorials will cut out so that we have 10 times 9 over 2 factorial is 2 times 1. 2 will cut 10 in 5, so we have 5 times 9, which is 45 ways of selection. Now, with the calculator, we can actually use combination from the calculator to check if you are not making any mistake. So when we press our shift divided is the sign for the combination. So in this case, we can say we want to evaluate 10 combination 8, that is equal to 45. And just like that, our question number 6 is totally solved. So here, our question number 7 from 2018 for the mathematics core paper. We have a question on complex numbers, but it's only algebra processes that we are going to be carrying out on these complex numbers. Now, we are given 3 complex numbers, m, n, and p, and we're asked to find 4m plus 2n minus 3p. Now, it's as simple as we can get it. All we need to do is just to substitute the values of m, n, and p in this particular expression. And what we are going to be having is 4 into all of m plus 2 into all of n minus 3 into all of p. And if you are to try and evaluate that, we can just open up our brackets so that we will have 12i minus 8j plus 2 times 2 is 4i, 2 times 3j will be 6j. Then now, minus 3 and minus I will be plus 3i, and 3 multiplied by 6j will be minus 18j, such that by the time we are collecting like terms, if you are to collect like terms, we have 12i plus 4i plus 3i, now minus 8j plus 6j minus 18j. And now if you are to just sum all this, sum the like terms, we are going to have 19i minus from 20j. And that is a solution to question number 7 from WAEC 2018 for the maths theory paper. Okay, our question number 8 now. We are given that a body of mass 20 kg moving with a velocity of 80 meters per second collides with another body of mass 30 kilograms moving with a velocity of 50 meters per second. Now, the two bodies are assumed to move together in the same direction after the collision. So we have to find the common velocity. If they moved in the same direction before collision, then in opposite direction before collision. Now, for the first part, when they are moving in the same direction before collision, so we have 2 case scenarios. Before the collision, we have 20 kilograms moving with initial velocity of 80 meters per second, and then the 30 kilogram body moving with an initial velocity of 50 meters per second. Now, we are told they are moving in the same direction. So if we take our direction to be the positive body, x-axis, both of them will be pointing towards that positive x. Now, after collision, we are told that they move in the same direction after collision. So we can have the two bodies, the 20 kilogram body and the 30 kilogram body, and both of them, they will move with a common velocity, meaning that the same velocity after collision. Now, with this analysis, we can use the principle of conservation of momentum, saying that the momentum before and the momentum after, they are equal. And here, the momentum before is the product of the mass and the velocity of the two bodies, and then this will be 20 times 80 plus the other body is 30 times 50 is equals to the sum of the masses of the two, 20 plus 30 multiplied by their common velocity. So that will give us 1,600 plus 1,500 is equal to 50V. And if we sum the left hand side, that will give us 3,100 is equal to 50V, such that our V is 3,100 divided by 50. The 0 will cut out, and that will leave us with, let's see, 310 divided by 50 divided by 5. That is 62 meters per second. So that is the final velocity if the objects are moving in the same direction before collision. So if you are to go to our question number B, we are now told that if they are moving in the opposite direction before collision, we have to find their common velocity after the collision. So again, if you are to analyze this, before collision, we have the 20 kilogram body and the 30 kilogram body moving in opposite direction. So we have 20 kilogram. Let's say that is moving in the positive x-axis. We have 80 meters per second. And then we have the 30 kilogram body moving in the opposite direction. So opposite direction here will be opposite to the direction of the previous one. So here we have 50 meters per second. And then after collision, now we don't know, maybe they will be moving towards the right or towards the left, but we just assume one. And if our final mass is negative, then we know our assumed direction is wrong. So we have the two bodies, but now moving with a common velocity, let's say still in the positive x direction. So by principle of conservation of momentum, if you are to evaluate this, we'll have the first mass multiplied by the velocity plus the second mass multiplied by the velocity will be the sum of the masses multiplied by the common velocity. So here our M1 is 20 kilogram multiplied by 80. Now the second mass is 30 kilogram, but our velocity is in the opposite direction, so we use negative, minus 50 meters per second. And this will now be equal to the sum of the masses, 20 plus 30 multiplied by the velocity after collision. That will give us, that will be 1,600. Now 30 multiplied by minus 50 will be minus 1,500, which is equal to 50V. If you subtract the left hand side, we will have 100 is equal to 50V, such that our V will be 100 divided by 50, and that is equal to 2 meters per second. Now that is the velocity of the two objects, their common velocity when they move in opposite direction before collision. What we need to note as a rule of thumb is that assuming that the velocity we got eventually is a negative number, if we get like say V is equal to minus 2 meters per second, that is only an indication that the direction we choose for the object initially was wrong. Then we should reverse the direction. Being a vector quantity, that means that the velocity, it has another direction but the same magnitude. We just need to take note of this, and in that case this final velocity will be in the other direction, and we can tag it as V. So here we have this question that we are given 3 points that a circle was drawn through center, and we have to find the coordinates of the center of the circle. We have to evaluate the radius of the circle, and ultimately to write out the equation of the circle. Now, if you consider our Cartesian plane and draw a circle on it, we can take the coordinates of the center of the circle on the x-axis and on the y-axis as shown in the diagram. On the y-axis and x-axis, on the x we can call it A, and on the y-axis we can call it B. Now the circle will have a radius r that is drawn from the center of the circle to any point on the circumference. And with this, there is a general format of the equation of a circle that is well accepted. It's called the standard circle equation, and the standard circle equation was derived from this diagram. Without going to the details of derivation, it is given as x working minus a all square plus y minus b all square is equal to the radius square. Now, this is a standard circle equation, but sometimes working with the questions that we are given, we may not have the opportunity to really express our equation in this. So if you go ahead to expand the brackets, what we are going to get from this standard circle equation is s square. Now we have ax in two places, so we have minus 2ax. Then when the negative multiply each other, we have plus a square. And the same thing will be applicable for y. Y square minus 2by plus b square all is equal to r square. Now, from the left hand side, if you are to put the x and y variables together, we can find s square plus y square minus 2ax minus 2by, then plus a square plus b square. Now, if we take the radius to the left hand side, we have minus r square, all is equal to 0. Now, if you're observant, already we are generating another form of the equation. So, if we take the constant a square, b square, and r square and denote as z, and instead of using minus 2a and minus 2b, if we revert that, we can find another format of the circle equation, which many times we also find useful, and that is given as s square plus y square plus 2fx plus 2gy. Now, instead of all this a square, b square minus z, we have plus z is equal to 0. This is noted as the general form of the circle equation. Now, having this understanding, we'll be able to go ahead with our questions and try and see what format will be best, will be most suitable for us, and we can answer our question from WAEC Further Mathematics 2018 theory paper. So now, in this question, we are given that there are 3 points that the circle was drawn through, but if we note the general form of the circle equation, that general form that we have been given, that we just highlighted not too long ago, we can say s square plus y square plus 2fx plus 2gy plus z is equal to 0. Now, for this that we are given, we can take each of those points and substitute the value of x and y into this general equation of the circle, and that will give us some set of equations that we can try and solve. So, if we are to take, in the first case, for 3, 2, x is 3, y is 2. If you substitute in this equation, we are going to be having 3 square plus 2 square plus 2f of x, and x is now 3 and f is there, plus 2. Now y is 2 multiplied by g plus z is equal to 0. And if we evaluate this, that will give us 9 plus 4 plus 6f plus 4g, which is 2 times 2, plus z is equal to 0. Now, we can have this as 6f plus 4g plus z. When 9 and 4 move to the other side, they become minus 13. And this we can call equation 1. Now, moving on from there, for the point minus 1 and minus 2, for the point minus 1 and minus 2, if we substitute this value into our general equation also, and we use minus 1 for x and minus 2 for y, what we are going to get eventually, if we substitute just like that, we are going to have 1 plus 4 2 times minus 1 is minus 2. Then 2 times minus 2 is minus 4g. That will give us minus 4g plus z is equal to 0. Such that here we can have minus 2f minus 4g plus z is equal to 1 plus 4 is 5. When we move to the right hand side, it becomes minus 5. And for me, I like to work with positive values, so I will rather multiply all through by minus 1. So we have 2f plus 4g minus z is equal to 5. I can call this equation 2. Now that's equation 2. And in the third case, for 5 comma minus 4, for 5 comma minus 4, I can go ahead and that will be 5 square plus minus 4 square plus 2 into 5 multiplied by f plus 2 into minus 4 multiplied by g plus z is equal to 0. And that will yield 25 minus 4 square is 16. 2 times 5 is 10, so I have plus 10f. 2 times minus 8 is minus 4 is minus 8. Then I have plus z is 0. Now, 10f minus 8g plus z, 25 plus 16 will be 41. When we move to the right hand side, will be minus 41. And this I can call equation 3. Now, interestingly, from trying to evaluate question on the circle, we are now being led to a simultaneous equation in 3 variables. And having a simultaneous equation in 3 variables, how do we go about to solve that? That's what we are going to be embarking upon next. And now, after I succeed in evaluating that, I will check with the calculator to check that I am on track and I'm not missing my question. So we want to find the variables f, g, and z from this simultaneous equation in 3 variables. As you can see, quite a lot of things are there for us to learn. Like here, we can also learn about solving simultaneous equation in 3 variables. And that's why our advocacy here is always that we can easily study together, we can learn together. And that's why we advocate that go ahead to subscribe to the channel, click on the notification icon, share the videos, like them, leave your comments in the section below, and let us learn together how best we can prepare you for your academic excellence. That's what DaveTuts Academy is all about, and it will be a plus for you to actually be part of this journey together. So here we have our 3 equations, and when we are solving for simultaneous equation in 3 variables, there are quite a number of ways. What I want to do is I want to eliminate one of the variables. So if I had equation 1 and 2, because I want to eliminate z, I'm going to have 6f plus 2f is 8f, 4g and 4g is 8g. The z plus z minus z will be 0. Then minus 13 plus 5 will be minus 8. Now, of course, 8 is common all through. If I divide through by 8, I'm going to have here, I'm going to have f plus g is equal to minus 1. This I can call my equation 4. Let me call that equation 4. Then again, if I look at equations 2 and 3, I can also eliminate z again if I had both equations. So equations 2 and 3 being added together, I have 2f and 10f, and if I add them together, that would be 12f. Then plus 4g and minus 8g, that will be minus 4g. The z will cancel out. Then 5 plus minus 41 will be minus 36. Again, looking at this, I can divide all through by 4 to have 3f minus g is equals to minus 9. This I can call my equation 5. Now, looking at equations 4 and 5, we can see that if we also add them, g will be eliminated out such that I can have f and easily solve for my f. The g's have plus g and minus g. If I had the 2, that will eliminate the g so that I can solve for f. So equation 4 plus equation 5 will yield f plus 3f will be 4f. 4f, then g will cancel out, then minus 1 plus minus 9 will be minus 10, such that my f is minus 10 over 4, and dividing by 2, I have minus 5 over 2. So I have the value of f, that is solved, f is resolved. Now, in one of the previous equations, either equation 4 or 5, I can substitute the value of f so that I can have g. So using equation 4, f plus g is equal to minus 1, and f is minus 5 over 2, meaning that g will be minus 1 minus f. That's minus 1 minus 5 over 2. The negative we multiply each other to give minus 1 plus 5 over 2. And if I find the LCM, that will be minus 2 plus 5, such that g is 3 over 2. Good. So I've obtained g to be 3 over 2. I've obtained f to be minus 5 over 2. I can use any of equations 1, 2, or 3 and substitute for the values of f and g to get the value of z. So if I'm using equation 2, now 2f plus 4g minus z is equal to 5. Meaning that if I substitute my values, I will have 2 into minus 5 over 2 plus 4 into 3 over 2 minus z, which I'm looking for, is equal to 5. So now I can cancel out the 2 to have minus 5. 2 times 3 is 6, plus 6 minus z is equal to 5. And if I move minus 5 and plus 6 will be 1, so minus z will be 5 plus 5 minus 6, which is 10 minus 6 is 4, and that means that my z, therefore z, is minus 4. So with these three equations, I've used elimination method to find the values of my three variables. I want to ensure that I got my values right, so I will use my Casio FS calculator to also confirm, to note that all these that I've gotten, they're actually the correct values as expected of me. I got f to be minus 5 over 2, g to be 3 over 2, and then z to be minus 4. So I'll bring in my calculator, slot in these three equations, and check if my solution to these simultaneous questions is actually correct. So here, if I go to mode, I want to work on equation, that is 5. And then the format of my equation, if you look at it, is corresponding to 2. That's 3 variables, x, y, and z. So here, it's being put in a matrix format. Instead of having x, y, and z, I'm using f, g, and z now. So 6f, 4g, and 1z, then d is minus 13. Second equation, I have 2f, 4g, I have 4, then minus z, I have minus 1, and then is equal to 5. Then in the third equation, I have 10f, 10, I have minus 8g, minus 8, then z, that's just 1, then is equal to minus 41. Alright. Now if I press equal to, now my x, which is the variable the calculator is using, is minus 5 over 2, y is 3 over 2, and z is minus 4. So I'm actually good to go with the values I obtained. I can move ahead to try and solve my questions as asked for the circle. So now going back to the equation that I started with. So if I'm to recall the general format of the equation I'm using, x squared plus y squared plus 2fx plus 2gy plus z is equal to 0. Now, I've gotten the values of f, g, and z. If you recollect, our f, we have f to be minus 5 over 2, g is 3 over 2, and z was obtained as minus 4. Okay, so if I'm to plug in these values into this general format of the equation of the circle, let me go ahead and do that. So I have x squared plus y squared plus 2. My f is minus 5 over 2 multiplied by x plus 2. My g is 3 over 2 of y plus z is minus 4, that's equal to 0. Now, because of the standard form that we are actually also looking for, we can notice that we can actually go ahead to do the operation of completing the square on this particular expression. Now, again, our question is leading us to completing the square, and you don't need to be frustrated, you don't need to be agitated at all. We can actually take this expression and use completing the square to bring out some very cogent equations, so that we have x squared plus 2 into minus 5 over 2 x plus y squared plus 2 into 3 over 2y. Now we have plus minus 4 is equal to 0. Now I'm deliberate not to cut out like this because I want to try and complete my square. Now, generally, when we are having a factor, let's try and explain that. Generally, when we're having, let's say, x plus minus 5 over 2, and we are squaring all this. Now, let's try and expand this. This will be x plus minus 5 over 2 multiplied by x plus minus 5 over 2. Now, if you open this bracket, that will be x multiplied by x squared, and x plus multiplied by minus 5 over 2 in two places. That will be plus 2 into minus 5 over 2x. Okay. Then minus 5 over 2 multiplied by minus 5 over 2 will be minus 5 over 2 all square. Now, we need to look at this expression critically, and we'll evaluate that what we are having in our equation that we are coming from is x squared plus 2 into minus 5 over 2x. And that will be equal to, now, the left hand side, if you take minus 5 over 2 squared to the left hand side, we have x plus minus 5 over 2, everything all square, minus 5 over 2 square. Now, I took the time to explain this because I'm going to substitute these values into this equation, and we can do the same thing for y, such that from there, what we are going to be having is, we'll have, instead of writing x squared plus 2 into bracket minus 5 over 2x, we are going to write this expression on the right hand side. So, if you are to do that, what we have is x plus minus 5 over 2, everything all square, minus 5 over 2 squared. The same thing for y will give us y plus 3 over 2 all squared minus 3 over 2 squared plus minus 4. So, this we can go ahead to say is x minus 5 over 2 all squared plus y plus 3 over 2 all square. Now, minus 5 over 2 all square will be 25 over 4. Then minus 3 over 2 all square will be 9 over 4. Then we have minus 4, all is equal to 0. And I'm doing this because I want to revert back to the standard form of the circle equation so that we can get the coordinates and the radius of the circle. So, having this, we can clear our board and write out our equation as desired. So here, that means we have x minus 5 over 2 all constant plus y plus 3 over 2 all square is equal to, when we move all the other constants to the right hand side. 25 over 4 plus 9 over 4 plus, now 4 can be taken as 4 over 1. And so we find the LCM for, we have 25 plus 9 plus 1 in 4 in 4, 4 times 4 is 16. So that will be 25, 9 and 16. That will be 4 and 16. That will be 50 over 4. So that will, 2 will go and we have 25 over 2. Such that our expression for the equation of the circle will be x minus 5 over 2 all square plus y plus 3 over 2 all square, and that is equal to that's 25 over 2. But I want to postulate something. If I say 4 and I have square root of 4 all raised to power 2, that will be 2 raised to power 2, which is equal to 4. So finding the square root and squaring is actually annulling each other. That means I can say this is square root of 25 over 2 all square. It's as if I'm just writing 25 over 2 alone. Now, for this new equation that we have obtained, if we compare to the standard form of the equation of a circle, if you are to compare this to x minus a squared plus y minus b squared is equal to r squared, we can see that our coordinates is easily obtained, our radius is obtained, then the coordinate of the center of the circle will be a comma b, and comparing the two, we can see that minus a is 5 over 2, and our b will be minus 3 over 2. Now, the thing to note is that we may make the mistake to just say 3 over 2. No, it is minus 3 over 2. And from there, the radius is the square root of 25 over 2. And just like that, we have gotten the center of our circle, the coordinates, and the radius of the circle. Now, the equation of the circle, we could as well leave it as what we obtained before, x minus 5 over 2 all square plus y plus 3 over 2 all square is equal to the square root of 25 over 2 all square, or just ordinarily 25 over 2. Either of the two is the same. But interestingly, we can go ahead to expand the bracket, then evaluate, simplify the equation, or from the general format of circle equation that we use, x squared plus y squared plus 2fx plus 2gy plus z is equal to 0. We can also substitute the values of f, g, and z. F is minus 5 over 2, g is 3 over 2, and z is minus 4. We can substitute these values back so that we have x squared plus y squared plus 2. F is minus 5 over 2 plus 2. G is 3 over 2 multiplied by y. Z is minus 4 equals to 0. And here, if we just cut out the 2's, our equation will come out as x squared plus y squared minus 5x plus 3y minus 4 is equal to 0. And with that, we've been able to evaluate the equation of the circle, the coordinate of the center of the circle, and the radius of the circle. We are having this equation that we are asked to solve, and it's an equation with respect to indices. And here we are going to be employing the law of indices, and particularly the law we want to note is that when you have a number raised to power the product of two powers, that will be a raised to power mn, can be a raised to power m first, then all raised to power n. Then a raised to power m plus n is a raised to power m multiplied by a raised to power n. And looking at the equation that we are asked to solve for, if we say we should eliminate 2 raised to power y and say 2 raised to power y is equal to p, we can rewrite this equation to say, using these two laws that we have highlighted above, we can say now we have 2 raised to power 2, which is the one for 7 plus 2, multiplied by 2 raised to power y all raised to power 3 minus 7. Now, all these expressions, we can have it as 2 raised to power 2 first, then 2 raised to power y raised to power 2 minus 31 multiplied by 2 raised to power y minus 8 is equal to 0. This is deriving from the laws that we have highlighted, and by the time we put in our p for 2 raised to power y, this will be 4p raised to power 3 minus 2 raised to power 2 is 4 times 7 is 28p square. Now minus 31p and minus 8 is equal to 0. And now with this, we have resolved to get a polynomial of degree 3. This is a polynomial of the third degree, and we will need to find a way to solve for this polynomial so that we can find the term of y. Now, there is a factor theorem that we can make use of, and the factor theorem of a polynomial states that if, say, p minus a is a factor of a polynomial, if p minus a is one of the factors of a polynomial, then the function of a will be 0. Meaning that if we input the value of a in the polynomial and we solve it, then that polynomial will be equal to 0. So now, what we normally take is we begin to assume some numbers that we want to slot in into the equation such that we will find through the factor theorem that the function of that factor we are looking at is 0. Let's assume that p minus 1 is a factor. Then function of 1, if we want to evaluate it in this polynomial, will be 4 multiplied by 1 raised to power 3 minus 28 times 1 raised to power 2 minus 31 multiplied by 1 minus 8 is equal to, if we say we should evaluate that, let's bring in our calculator. We have 4 x raised to power 3 minus 28 x square, 28x square minus 31x, then minus 8. If you are to calculate when x is 1, now this is minus 63. That means the function of 1 is minus 63. This is equal to minus 63, and that is not equal to 0, meaning that p minus 1 is not a factor. Now, the dilemma we are facing in our exam is we don't have the luxury of time to be taking assumed values again and again, so that we want to check. Sometimes working with minus 1 we easily yield what we are looking for. Sometimes working with 1 we easily yield what we are looking for, but we need to work smart. So what I personally advocate for is let's make use of our calculator to try and solve this polynomial equation. The calculator has a mode that we can use, and if you go to mode 5 is equation, then if you look at the fourth entry, that is the entry for solving for a polynomial function of degree 3. So if you put in our values of coefficient 4 minus 28 minus 31 and then minus 8, now it's solving and telling us that x1 is 8 minus, and then x2 is minus 1 over 2. Okay, it's only giving us 2 solutions, well, meaning that one of the solutions is being repeated. So here, we already know that, of course, we have 8 and we have minus 1 over 2. So let's assume, since we need to show our workings in our exams, we'll say let's assume that p minus 8 is a factor. Then the function of 8 will be 4 multiplied by 8 raised to power 3 minus 28 multiplied by 8 raised to power 2 minus 31 multiplied by 8 minus 8 will be, now we can bring in our calculator to also evaluate it. And if you want to evaluate that, that will be, let's go back to our normal mode. 4, okay, it's not giving me the option to go back. Let me just work it out. 4 multiplied by 8 raised to 33 plus Okay, minus 28 multiplied by 8 raised to power 2 minus 31 multiplied by 8, then minus 8 is equal to 0. So this, we can say it is 0. And since it is 0, that means p minus 8 that we assume is actually a factor of this polynomial we are trying to solve for. And now, we still need to go ahead and check for the other factors. And because we need to show our workings, that means we will be employing the division of a polynomial. We already know a factor. Now, this is a polynomial of degree 3. So, we have known a factor. P minus 8 is a factor. Then, to get the other factors, we divide our polynomial by p minus 8. So, we'll be doing polynomial division. Now, we need to be smart because already, from using our calculator, we know that the other factor will be x plus 1 over 2 because the calculator evaluated x to be minus 1 over 2. So, working smart had helped us and we can move on with our calculation. And trying to now evaluate our other factors, let's divide this polynomial by the factor we already know, p minus 8. So, we want to divide 4p raised to power 3 minus 28p squared minus 31p minus 8. We want to divide it by p minus 8. And what we do is we take the first entry, we say p in 4p raised to power 3, that will be 4p squared. 4p squared multiplied by p is 4p raised to power 3. 4p squared multiplied by minus 8 will be minus 32p squared. Now, if we subtract these first two entries, it will be like 28 minus 32. Of course, the 4p raised to power 3 will cancel out. That will be 28 plus 32p squared, which will be 4p squared. And if we bring the other factors down, we'll have this. And when we say p in 4p squared, we have 4p. 4p times p will be 4p squared minus 4p times minus 8 is minus 32p. And if we also subtract, 4p squared will cancel out. We have minus 31p minus 32p. That will be minus 31p plus 32p, which is p. Then we'll bring minus 8 down. Of course, this is p minus 8 in p minus 8 is 1. And there is no remainder for our division. Meaning that 4p squared plus 4p plus 1 is the other, constitute the other factors of the polynomial that we are looking for. So we can conclude and say that we have 4p squared plus 4p plus 1 actually constitutes the other factors of the polynomial. So this is the other factor, and we can still go ahead to factorize this so that we get the set of factors particularly and not just a quadratic equation. So if we want to factorize 4p squared plus 4p plus 1, we can easily do that by saying this is 4p squared plus 2p plus 2p plus 1. And now 2p is common to the first two entries, and that will be 2p into 2p plus 1, then plus 1 into 2p plus 1. And here we have the same factors, 2p plus 1, 2p plus 1. So we can now understand why our calculator gave us just only two entries as the factor of the polynomial. So from here, p will be minus 1 over 2 as indicated in our calculator, but minus 1 over 2 is not a real number. This is not a real number, so we can't use that because our question said that we want to evaluate y for a real number. So we can go ahead to say that means our p is 8, and of course 8 is a real number. That means 8 is equal to 2 raised to power y, and that is a real number, such that 2 raised to power y is equal to 8, and we know 8 is 2 raised to power 3. Now, the number bases will cancel out so that y is equal to 3. And this is the solution to what we are asked to do. We are asked to solve for this equation, and our y as a member of the real number is given as 3. So now our question number B Question number 10B, WAEC 2018, further maths, May, June. This is an integration, and we're asked to find the integral of x squared plus 1 all multiplied by x dx. We can rewrite this to say x squared plus 1 raised to the power 1 over 2 to cater for that square root. But now we can just use integration by substitution to say let u be x squared plus 1. Then from here, if we differentiate, the u dx will be 2x. Now it will be plus 0 because 1, when you integrate that, when you differentiate, that will be 0, is a constant. Then from du dx is equal to 2x. If we cross multiply and find x dx, you can find x dx to be du over 2. Now, since we are making all this substitution now, we can go back to our original question, and instead of writing integral of x squared plus 1 raised to the power half x dx, we can substitute for u and x dx to say this is equal to integral of u raised to the power 1 over 2 du over 2. And that will be 1 over 2 integral of u raised to the power 1 over 2 du. And now this is simpler for us to solve. And by the time we make that integration, that will be 1 over 2. If we integrate, what we do is we add 1 to the power u 1 over 2 plus 1. And then that new power will be coming to divide our expression as 1 over 2 plus 1 as written, plus constant c, the constant of integration. Now this will be 1 over 2 into half plus 1 will be 3 over 2 over half plus 1 will also be 3 over 2. Now, all plus c. With this, the 2 that is at the base will come up. So we have 2 over 2 into u raised to the power 3 over 2 over 3 multiply plus c. And 2 over 2 is 1. So this will give us 1 over 3 multiplied by, now our u originally we know is x squared plus 1 all raised to the power 3 over 2 plus c. And this is the solution to the integration question that we are asked to solve. So here in question number 11, WAEC 2018 further mathematics theory paper, we are told that the binomial expansion of 2 minus 1 over 2x raised to the power 5 is to be written out in ascending power of x, and then we use the expansion in that question to find the value of 1.99 raised to power 5. Now, there is a general rule of thumb when it comes to working with binomial expansion. Say, for example, we have a plus b raised to power n. What we do when we want to find the binomial expansion is to find the n combination 0 multiplied by a raised to power n, b raised to power 0, and then plus n combination 1, a raised to power n minus 1, b raised to power 1, plus n combination 2, a raised to power n minus 2, b raised to power 2, and on like that. Now, what we need to note is that from the first entry, we are having a raised to the highest power and b raised to 0, and then subsequently the powers of a will be reducing while the powers of b will be increasing. So a start from n to n minus 1 down to 0, b start from 0 to 1, 2, up to n. And then having this as a general expression for the binomial expansion, we can go ahead and say we want to work with our 2 minus x over 2 raised to power 5. In this case, this will be 5 combination 0, 2 raised to power 5 multiplied by minus x raised to power over 2 raised to power 0 plus 5 combination 1, 2 raised to power 4 minus x over 2 raised to power 1 plus 5 combination 2, 2 raised to power 3, we are reducing the power, minus x over 2 raised to power 2, we are increasing the power. Now, the mistake that students normally do is that when we are working with the minus x over 2, we tend to forget the negative sign and we just write x over 2. And right from the beginning, we're already getting our question wrong. So if we continue correctly, the last term will be 5 combination 5, 2 raised to power 0 minus x over 2 raised to power 5. Now we need to note, how do we find the expression for combination? How do we find the expression for combination when we are working with all this? That's number one. And then any number raised to power 0, we should know that it is 1. So for 5 combination 0, 5 combination 1, 5 combination 2, formula 2, up till 5 combination 5, we can actually find the general formula n combination r to be n factorial over r factorial multiplied by n minus r factorial. And if we plug in these values, we are going to be getting the values of each of those combinations. Like 5 combination 0 will be 5 factorial over 0 factorial 5 minus 0 factorial. Now that will be 5 factorial over. Now 0 factorial is actually 1. 5 minus 0 is 5. So this will give us 5 factorial can cancel out. So we have 1 over 0, and any number divided by 0 is 1. So we have our value for 5 combination 0. Then we can move ahead to evaluate 5 combination 1. Here we have 5 factorial over 1 factorial multiplied by 5 minus 1 factorial. If you want to express this, when we say factorial, it means multiply by the descending numbers up till 1. So we have 5 times 4 times 3 times 2 times 1. But I know that 4 factorial will cancel out, so I can stop at 4 factorial. All divided by 1 factorial. 5 minus 1 is 4 factorial. So my 4 factorials will cancel out, and this will be 5 divided by 1, which is 1. As interesting as evaluating this combination expressions can be, there is also another method that we can use, and it is referred to as a Pascal's triangle. Now, the Pascal's triangle is taking the powers of, like the expression we're having, a plus b, starting from 2, is taking the power of the expression a plus b. Let's say when the degree is 1, of course, we have that is only a and b. The coefficient of a is 1, the coefficient of b is 1. Now, when the degree is 2, what we do is we add these two ones, 1 plus 1 is 2, then we put the ones at the edges. And continue like that, we'll have 1 plus 2 is 3, 2 plus 1 is 3, 1 at the edges, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and the 1 at the edges, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, with the ones at the edges, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and 1 at the edge. Now, these correspond to the coefficient of our variables in increasing powers of n. So when the degree is 2, 3, when the degree is 4, these are the coefficients, and when the degree is 5, which we are concerned about here, these are the coefficients, meaning that each of these coefficients corresponds to our n combination r. So like for the first one, 1 is 5 combination 0, 5 combination 1 is 5, 5 combination 2 is 10, 5 combination 3 is also 10, 5 combination 4 is 5, and 5 combination 5 is 1. So from our question, we can say we want to be evaluating the values of the combinations, but knowing Pascal's triangle, I can easily plug in the value of the coefficient of the two entries that we are trying to find the binomial expansion. So for this power 5, we have 1, 5, 10, 10, 5, and 1 as the coefficient of the values. So here we have 1 multiplied by 2 raised to power 5 multiplied by minus x over 2 raised to power 0 plus, now the next coefficient is 5, so I have 5, 2 raised to power 4, reducing the power now, minus x over 2 raised to power 1, increasing the power of that second entry, plus the next coefficient is 10, multiplied by 2 raised to power 3 minus x over 2 raised to power 2 plus 10 multiplied by 2 raised to power 2 multiplied by minus x over 2 raised to power 3. You can notice the increasing powers of x minus x over 2 and the reducing powers of 2. So now the next entry is 5 multiplied by 2 raised to power 1 now multiplied by minus x over 2 raised to power 4. Then the last entry is 1 multiplied by 2 raised to power 0 minus x over 2 raised to power 5. And with that, so this is the binomial expansion of the expression we are asked to find. And if you are to go ahead to work this out, 2 raised to power 5 is 32. Any number raised to power 0 is 1. So we have plus 5. 2 raised to power 4 is 16. Now, when we raise the negative power to an odd number, it will always be negative. So it will be minus x over 2. And if you cut, 2 can go in 16. The next variable, 10 multiplied by 2 raised to power 3 is 8. Now, when we raise a negative number to an even power, that will be positive. So I have x squared over 2 raised to power 2 is 4. We can also cut 4 in 8 is 2. Then plus 10, 2 raised to power 2 is 4. Again, we are raising a negative number to an odd number. That will be minus x raised to power 3. Then 2 raised to power 3 is 8. So 4 can go in 8. 4 here 1, 4 here 2. 2 can go in 10, 2 here 1, 2 here 5. Then the next time plus 5 multiplied by 2. Now this will be x raised to power 4 over 2 raised to power 4 is 16. 2 can cut 16. We have 8. Then plus 2 raised to power 0 is 1. But we are having minus x over 2 raised to power 5. That will be minus x over 5. Minus x raised to power 5 divided by 32 because 2 raised to power 5 is 32. So we have to multiply out this expression that we now have. What we are going to get is 32 plus 5 times 8 is 40. But we have minus x, so minus 40x, multiplying that 40. Then plus 10 times 2 is 20 and our x squared. Now we have minus 5s cubed because 5 times minus s cubed is minus 5s cubed. The next time will be positive. This will be plus 5 over 8 multiplied by x raised to power 4. Then minus x raised to power 5 divided by 32. And our question had been solved in ascending powers of x. We have been able to evaluate 2 minus x over 2 raised to power 5 in ascending power of x from 0, 1, 2, 3, 4, and 5. And that is solution to our A question. Note, we are to find the expression 1.99 raised to power 5. Now, what we need to note is that to use the previous binomial expansion that we are given, we need to express 1.99 as 2 entries that we are subtracting one from the other raised to power 5. And we are to express that 1.99 can be expressed as 2 minus 0.01 raised to power 5. 2. So now if we are to compare this with 2 minus x over 2 raised to power 5, we will notice that, of course, the first entry is 2, but then the second entry is minus 0.01 and minus x over 2, meaning that 0.01 is equal to x over 2, and our x will be 0.01 multiplied by 2, which is 0.02. Now, without expressing this like this, the student will just take the value of 0.01 and plug in into the expression we have before, and that will be quite wrong. It's not 0.01, it's 0.02. So 1.99 raised to power 5. Now, where we find x in our expression that we got before, we just need to plug in the value of 0.02. So we are going to be having The first entry is 32 minus 40 multiplied by 0.02 plus 20 multiplied by 0.02 raised to power 2 minus 5 multiplied by 0.02 raised to power 3 plus 5 over 8 now, the next entry, plus 5 over 8 multiplied by 0.02 raised to power 4 minus 0.02 raised to power 5 divided by 32. Now, for the observant students, the higher powers of 0.02 will tend to give us quite negligible numbers. But let's also bring in our calculator to see what we are going to get with these values that we are trying to plug in. So here, we have 32 minus 40 multiplied by 0.02. That will be 0.8. So 32 minus 0.8 plus 20 multiplied by 0.02 raised to power 2. That will be 8 times 10 raised to power minus 3. 8 times 10 raised to power minus 3 minus, now, 5 multiplied by 0.02 raised to power 3. That will be 4 times 10 raised to power minus 5. Now you can see that with subsequent values we are getting a large decimal place, and that will be quite negligible. The next entry, 5 divided by 8 multiplied by 0.02 raised to power 3 raised to power 4. That will be 1 times 10 raised to power minus 7. Now minus 0.02 raised to power 5 divided by, no. We are not dividing the power. We are bringing it down. This whole divided by 32. Okay. That will be 1 multiplied by 10 raised to power minus 10. 1 multiplied by 10 raised to power minus 10. Now, if you are to evaluate this and add up all this together, let's use our calculator also. If you are to add all this and express them in 2 decimal places, actually we will see that we'll have 32 minus 0.8 exponent 8, that's 8 exponent minus 3. That's this exponent expression. Eight exponent, okay, minus 3. No, we have to bring 4 down. Minus 3, 4, okay. Minus 4 times 10 raised to power minus 3 and minus 5. 0, 0. We can neglect the other ones because they'll be quite negligible. It will be just dot 0.00000 in 7 places, in 10 places. That is quite negligible. So if we sum everything, we are going to have 31.20796, and correct to 2 decimal places will be 31.21 as our answer. Now, just to be on the safe side, we can quickly check with our calculator what is 1.99 raised to power 5. That's 31.207961, and you can see that we're on the right track. That is the solution to our question number 11A. So now question number 11B, we are told that the polynomial that is given as s raised to power 3 plus q square plus rx plus 9 with p and r as constants, asks s minus s plus 1 as a factor and the remainder minus 17 when divided by x plus 2. We have to find q and r. Now, we are going to be using factor and remainder theorem. And the factor theorem states that if x plus 1 is a factor, then the function of minus 1 is going to be 0. And if there is a remainder, in this case, minus 17, if you have, say, minus 17 as a remainder, when we are dividing our polynomial by, in this case, x plus 2, then the function of minus 2 is equal to minus 17. Now, what you need to note, when we say x plus 1, when we factor, that means x plus 1 is 0, x is equal to minus 1. We find the function of minus 1. And when we say x plus 2 is used to divide the polynomial, that means when x is minus 2, like x plus 2 is 0, then x is minus 2. Function of minus 2 will give that remainder. These are the remainder and the factor theorems. And using this, we will see how we can solve this our question. So, let's go ahead and plug the value of minus 1 and minus 2 into our polynomial and see what we are going to get from there. So function of minus 1 will yield minus 1 raised to power 3 plus q multiplied by minus 1 raised to power 2 plus r multiplied by minus 1 plus 9, and we're saying it's going to be 0. So if you are to express this, in a negative number raised to power 3 will be negative, because 3 is an odd number. So we have minus 1. Minus 1 square is 1. 1 times q is q. R multiplied by minus 1 is minus r, plus 9 is 0. So we have q minus r is equal to minus 8, because minus 1 plus 9 is 8. When it crosses to the other side, is minus 8. We have equation 1. Then function of minus 2, let's use minus 2 in the expression. Minus 2 raised to power 3 plus q multiplied by minus 2 raised to power 2 plus r multiplied by minus 2 plus 9 is now going to be our remainder, minus 17. And that will give us minus 8 plus 4q plus minus 2 raised to power 2 is 4. 4q minus 2r plus 9 is equal to minus 17. So here we are having 4q minus 2r. Minus 8 plus 9 is 1. When 1 moves to the other side, it will become minus 1, minus 17, minus 1. We have minus 18. So this, I can divide all through by 2, so that I have 2q minus r is equal to minus 9. So this is my second equation, equation 2. All I need to now do to resolve this question is to find the solution to these two equations, these two simultaneous equations, and then my answer is out. So if I want to write out this, I can clear my board. I have q minus r is minus 8 and 2q minus r is minus 9. I can use any method. Let me say from equation 1, I will say that now I can get my q to be minus 8 plus r, and if I'm to use that new equation in equation 2, if I'm to use q is equation minus 8 plus r in equation 2, I will have 2 into minus 8 plus r minus r is equal to minus 9. 2 times minus 8 is minus 16, plus 2 times r is 2r, minus r is equal to minus 9. So, because 2r minus r is r, when minus 16 moves to the other side, that will be plus 16. R will be minus 9 plus 16, and that will give 7. So the value of r is 7. And then if I want to use the value of r in q, in the expression for q, I can also find q, because my q is equal to minus 8 plus r. That means q is minus 8 plus 7. And that means q is minus 1. So the values of q and r that we are asked to find is that q is minus 1 and r is equal to 7. So here, question number 12 from WAEC Further Maths 2018 May-June exam. We're given these statistics of the 10 coins that were tossed, the number of times and the outcomes that we have. And we're asked to calculate the mean number of heads, probability of getting an even number of heads, and the probability of getting an odd number of heads. Now, we know that mean is sigma fx divided by sigma f. That is the sum of the product of the frequency and the particular statistics, here the number of heads, divided by the sum of the frequency. So if you are to draw our table to get the value of the number of heads multiplied by the frequency, our number of heads will be denoting that with x and the frequency with f. So if we populate with the information that we are given is the question, we can go ahead to find the value of fx. 0 multiplied by 2 is 0, 1 times 7 is 7, 2 times 23, 46, 3 times 36 will be 108, 4 times 11 is 44, 5 times 61 is 305, 6 times 100 is 600, 7 times 12 is 84, 8 times 8 is 64, 9 times 5 is 45, and 10 times 3 is 30. So we can go ahead to find the sum of our frequency and the sum of fx. Now, summing that, let's bring in our calculator so that we don't make any mistake. Let's bring in our calculator. We want to sum the frequency and fx. So we have, for the frequency, we are going to be having 2 plus 7 plus 23 plus 36 plus 11 plus 61 plus 100 plus 12 plus 8 plus 5 and plus 3. So the sum of the frequency is 268. Is 268. Then we want to sum fx. We want to sum the product of the frequency and our data. We have 0 plus 7 plus 46 plus 108 plus 44 plus 305 plus 600 plus 84 plus 64 plus 45 plus 30. Okay, that's 1333. 1333. So using this information that we got from our table, we can find our mean to be 1333 divided by 268. And if we divide that, our mean, the mean number of heads will be 1333 divided by 268. That is 4.973888. Now that line is telling us that it's a continuous loop, just like you are dividing 3 over 10. You know, you have .33333. So this is a continuous loop, and we can put in our value. But in our question, we're asked to find it correct to 3 decimal places, so we can just stop at 4.974. Okay, good. So here, if you want to find the probability of getting an even number of heads, now, what is the definition of the probability? Generally, probability we can define as the number of our desired outcomes, the number of the possible desired outcomes, all divided by the number of the total possible outcomes. Probability can be defined as the number of our desired outcome divided by the total possible outcome. And now, our desired outcome from this particular question, we are looking for the even number of heads. The even number of heads. We need to know that so that we can identify them appropriately. And then since we have the frequency, we actually add all those frequencies and divide by the total frequencies. So here, to identify our even heads, we have 0, 2, 4, 6, 8, and 10. These are numbers that can be divided by 2 without having any remainder, and 0 is included. So the probability of the even number of heads we are looking for will be 2 plus 23 picking the frequency of the even numbers plus 11 plus 100 plus 8 plus 3, all divided by the total number of frequencies here, which is 268. And if we add that, we can bring in our calculator to add this. We have 2 plus 23 plus 11 plus 100 plus 8 and 1 plus 3. So that will give us 147. We have 147 divided by 268. If we divide that with our calculator, that will give us 0.54851, 0.5485. But now we're asked to get our answer correct to 3 decimal places. So that will give us 0.549, because 5 will round up to 1 and we add that to 8 and our answer is out. Okay. And now finally from this question number 12, we're asked to find the probability of getting an odd number of heads. So the probability of the odd, if you also identify the odd numbers, since we identified the issue of the even numbers, we'll have this as the frequency of the odd numbers, frequency of getting the odd head, all divided by the total frequencies. Now, the odd heads, if you are going to identify them, we have 1, 3, 5, 7, and 9. So if you add the frequencies of these, that will be 7 plus 36 plus 61 plus 12 plus 5, all divided by 268. So to add that in our calculator, we have 7 plus 36 plus 61 plus 12 plus 5, and that is 121. So we have this to be 121 divided by 268. If we divide that again using our calculator, we are going to get 0.45149, 0.45149, and rounding it up to 3 decimal places, we are going to get this as 0.451. Now, what the student needs to know is that at least we are able to identify that 0 is an even number, and with that we can always move ahead to solve our questions. Question number 13, we are given the probability of Ali, Baba, and Katie gaining admission to their college, and then we are to find the probability that only Katie and Baba will gain admission, none of them will gain admission, or at most 2 of them will gain admission. Now, if you want to take all these statistics that we are given, and starting with Ali, like given that the probability that Ali will gain admission, if you call it PA, that will be 2/3 as given. That implies that the probability that Ali will not gain admission, we have been given the probability that he will gain admission, that is 2/3. That means that inherently the probability that Ali will not gain admission will be 1 minus probability that he will gain admission, and that will be given as P prime A will be 1 minus 2/3, and that is 1/3. Subsequently, we can also find the same expression for the case of Baba and the case of Katie. So the probability that Baba will gain admission, if we also call that, let's say we are using the first letter of his name, probability of B, that will be 3/4. Therefore, the probability that Baba will not gain, P prime B, will be 1 minus 3/4, and that will be 1/4. So moving on to Katie, we can also find this expression for Katie, we've been given that the probability that Katie will gain admission had been given for us as 4/5. So we can write it out that probability that Katie will gain admission will be probability of K, which is 4/5. So the probability that Katie will not gain admission, P prime K, will be 1 minus 4/5. And that will be 1/5. So having this, we can now go ahead to solve the 3 questions that we are asked in this probability question. And the first one is saying that what is the probability that only Katie and Baba will gain admission? Now we need to interpret this question correctly so that we don't miss it. We are being asked the probability that only Katie and Baba will gain admission. Now we have 3 personalities that we are talking about, but we are being told that it's only Katie and Baba that will gain. That will imply that Katie will gain admission, Baba will gain admission, but Ali will not gain admission. You know, there are 3 of them. We have Katie, Baba, and Ali. So we are looking for the probability that only Katie and Baba will gain. That means that Katie will gain admission, and at the same time, Baba will gain admission, and also at the same time, Ali will not gain admission. So we have, this implies that Katie gains, Baba gains, and Ali did not gain. And since we found the expression of these probabilities, we can input our value, and in the case of hand, we use multiplication. So Katie gains is probability of K, which is 4/5. Baba gains is probability of B, which is 3/4. Then Ali fails is P prime A, which is 1/3. Now dividing, we can cut 3 out, can cut, and 4 can also cut. This will leave us with 1/5. So the probability that only Katie and Baba will gain admission is 1 divided by 5. Now I want to look at the probability that none of them will gain admission. The probability that none of these 3 personalities we are looking at will gain admission. Now that will mean that Baba fails, Ali fails, and Katie fails. And that will be P prime A multiplied by P prime B multiplied by P prime K. These are the probabilities that each one of them will fail. So none pass means that each one of them fails, and that will be 1/3 multiplied by 1/4 multiplied by 1/5. And if you multiply that, 3 times 4 is 12, 12 times 5 is 60. We have 1/60. Okay, good. And now, on the last note, we want to find the probability that at most 2 of them will gain admission. Now, this is quite interesting for me. What is coming to mind? What can we interpret with this statement that at most 2 of them will gain admission? I want to encourage students out there that you need to work smart. When you are listening and you are hearing the word at most, you are reading, you are seeing at most, what interpretation comes to mind? Now, the danger is that you want to start writing out all the possible probabilities that will culminate in at most 2 of them gaining admission. But we need to work smart. So if you want to work smart, what do we need to do? Now, inversely, if you are being told that at most 2 of them will gain admission, the only exclusion to that case in all of the possible outcomes is that all of them will not gain the admission. So this question that we are being told that at most 2 of them will gain admission, it will involve all the possible cases except when the 3 of them gains admission. So we can look at all the combinations that maybe Ali gains, Baba gains, Katie fails, Ali fails, Baba gains, Katie gains, Ali gains, Baba gains. You know, all those on. But no. You don't need to stress yourself like that. This is going to be all possible cases except when the 3 of them gain admission. And that will be 1, which is all possible cases, minus the scenario in which all of them gains, which is probability of Ali multiplied by probability of Baba multiplied by probability of Katie. I hope the student out there can get to grasp this and understand it. So this will be 1 minus probability of Ali is 2/3. Probability of Baba is 3/4. Probability of Katie is 4/5. And if you are to divide and cut out, 3 will cut out, 4 will cut out. So we have this to be 1 minus 2/5. And that is equal to 3/5. Wow. Good. So what I want to encourage students is, whenever we are working with questions like this, don't just rush in to try and doing the possible outcomes. First, interpret the question well, and you can easily get your answer smartly. So here in our question, we are given the position vectors of points A, B, and C, and then we are told that A, B, C, and now another new point N, they all constitute a parallelogram. We have to find the position vector of N. We have to find the magnitude of AN and the magnitude of vector AB. Then we have to find the acute angle between vector AN and vector AB. Now, a good overview of our vectors before we go ahead to launch into this video. Normally, when we are talking about vectors, we are talking about a quantity that has both direction and magnitude. So, if you are to draw our vector components, component I and component J, now let's take that. Let's assume that we are looking at two position vectors A and B. For us to get to A, we can actually go through directly from the origin. You can go from the origin to A. Can go from the origin to A, and let's call that vector A, small letter A. We can also go from the origin to B. Let's call that vector B, small letter b. Then, of course, we can also move from the point capital A to point capital B. Okay. Let's call that's another vector. That's vector AB. Now, looking at point B, if you want to navigate from the origin, there are two paths that we can actually go through. Is either we go through first the small letter A, then from the capital letter A to the capital letter B, or we go directly from the origin and go through small letter b. That means that to get to point B, we can go through A plus AB, or we can go through B, and meaning that our AB will be B minus A. Now, this will help us a lot in trying to work with our vectors, that vector AB is position vector of B minus the position vector A. This will help us to actually solve our question. So, having this understanding, let's go ahead and try and estimate what we can get with the question we are being asked. So if I have my graph here calibrated in 2 units, I can represent all the points A, B, C that have been given in the question. So now A is 8i and minus 10j. So taking that in 2 units, 8 will be in 4 places, minus 10 in 5 places. So I have A as 8i minus 10j. I can go ahead to locate my B. B is 2i plus 6j. So 2i, 2 and 6j, 3 places, okay? That will be B, point B, 2i plus 6j. Then let me also go ahead to locate the point C, minus 10i. Minus 10i will be to the left, and then 4j will be on the upper part. So I have my C to be minus 10i plus 4j. Now, we are told that if we include another point N, we are going to have a parallelogram. Now, a parallelogram, by our understanding, is a shape that has both of its two sides parallel to one another. So, if we are to join these points that we have already, point A, B, C, if you are to join these points A, B, and C, we can go ahead to say we want to find another point N that will be parallel to these two lines that are being drawn in green. Now, these are two sides of the parallelogram. The other two sides are going to be parallel to each of these sides. So we have another side will be parallel to CB, and then another side will be parallel to AB. Now, just by looking at the symmetry of this diagram, we can see that the distance between point B and C, looking vertically, is only 2, and then the offset between B and C, looking horizontally, that will be 12. That will be 12. So this displacement 2 and 12, we can also replicate at the base of the diagram. So from A, we replicate a distance of 2 units down the graph, and then from A also, we can replicate a distance of 12 units to the left of A, and that will give us the point N as an estimate of what we are trying to get. So now, doing that, I can actually draw my parallelogram and complete my diagram like this. Now, this is point N that I am asked to find. I'm using this as a guide so that whenever I'm working, I can know that this is the estimate of what I want to get. And if you look critically, this point N will correspond to minus 4i minus 12j. I don't think WAEC will accept this as a means of working for us, but actually this is correct. We are going to work it out mathematically, not on the graph. And if you see, our parallelogram is out already, and I have an idea of what my position vector N is going to be. So having this understanding, I can go ahead to work, but then there is a rule of thumb for me to know. If I can get my N, I can also get the angle theta between vector AN and vector AB as shown in the diagram. Now, another point for me to know, if I'm talking about, in the question B, they are talking about AN and AB. Okay, now from this diagram, vector AB and vector NC, they're actually equal. Now, the magnitude is equal and the directions are equal. And AB will be B minus A, and NC will be C minus N. From the first postulate we are trying to clarify in our work here in this video. Or we can also use vector AN, which is also parallel to vector BC. So vector AN is also equal to BC. They are parallel, they are equal in magnitude, they are going in the same direction, and so those two vectors are equal. We can use either of these two expressions, B minus A is equal to C minus N, or N minus A is equal to C minus B, to find the value of our N. So with this, as a basic understanding of how to work with our vectors, we can go ahead to question number A. So in question number A, we are asked to find the position vector of N, and N is a point that renders our parallelogram to be complete. So already we have A, B, and C. Then we are looking for the fourth point N that will render our shape to be our parallelogram. And like I explained before, vector AB is the same as vector NC, and alternatively I can say vector BC is also equal to vector AN. Now, because these constitute a parallelogram, you can pick any of these two and work with it to get the value of the position vector of N. Now I'm going to take vector AB is equal to vector NC, but for my N, I need to also define its components. Y, let's say I take vector N as xi plus yj, meaning that my N is equal to xi plus yj. So now I can find the value of AB, which will be B minus A, and NC, which is going to be C minus N, component wise. So going to that component wise, I can now say my AB, vector AB, I want to use vector AB and equate it to vector NC. So I can say that means that the position vector B minus A is equal to the position vector C minus N. B is 2i plus 6j, A is 8i minus 10j, C is minus 10i plus 4j, N is xi plus yj. So I can go ahead to plug in all this. I have 2i plus 6j minus A is 8i minus 10j. This is equal to my C is minus 10i plus 4j, and N is xi plus yj. Okay, good. Now I can open up the bracket and collect like terms and bring the I components together, bring the j components together. So I have 2i minus 8i plus 6j minus 10j. This is equal to minus 10i minus xi plus 4j minus yj. Now 2i minus 8i will give me minus 6i. 6j minus 10j will give me plus 16j, because the negative signs will multiply each other to be plus. Minus 10i minus xi will give me minus 10 minus x all into I. Then the other will give me, that will give me 4 minus y all into j. And now looking at the left hand side and the right hand side, I can equate the components of I and also equate the components of j. If I want to collect the like terms for the component I, that means that minus 6 is equal to minus 10 minus x. And for the component j, that means 16 is equal to 4 minus y. So looking at the I component, minus 6 is equal to minus 10 minus x. And then if I'm to solve for x will be minus 10 plus 6, and that will be minus 4. And also for the y component, I will have 16 is equal to 4 minus y, so that my y will be 4 minus 16, and that is minus 12. So since I've defined my n as xi plus yj, that means the value of my n is coming out from here. I can say my n is equal to minus 4i minus 12j. And like that, I've been able to get the position vector of n that constitutes our diagram to be a parallelogram. Okay. So now we are asked to find the magnitude of the vector an and the magnitude of the vector ab. Now, how do you go about finding the magnitude? Knowing that initially we are only given the position vectors, but now we are being told to find the magnitude of the vector an. How do we express the vector an? Again, like I explained before, an will be the position vector n minus the position vector a. So an first is n minus a. So now we have n, we just evaluated the value of n to be minus 4i minus 12j. And then we have a, we are given a in our question to be 8i minus 10j. So if you are to open up this bracket, that will be minus 4i minus 8i, then minus 12j minus 10j. Now, the student should not forget all those signs. This will now constitute minus 12i. The negative will multiply each other to be plus. So we have minus 12j plus 10j, and that will be minus 2j. This is vector an. And now the magnitude of an will be, the magnitude is just something similar to the hypotenuse of a right angle triangle, and that will be the square, the sum of the square of the components will find the square root, and that will be square root of 144 plus 4. which will be square root of 148. So similarly, we can also go ahead to find the magnitude of the vector AB. Just as we did for vector AN, we can go ahead to say vector AB. To find its magnitude, first we need to find an expression for vector AB, and that will be position vector B minus position vector A. We are giving B to be 2i plus 6j, so that will be 2i plus 6j, minus, we are giving A to be 8i minus 10j. So going ahead to open the bracket, that will be 2i minus 8i plus 6j minus 10j. Don't forget the negative sign. Alright, so this will be 2i minus 8i will be minus 6i. Then 6j will be plus 10j, which is plus 16j. And from here we can go ahead to find the magnitude of the vector AB, and that will be square root of minus 6 square plus 16 square. That will be square root of 36 plus 16 is 256. So we have that as a square root of 92. Yes, so that's the magnitude of vector AB. Now we are through with our question B. We can now go ahead to say we want to find the acute angle between AN and AB. To find the acute angle between vector AN and vector AB, how do we go about that? The dot product of vectors is the tool that we can use to determine the angle between two vectors. And what is the expression of the dot product of vectors? The dot product of vectors is telling us that we can find an expression for the dot product by saying, let's say we want to consider vector AN and vector AB, as in the case in this question, then the dot product will be vector AN dot vector AB is equal to the magnitude of vector AN multiplied by the magnitude of vector AB multiplied by the cosine of the angle between the two of them, cos theta. Now, this is actually an offshoot of the parallelogram law of vectors, or the parallelogram law generally. And from here, we can say that cos theta is AN dot AB all divided by the magnitude of AN multiplied by the magnitude of AB. Now, remember, we have gotten the magnitude of AN and the magnitude of AB. So if we are to bring in our vectors, that will be minus 12i minus 2j multiplied by AB. AB is, we have gotten it initially in question B, minus 6i plus 16j, all divided by the magnitudes that we got initially, square root of 148 multiplied by the square root of 292. So now, how do we find this dot product on the numerator? What we do is we take the components, like the I component, we multiply them together, plus the j components, we also multiply them together. So going ahead with that, we can have our cos theta to be equal to, now we have the I component minus 12 multiplied by minus 6 plus the j component minus 2 multiplied by 16, all divided by square root of 148 times square root of 292. Now, minus 12 times minus 6, the negative will become plus, so we have 72. Minus 2 times 16 will be minus 32, divided by 148 multiplied by 292. 72 minus 32 will be 40, and we have 40 over square root of 148 times square root of 292. Let's bring in our calculator here. and try and find this expression. So we have 40 divided by square root of 148 multiplied by square root of 292. That is equal to 0.19241. Okay, that's 0.19241. Now that is cos theta. That is cos theta. So our theta will be arc cos 0.19241. So we can also bring in our calculator to find that expression. Arc cos, our answer, that will be 78.90627. So we have this as 78.906. So, but we are asked to find our answer correct to 2 decimal places. That will be 6, we round up to 1. We add 1 to 0. That will be 78.91 degrees. So that is the angle of that's the value of the acute angle between vectors AN and vector AB. So here we have this question number 15. A uniform beam XY, which is 4 meters long and weighing 315 Newton, rests on 2 pivots P and Q, and it is kept in equilibrium by weight of 80 Newton and 1000 Newton attached at some point. Then we are to calculate the reactions at point P and Q, and then if the weight is the 1000 Newton weight is replaced with 1200 Newton weight, at what point from Q should it be placed to maintain equilibrium? Now, interpreting this question will help us a lot to try and solve it. So if you have our uniform beam XY, now its own weight will act at the middle, at the center of the beam, because we are told that it's a uniform beam. So the weight will be evenly distributed, and we can take it at the center, that's 350 newtons. Then we're also told that it is kept in equilibrium by another weight of 80 Newton, which is at point X. So if you go to point X, here we have 80 Newton weight being placed there. Then there's another 1000 Newton attached at a point between P and Q, such that it is 0.6 meters from Q. Now we are told that XP, okay, we have pivots at P, and we have been given XP to be 0.8 meter. Now between X and 350 Newton there is 2 meters, because the whole meter is 4. The whole beam is 4 meters. So here between X and P we are going to have 0.8 meters, and then so let's label that as this is 0.8 meters between X and P, 0.8. Then we know that if that is 0.8 and half of the beam will be 2 meters, that means between P and the center of the beam we have 1.2 meters. But we are told that PQ, the 2 pivots PQ, are spaced 2.2 meters afar. Now we have taken 1.2 meters between P and the center of the beam. Then this other distance between the center of the beam and the point Q will be 1 meter, so that 1 and 1.2 will amount to 2.2 meters as we are given. Okay. Now, doing all this will actually help us seriously, and furthermore, we are told that the 1000 Newton is placed 0.6 meters from Q. Okay, so from Q, what we need to measure is some 0.6 meters, and then we can put in our 1000 Newton weight. So our 1000 Newton weight will be somewhere around here. All right. So now, interpreting the question like this had helped us a lot in solving for the distance that we are going to be finding our product of momentum from, so that now, once we have all this, at the pivots, there will normally be some reactions. There will be a reaction at P, there will be another reaction at Q. And we can check for the distance between all this. Now, we've been told that P and Q is 2.2 meters. All right. So, if we are to go ahead to try and complete our diagram by noting the reaction at P, let's call that RP, and the reaction at Q, let's call that RQ. Two principles are going to be guiding us, and this will help us in solving our question easily. Now, the first principle is that the sum of the clockwise moment is equal to the sum of the anti-clockwise or counterclockwise moment. So, if you are summing clockwise moment being denoted like CW clockwise and the counterclockwise CCW, the sum of those moments are going to be the same. Then for equilibrium, the sum of the upward forces is also going to be equal to the sum of the downward forces. Here we are seeing that some forces are going down, the 80 Newton, 350 and 1000 Newton, while we have some reactions at pivot P and Q. Those are the upward forces. So using these two principles, our questions will be easily solvable whenever we apply these principles. So we can go ahead to try and find the solution to question number A. So now we can go ahead to solve our question number A, in which we are asked to get the reactions at point P and Q. So now from the diagram as indicated, we have RP and RQ as the reactions at these 2 points P and Q. So if we are to take the moment about point, let's say point P, we can find the clockwise moment and then the counterclockwise moment, and equating them, we'll be able to solve for one of these reactions. So now, looking at point P, if we want to find the moment about point P, we should recollect that the formula for finding the moment is force is the product of force multiplied by the perpendicular distance in which the force is acting upon. Not just the distance, it's the perpendicular distance. So here, you can look the moment using the principle of counterclockwise moment is equal to the clockwise moment. We can look for our clockwise and counterclockwise moment. Our 80 Newton will be a counterclockwise moment around P. 350 and 1000 Newton weight will be clockwise moment around P. Then the reaction at RQ will be a clockwise moment. There won't be any reaction at P because that's the point where we are taking our moment from. So summing these clockwise and anti-clockwise moments, we can equate them together to try and see how we can solve for, in this case, the reaction at Q. For our clockwise moment, the distance is 2.2 for RQ plus 80 times the distance between that 80 Newton force and P is 0.8. This will be equal to our 350 weight multiplied by the distance between 350 and P, which is 1.2, plus our 1000 Newton weight multiplied by the distance between that weight and point P, and that will be 2.2 minus 0.6. So that will be 1.6. 1.6. So now that is telling us that 2.2 multiplied by RQ will be, now bringing our calculator, we have 350 times 1.2 plus 1000, that 1000 times 1.6 is 1600, minus, when the 80 multiplied by 0.8 move to the other side, they will become minus 80 times 0.8. This will give 1956. Okay, 1956. such that our RQ will be 1956 divided by 2.2. So divided by 2.2. This will be 889.09 newtons. 889.09 newtons. So that is the reaction at point Q. Now, for us to get the reaction at point P, instead of going all the way and taking the moment around point Q now, we can just use the other principle, the sum of the upward forces and the sum of the downward forces. So RP plus RQ, which are the upward forces, if we sum them, they're also going to be equal to 80 plus 350 plus 1000 newtons, which are the downward forces. Now we have gotten our RQ already. So RP will be 80 plus 350 is 430 plus 1000 is 1430. But I want to write that out minus RQ. RQ is now 889.09 newtons. So this will be, let me bring in my calculator again. Okay, 80 plus 350 plus 1000 minus 889.09, 540.91. So reaction at P is 540.91 newtons. And with that, we have been able to solve question A. Now, for us to solve this question number B, in which the 1000 Newton weight is being replaced with a 1200 Newton weight, and we have to find the distance from Q where that force will be placed. Now we have our 1200 Newton weight being included, and we are looking for the distance between this and Q, which you can tag as X, and then we have to find the value of X. Now, what we need to note, which students will generally make a mistake of, is to think that the reaction at point P and the reaction at point Q, they are still going to be the values that we got in question A. But no, that would be quite wrong. Because we are changing the value of the 1000 Newton, that means that the reaction at P and the reaction at Q, they will also change. So RP and RQ will change, since the 1200 Newton is now replacing the 1000 Newton that we are using before. Now, if you look at the question, it will look as if the information we have is not sufficient for us to calculate the distance as being requested. That means we are going to leave our question in the form of RP and RX. So if you bring in our direction of moment, now we want to take moment about point Q, which will be the one that will be suitable for us to get distance X. We take the moment about point Q. Okay, let's find the moment of all the forces operating at point Q. We can't use the previous ones, so we can erase our moment. Let's erase this. Now, this direction now, in this case, at point Q, the 350 Newton will go in the counterclockwise, and the same with the 1200 Newton, but the reaction at P will go in the clockwise direction. The distance between P and Q now will be 2.2, which will be the distance for RP. Then we know the distance for 350 Newton. We don't know the distance only for the 1200 Newton weight. So this will be counterclockwise, 1000 Newton counterclockwise. Then the reaction at P is the only clockwise moment. So taking our clockwise moment, 2.2 multiplied by RP will be now 80 multiplied by the distance between 80 and Q is 3, 0.8 plus 2.2, then plus 350 multiplied by its distance to Q, that will be 1, because we have 2.2 minus 1.2, that will be 1, then plus the 1200 Newton multiplied by the distance we are looking for, which is x. So with this, you can easily say that our 1200x will be 2.2 rp minus 80 times 3 is 240. Then 350 times 1 is 350. So that will give us 2.2 rp minus 590. Okay, if we divide through by 1200, our x will be 2.2 rp minus 590 divided by 1200. That will be the solution to our question. Don't forget, it is that we are not using the value of rp that we got in the previous question A. Now the reaction will change and we don't have enough information to evaluate that, so we leave it as rp.